Yeah, I don't know why people are all enamored by MIT people. Hold on, let me find the video. Dude's like, I got a 5-point frickin' I graduated with a 4.0 average from MIT and I'm stupid. It's fucking funny, dude. Because the way MIT is structured is that if you're like failing the class or if you're not doing good, right, where you're gonna get a C or a D, you can switch it to pass fail. You could switch your
Oh,
grade
yeah, in the middle, like, while you're taking
yeah,
it. Mhm.
yes, and you can switch it to pass fail, and then if it's pass, that counts as like a 5.0 or 4.0 rather. Yeah, dude.
Oh,
Is
Rusty
this why
P
we're
thinks,
ending up with doctors that use ChatGPT?
yeah.
Probably.
Rusty P thinks we're trolling about the gas pressure gradient. Is that true, Rusty P? Is that what you think?
Depending on the picture that it was about, yes. There's no other way you can explain it without
you
trolling.
think they have a hard boundary? Is that your problem? Is that there's a hard boundary in their little atmosphere?
Yeah, I was just responding to a picture.
Yeah, that's what I'm talking about. Look at the picture, the one that says how.
Yeah, how like gas pressure exists to a vacuum.
Yeah,
there's no.
It's not meant to be a freaking graphical simulation of a gas pressure gradient in space, dude. It's just meant to get people to ask the question, how does it happen? To investigate.
Even then, it's still. It feels like a troll question because at this point, everyone should.
How is it a troll question?
Because I think everyone should understand that there is no vacuum next to gas pressure. The question itself is kind of a
There's no
question.
vacuum of outer space. Yes, I agree. There has to be a vacuum next to gas pressure. Has to exist.
Like it's
in the globe
like
model.
Vacuum. Yeah. Like a vacuum is kind of arbitrary. Like, you know, what we call
and why do we use? What is we using the word for?
That's kind of if you have a vacuum at home, is it like space?
This is like you're doing like a word context fallacy. We're not using it in that context.
Yeah, I understand that, but like, do you understand that if you go, like, if you increase in elevation, if you go up a mountain or something like that, that like the gas pressure reduces?
Yeah, we know that. Why is that?
And if you go higher and higher and higher and higher and stuff, like you just have like a gradient.
Okay, cool. Does it reduce to zero?
Not to like 0 point something.
It does it. Well, when does it get to zero? Because if your argument is like there's a gas pressure gradient and it tapers off, like when does it get to zero?
It doesn't have to go to zero. It doesn't ever get to zero.
So it stops at some point, right?
No, it doesn't stop at some point.
No, the gradient stops. It stops being a gradient at some point.
No, it doesn't.
So it goes to zero.
No, it does not.
Doesn't converge to zero at some point.
Not really, no. I don't think.
You know how gradients work, right? You start with some number, and then you have some other number, and it slowly tapers off to that lower number. What's the lower bound?
I mean, it's just completely different when we talk about.
See, this is the problem with making that silly argument that if it goes down, why doesn't it just keep going down? Because eventually you have to get to zero or some arbitrarily low number that you have no evidence for. And then I go, okay, where's the container there? Well, you can place that container boundary wherever you want, but because the gas pressure has to go down and stop at some point.
It doesn't have to stop. It can fizzle out.
Into what?
Into nothing. There's just
yeah, exactly nothing into absolute vacuum. Where's that?
Yeah, there doesn't have to be nothing at all, and there can still be some molecules that float around and shit. I just think
but then there
I'm
wouldn't be a
responding.
vacuum. Even one molecule, if there was
No,
one molecule in a
it's
fucking
close.
light year of space, that's still that's still a not a perfect vacuum.
Okay, but like who like you think that like a vacuum means only that there's completely nothing there. What scientist is actually like, or like who, like Neil deGrasse Tyson or whatever, is saying that there is absolutely nothing in space, like completely nothing.
Well, they make who cares what he says, because they make illogical, inconsistent, and contradictory arguments. Okay, they say there's a gas
But it
pressure gradient and it tapers down to some low value.
Yes,
But
exactly.
yeah, great, and that proves that space exists because
No, it doesn't prove it doesn't prove that it exists. It only explains something that happens when you think about going, for example, up a mountain, for example, and you can use your mind to think about, okay, so
use your mind.
if I
don't want to use
yeah,
my mind, dude. I want to
you
use
don't want to
empirical evidence. That's what I want to use. So I don't have to
okay.
imagine shit.
Yeah, but if you stand on like sea level and then you climb up a mountain and the air gets thinner and
Great.
thinner and
That's
thinner,
descriptive.
the
That's
further you go,
great. When does it stop getting thinner?
it never really like it never really stops. Like at some point, it's so thin that yeah, it doesn't
Is that speculation, or
matter.
do you know that?
Well, it's yeah, I guess you can say a speculation from my own
Okay.
experience. Yes.
So the difference is you're speculating on when it should stop and when I think it should stop, right? You think it should never stop, even 100 trillion freaking light years away from Earth. There's still a continuing gradient.
No, because there are additional like points of information that you have.
Yeah.
Like it's not just only this one thing that you have like that. Yes, it gets thinner and thinner, but it's like you're a
the major
fucking idiot
problem
going.
the major problem that really exists is the fact that we can talk about it, but nobody can demonstrate it. Can't do this experiment, okay, and insert gas into a vacuum chamber, and the gravity of the Earth hold the gas away from the vacuum at the bottom of the vacuum chamber. Okay, that doesn't happen, but that's what they say is happening on Earth. And I could take my little vacuum chamber and stick it on the surface of the Earth where the gravity is the strongest, and it's not going to hold the gas from the top, away from the top of the chamber where the vacuum is, to the surface of the Earth. I'm not going to measure more gas molecules at the bottom because of gravity. There's no, like, it's easy to talk about, right? That, hey, we have some gas pressure gradient and it tapers off into whatever value you want to think, 10 to the negative 22 or for deep interstellar space. Great. That's fine. But experimentally, you can't demonstrate any of this shit. That's the problem. Because science, when you guys just keep
That what?
like, you guys really need to get this, and this is why you guys constantly get smashed by us, dude. I'm just being honest, is because science is empirical, and you can come up with all these hypotheses. You did say something empirical when you go up from the sea level to the top of the mountain, the gas pressure gets lower. So what? What is your evidence that it just goes down to some level that you can fly spacecraft in, or that there's fucking planets in fucking whipping around in a vacuum? Right? You see what I'm saying? Is this gas pressure going down? Either it goes down forever or it stops at some point, right?
Huh?
So it has to, but your position is never stops, it just goes down forever. Where does it stop?
Yeah, basically.
It goes down forever.
Kind of levels out at some point.
So we could just, so at some point, if we get far enough away, there'll be like 1 atom per cubic fucking light year. And then if we go fucking further away from that, there'd be 1 atom per 10 cubic light years. Right? Continually going down and down. Then 1 atom per 100 fucking cubic light years. That's all
Mm.
speculative. That's speculative nonsense. There's no evidence that it goes down forever.
There's evidence that it does go down.
Forever?
Doesn't have to be forever. Doesn't really matter
It does matter because then you're quibbling about where it fucking stops or not.
No, it doesn't have to stop. Like, what are you saying? Like,
Be-
there's like additional information that you have to take into consideration.
Yeah, that's what I'm taking into consideration. We're trying to figure out: is there a barrier? Is there a barrier that stops the gas from fucking off into some lesser thing region?
No, there is no barrier.
Why not?
There does not have to be a barrier.
Okay, can you demonstrate that in an experiment? That's your hypothesis.
Why
Rusty
would
P's hypothesis: we don't need a barrier. Okay,
no, there does
now
not have to be a
what's
barrier.
the evidence for the
between-
What's the evidence in the natural world for the hypothesis?
Okay, so you know wind, for example.
What's
You have-
the evidence in the natural world for the hypothesis?
Yeah,
What's the
gas
evidence the
pressure-
hypothesis is true?
One gas pressure amount, higher pressure,
Yeah,
another, a lower pressure being right next to it.
yeah. What happens?
What happens? Yeah,
Yeah,
wind.
the high goes to the low.
Yeah, wind happens.
Yeah,
Exactly.
thermodynamic systems try to reach equilibrium.
Yes.
Okay, really simple.
Well done.
Okay, so
Right.
why isn't the gas pressure on Earth trying to reach equilibrium with outer space?
Gravity.
Okay, can you demonstrate that hypothesis in an experiment?
Yeah, it can all depend. Like, bro. Like,
No, the hypothesis that gas pressure can be created by gravity.
Yeah, real life.
So you're going to affirm the consequent.
Like, what do you think? Is like, do you think that people figured out gravity based on gas pressure? That was the first thing that they thought. Oh, we can't
Dusty,
figure this shit out. But
they didn't figure out gravity, okay? There's two values. There's little g and big G, right? Little g we know empirically from just fucking dropping shit. But there's no evidence that gas takes little parabolic fucking arcs and falls back to Earth. And in fact, if you look in any
doesn't
textbook on the
have-
kinetic theory of gases, there's no little g in there predicting fucking gas molecules are taking parabolic arcs, falling back to Earth.
it doesn't have to. Like,
How do you
why
create gas
would it have to?
pressure? You just appeal to gravity.
Yeah. So what?
So say we got a gas molecule heading straight up.
Hmm.
What makes it come back down? What if it's at a 45-degree angle? Does it take a parabolic arc and fall back to Earth?
Can have depends on the energy that it has.
Okay, but at some point,
But,
right, it'll
we
fall
don't
back
have
to
to talk
Earth,
about
right?
the air
It doesn't
molecule.
have, but at some point though, it'll fall back to Earth, right? If gravity's affecting it,
Correct.
and it's not going to fuck off into the vacuum. The gravity is going to do thermodynamics. Now, this isn't in any theory of gas. This can't be demonstrated in a lab or any experiment. Like I said, Rusty, you can say stuff. You can say, yeah, gravity is what causes the gas pressure. But science is empirical. That is a hypothesis. Gravity creates gas pressure. Demonstrate your hypothesis is true in some fucking experiment. This is why you guys fail, because it always comes down to science is empirical. It's based upon tests in the natural world, And when we go do this test, what do you want to know what's going to happen? Where your hypothesis will be falsified.
That's so, yeah. Okay.
Yeah.
Like, wouldn't the
Get a
same
vacuum
thing apply
chamber,
to
put
you?
gas inside of it, measure gas pressure at the bottom and not at the top.
Okay.
You know that's stupid. You know that would never happen.
No, you don't. No, because you don't have to do that.
How are you
This
going
is
to
like some-
demonstrate? How are you going to demonstrate gravity creates gas pressure?
You take a sample, you measure gas pressure at the ground, at sea level, for example.
That doesn't give you the cause.
No, you don't have to measure the cost. Like, no people other than fucking flat
Then how do
earthers
we know it's
fucking could do
causing the
that.
gas pressure then?
You can derive information based on evidence.
Yeah,
No,
our
like, you
evidence
can-
is gas pressure, 15 pounds per square inch at sea level, some other value at the top of a mountain. How do we know what caused the difference?
Again, you can derive information from things you observe or measure. Like,
How-
it's if you like what?
Yeah,
Okay,
right. We
like,
have
okay, wait.
information. We have a bunch of data. We're taking the data and we're trying to interpret it and see what the data says and what it means.
Yes,
Okay.
okay.
We
let's-
know we've measured a pressure difference. We want to know why is there a pressure difference? Okay. What causes there to be a pressure difference?
Okay,
What
so
experiment can we do to see if things falling is the same cause as the gas pressure?
yeah, okay. So let's put it to the flat Earth side, maybe.
Oh no
And
no
say-
no 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 no
No?
no 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 no
There's
no
no
no no Rusty,
do it?
no.
You can't do it?
Stop.
Okay.
No, I'm being nice, dude. I freaking lucky I'm not screaming at you. Bro, you said gravity creates things falling. That was your demonstration. Your analogy.
That's my
Hey, if I
claim.
drop something that
Claim.
falls, that's what's creating gas pressure. The same thing that I dropped the freaking bowling ball, the same thing that made that happen creates the gas pressure. How do you know that?
That is a claim that I make, that when we see things falling and that we have a great pressure gradient in the atmosphere, that's a claim that I make. Okay, there's
You don't
gravity.
even know what causes the first one. How are you going to know that whatever causes that is the same thing that causes the second one?
Yeah, no, that is my claim, right? That's what I'm claiming. Now,
Huh?
if we have like a debate about whether the Earth is flat with the flat
Oh.
Earth model and stuff like that,
What
and
flat
I'm
Earth
making the
model?
claim, it doesn't matter the flat. I'm making the
What?
claim
Uh-huh.
that gravity is what's causing that. Now, if we are putting the two models side by side, like in a fucking Tekken universe versus shit, right?
Yeah.
Now, what causes this thing to happen, what we see in real life, whether the Earth is flat or not? What's causing things to fall down on the flat Earth? Or
Nobody
to
knows why
produce-
things fall, Rusty. Do you understand? You can say why all you want. Nobody knows why.
Okay, so
Do you think you know
can't,
why?
You can't make any
Neither
claim.
can you. You can claim you know why, but you don't. Because I can ask you one simple question. What was the experiment that determined the causal mechanism of a falling object? And you can't tell me one. Nobody can tell me one.
Yeah, I can tell you one.
Oh, okay. Tell me the causal mechanism of a falling object. Go for it.
You take an object, you let go of it, drops
Uh-huh.
it down to the ground.
Okay.
That's an experiment that you can make.
That's the effect. We want to know why.
Okay,
You just gave us the observed natural phenomenon.
Oh,
We want the
okay.
cause of it.
yeah.
You
I mean,
gave us a dependent variable. We want the independent variable, Rusty. The cause.
things of like things that have mass, right? Objects that have mass attract each other. Is that
Mhm.
enough? Probably not. Next thing would be
Because it's
because you have a
what did
Yeah.
I want? Because you're sitting here saying we like X causes Y. You don't have evidence for X causes Y. Okay. You're just saying I could just say the same thing you'd have, and same thing I could say. Well, it's magic freaking fairies with rubber bands that cause things to fall. I'd have the same evidence you do. Nothing.
okay. So the entire world is just
Who
fucking
cares what the
bumps
entire
up.
world thinks? I'm talking about evidence. I don't care what the entire world thinks.
Yeah,
If everybody
but
agreed there was magic fucking elf rubber bands, would you be in here fighting for that?
oh,
And I'd be, the whole world thinks it's magic elves with rubber bands. It's got to be true. The whole world thinks it. The whole world thinks a lot of stupid things. I wouldn't want to fucking place bets on what the mob thinks.
I understand that, but it's like the level of evidence that you require
It's a
is
co-
impossible.
It's no, it's not.
give
No,
to
no,
you.
no, no. It's a simple experiment.
It's not, apparently.
Yeah, because it's a shit theory. It's not even a theory.
What experiment would
Look,
you?
it is so in
what you
science, the
propose?
scientific method determines cause and effect relationships of natural phenomenon. Okay, you have independent and dependent variables. You very manipulate the independent variable and see the effect on the dependent variable. Your dependent variable is your observed natural phenomenon. Now we've known for fucking 200 years how to do the scientific method and figure out when we see a natural phenomenon if we can isolate the independent variable to figure it, we can even quantify it and come up with a law of nature, right? You don't have that for gravity. It's a shit idea. That's why they're still fighting about it. Is Einstein right? Is Newton right? What about quantum fucking other quantum emergent gravity? And this is why there's 70 freaking theories of gravity, right?
Yeah,
Because
but again, like
it's fundamentally a shit idea.
what experiment would you consider to prove it to your specifications?
Look, what do you mean prove what?
Gravity.
The cause?
Yeah, the cause.
The same thing that follows the scientific method. You isolate an independent variable and manipulate it, and that would manipulate the effect.
So what would you propose to prove that?
A scientific method experiment, dude.
Yeah, but how would you do it?
Okay, let's say, okay, I'll tell you. So, say your independent variable is mass. Mass causes gravity, wherever the fuck mass is. Another poorly defined fucking thing. So let's say it's mass. Mass causes things to fall. Okay, so we can manipulate. That's our independent variable. So we'll take two different masses. Take a mass that's fucking 100 kilograms. We'll take one that's 1,000,000 kilograms. We drop them both. We see which one falls faster. Right? We manipulate it. We want to change the effect. We want to manipulate the independent variable and watch the effect on the dependent variable. That's how we figure out what the cause is. As long as we've eliminated all the other possible confounding variables, we can definitely say, hey, this causes that, right?
But no,
so this test, if you do this test, what you'll find is, irregardless of the mass, they all fall at the same rate.
not what the cause is, though.
So your cause, mass, can't be the cause because it had no effect on it had no manipulation of the independent variable, had no effect on the dependent variable.
It can still be the cause, but
how can it be the cause if manipulating it doesn't change it?
Yeah, no, it can still be an indicator of like different masses, for example, like fall at a different rate or something.
Rusty,
like that,
let me
right?
use an analogy. You want to go on the date. There's a whole bunch of girls, and they're all saying no. And they say, if you change one thing, we'll all go on a date with you. So you change your hairstyle, and they all say no. Now you know that's not the cause of them not going on a date. You change your shoes. They say no. Well, that's not the cause. Then you change your cologne, and then they all go on dates with you. Now you know what causes them not to go on a date with you. You smelled. Okay? It wasn't your shoes. It wasn't your hair. It was your frickin' cologne. Okay? You understand? So if I manipulate mass and it doesn't change the effect and I still get something falling at 9.8 meters per second squared, then that's not the cause.
Yeah, exactly. Like, that's the point.
Yeah. So mass can't be the cause. So you asked me to tell you how to do it. We're going to drop two different masses. We'll drop two different weights. So we use, weight, mass. We'll drop fucking two different densities. Oh shit, dude. Now we're getting somewhere. Different densities fall at different rates. Shit. But we got a confounding variable. We got the fucking air that surrounds it. Okay, let's fucking old dude, fucking beat me to it. How'd you know where I was going, old dude? So this experiment in here is in a vacuum chamber, and they use different elements. So this is called Bremen Drop Tower. It's 5 stories. Okay, they have a vacuum chamber. They put this shit in a capsule and drop it in the vacuum chamber. Now they have, and this dude did an experiment and then got kicked out. He's German. He put all these different elements. They're all the same mass, as in, whatever, and whatever that means. And he dropped them, but they didn't all fall at the same rate in the vacuum chamber. So what this tells you is that mass, even though it's the same, if you do a carefully controlled experiment, there's some other variable that manipulates the rate of fall, that manipulates G.
Yep.
So what I'm saying is gravity is fucking unknown, dude. It's just an unknown.
I don't know. Like what you just said is like that's what we understand as gravity. Yes.
Yeah, but
Like it's
the
like
understanding
not some
is
unknown shit.
it's more like, yeah, it's an understanding that's more like a kid's story. Like they tell people, like, we understand this, but they really don't.
Yeah, well, like like generally people understand that when we come to
In a descriptive way,
like-
we understand it. Like we know, like we can make formulas and predict what happens. Like if we shoot a cannon, right? Based upon, a formulas, we know where the cannonball is going to land, right? Using little g. But like I said earlier, that's known empirically. We don't need a theory of gravity to make those predictions. We don't need to know why any of that happens.
Of course. You can figure it out. Like cavemen can figure shit out.
Yeah, you could
without,
actually
like,
just feed the data into an AI, and the AI could figure out where the fucking cannonball is going to land without knowing anything about Newton's laws, right? So,
I mean, yeah, you gotta put the numbers in, but it's not about like the fact that.
well, yeah, you could shoot like a trillion cannonballs, right, and just punch in the numbers of different the different configurations of the cannon and the cannonball and the distances and where it lands and all that shit, right? You feed it into the AI and fucking you like once it's done being trained, you go, okay, I shot a cannon, it was tilted at 45 degrees, and the cannonball is gonna, it's got this much gunpowder, the cannonball fucking has this much mass. Where's it gonna land? And it would spit out fucking the right answer. But it wouldn't need to use Newton's laws to figure any of that shit out, right?
So no, because a trebuchet can launch a stone 90 kilos for 300 fucking meters, bro.
Yeah,
he's gonna bust that fucking wall, that castle.
I want to see a human trebuchet, dude. I want to see a fucking launch a human being. But
bro, we had one right next to my next village or whatever. They had a fucking trebuchet. They shot shit from it. Damn, that shit goes far. But again, you don't have to you don't have to know anything about like gravity or what like we have today. Of course, you can like look at a stone flying a certain distance based on your trebuchet or your catapult.
Yeah,
but it's like if there is like things that you can derive from that information about like how far things fly.
My only point is that you don't need to know the causal mechanism. Like saying, hey, we understand gravity, but that's two different. Like it's a very poor idea. That's all I'm saying. This is why Newton freaking didn't believe it, because it's a poor. The idea itself is poor. It's conflated. Like I said, big G and little g. There's the so-called universal law of gravitation, where two masses pull each other, but then there's little g. In the real world, we do everything with little g. We're not doing fucking gm1 m2 divided by r fucking squared calculations. We're just calculating little g. So, which is, like I said, is known empirically. So when we jump from that and start saying causes, this causes why? Hey, air pressure, that's caused by gravity. Okay. Well, what do you mean by gravity? Do you mean the fucking big G or the little g gravity? Oh, the little g gravity. Okay. Where's the evidence that fucking little g makes shit like gases fall to the fucking ground at 9.8 meters per second squared? There's no evidence of any of that shit, or that gas can do thermodynamic work, or that gravity can do thermodynamic work, or that gravity can change. Think of how crazy it is to say that shit. That gravity would have to be, or little g would have to be able to do things like heat up matter and change the phases of matter and turn things from solid to liquid and liquid to fucking gas and like all sorts of shit.
I mean,
If you had a gravity dial, right, and started manipulating your gravity dial, that fucking things would like matter would change phase. Because it has to be able to do because the gas, it's a thermodynamic state. You understand? It's a state of matter. So that thermodynamic state has a certain behavior. And saying gravity can overcome its intrinsic fucking behavior of a gas, of what it does, saying, hey, gravity just stops it from doing what it normally does. There's no evidence of that. And that's a freaking tall claim, man.
Yeah, okay, like you don't have to go to this like specific level of shit, right? Like
I think we do for this, yeah. It's saying they're fucking got machines fucking floating around fucking a million miles away.
Yeah, but it's like you don't have like pretty much with all science, you don't go to the absolute base level of why things happen, right? Like, well, that's actually like what physics does, but at some point, it's like you like as a normal person, you basically can't understand what the fuck's happening, right?
Yeah, I understand, but like what we have here, Rusty, is on one hand we have the laws of thermodynamics, which have no known violations, and in fact, if you look at what's been written by scientists in the literature, Einstein said out of the 3 freaking legs of a stool of physics, thermodynamics is one of the legs, and if you took it out, the whole thing would collapse. Fucking Eddington, who was Einstein's buddy that supposedly confirmed his theory, his eclipse theory of fucking bending light. He said anyone that theory goes against the second law of thermodynamics is condemned to the greatest humiliation. So like it's like things like that on one hand. So that's what they say on one hand. And then they say gravity violates the laws of thermodynamics because there is no thermodynamic theory that actually incorporates gravity into it. You can look all through the textbooks. You can ask ChatGPT. You can look wherever you want, but there's no actual testable thermodynamic theory that has ever survived any laboratory experiment. So, like, we have a bunch of hypotheticals. The whole idea that gravity can create gas pressure and alter the thermodynamic behavior of gas is a hypothesis. That hypothesis has no evidence. They'll say things like, well, it happens on Earth, obviously, because it's obvious. There's this outer space thing, and we have gas pressure gradient, so blah, 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 right? No, it's not obvious. You have to be able to demonstrate in science your central claims through experiment. You just don't get a freebie of like, we can't test it, so we get to assume it's true.
Yeah, I mean, you don't have to use the word gravity or whatever. Like, you can use whatever word you want. But
yeah, I agree.
What like, if we go from like a base perspective, like let's say we are back in a fucking cave era or whatever, we don't have any like tools to measure it appropriately. Let's say we go up a mountain and we kind of we can feel it's getting harder and harder to breathe the further up the mountain you go.
You're right, just back to the natural phenomenon, dude. I agree with you. We observed that.
Yeah, of course, but you
why does it matter?
It doesn't. Well,
how is that evidence? There's this thing called outer space vacuum.
Because you can observe.
Because we're going to go right back to where we started. Because it goes down forever. It doesn't stop.
That's the thing. Yes.
Then if it stops, why does it stop?
It doesn't
stop. Right back to the same thing is what causes the gas to stop, right? What causes the gas pressure in the first place?
No.
You're right back at the starting point.
No, That's the thing. When you say it stops, that's not like a real thing. Like it doesn't stop or whatever. Like it
Ever.
doesn't stop. No, it's that's the word stop has no meaning in this discussion.
It means that the vacuum state can't get any lower. That's what it means to stop.
Yeah, but it's meaningless in this discussion. Because that's not what the vacuum
No,
of
it
space
does.
is.
I'm
That's
trying
not-
to explain
no
you
one-
why it
no-
means something.
No,
Because
no
then we're
one's
just
saying that.
quibbling about where the fucking boundary is.
Yeah. Well, actually, if you actually like, do you believe that the vacuum of space actually exists?
No,
Okay, then what's
I'm
the
trying to
point?
tell you it's impossible.
Well, that okay. So what's the point? What are we in? What are we even arguing about? Like,
Do you think it exists?
yes, I do.
Why?
Well, that then.
Because you climbed to the top of the mountain and couldn't breathe, so you thought if you go a little bit higher, you're gonna fucking whiz around the ball.
No, it's one point of an information that I experienced
Yeah,
and that I
that's
can
right.
think about. Also, because I have a brain that I can like think about and say,
Uh-huh.
okay, if I go
Okay,
higher,
so it's hard to breathe up a mountain. Where does your brain take you from here?
Obviously, hypoxia.
Mhm. No,
Trying to
like
figure out what your logic is. It's hard to breathe up a mountain.
Okay, like now
And?
from this specific point of argument, like if you go higher up again, right? If you go increase your elevation, the air gets thinner and thinner, right?
Yep.
Yeah. So what would that tell
When
you?
does this stop getting thinner?
Hey, this is your logic.
That's never,
right?
never, ever.
It
Don't
never stops
ask me a
getting thinner.
question and ask
Okay.
us what it tells us. I asked you. You go up a mountain, it's harder to breathe. It gets less and less dense. And the question's for you to finish. It's your logic, dude. You're taking us somewhere. Don't ask us a question.
Okay. I mean, this like alone, like I'm not taking any point of evidence by itself and
This
not
was your evidence.
included. No, I haven't made. Did I make any claim?
Yeah, we go up a mountain, it gets less and less dense. I'm waiting for the therefore.
Therefore, I didn't say anything after that. But you know. what
Okay,
we're
so
talking about.
let me ask it like
It's a
this.
point of
What was the
Claim has
point
no
of the
boundary.
analogy being a caveman going up a mountain and he finding it hard to breathe? What was the point?
The
What
point
does
of
that
the
tell us?
discussion that we had before about the
What
atmosphere.
Jedi's
and
asking
then-
you is, what does that tell us about space by him going up and it's hard to breathe?
I know you want
See,
to say
this is
want to
see,
say
but,
gravity.
okay.
but-
Hold on. I think I know where the problem is. So what you're doing is extrapolating. You're going from one pressure area to another one by raising an elevation, and you're extrapolating a continuation of that state, of that change, right? That there's a gradient that continues changing. We're asking you, you're extrapolating to what, to where? Does it end lowering pressure? Does it continue forever? Because if it ends, then there has to be a boundary somewhere. Okay,
Oh.
and even if it goes down forever,
No, they don't.
Right.
Go on.
well, even if it goes down forever, then like you're gonna have to have some sort of fucking infinite universe, which contradicts the Big
Yes.
Bang. So like,
No.
I'm trying really hard to avoid like some infinite regression fallacy, right? But the point is that are we quibbling about where the air pressure, this extrapolation? Because like I said, like you admitted, is that like, is this hypothetical? And you said, yeah, probably, right? So like where it stops, how does it continue to go down?
Yeah.
What rate
It's
is
because it's a
it linear?
stupid
Is it inverse square? Is it adiabatic? Like how does it go down? At what rate? Like how do we know where it stops? Does it go down enough to allow space travel? Does it go down enough so that there's a vacuum sufficient to fly rockets from here to frickin' Mars in. Right? That's what we're talking about. We're talking about outer space that they claim
No.
exists.
We
Is what
don't
we're
really
talking
do
about.
that. Yeah, but the thing is, I'm looking at the fact that if we go from sea level higher, like you elevate from that point, gas pressure decreases,
Yeah.
right?
Yeah. Why are you
You-
Okay, great. So we have two actually known values. How are we extrapolating it into unknown values?
So there's temperature.
What
lots of things.
what does that even mean? Like it's
We're
if you go-
extrapolating, dude.
yeah, of course. Okay, so can you extract some information from that fact? Like
Yeah, we've got gas pressure that changes.
Yeah, we
with
got
altitude
15
and
pounds per
temperature.
square inch of sea level. We got
And it
freaking
gets-
10 pounds per square inch on top of Mount Everest. Okay, now what?
okay, like it gets lower and lower the higher you go.
Okay,
Okay.
continuously forever.
I mean, is our next
Continuously,
question
yes.
what caused that?
The cause is the point, probably.
Yeah.
So on the
So what
I mean,
causes gas pressure?
I'm gonna ask you that.
A container. It's
A
defined
what?
as the force that the gas exerts upon the walls of its container. It's also
Well,
the thing that keeps the gas here and stops it expanding into an available volume of vacuum if there was one.
But wouldn't the gas pressure be equal everywhere if it
Is
was
the
in a
temperature
container?
equal? Is the gas produced in the same place the whole time? What? There's multiple variables now. Temperature.
Oh,
where
it's
the
called
gas is produced.
thermodynamics. We're not doing
Yeah.
thermostatics.
Okay, so if you had, like, if there was a container that was like a fucking iron or like a glass thing, like a
Is this container
what
static?
do you call it? What do you call it? Like the firmament.
This don't worry about that. This container, is the environment static? Does it have variance of temperature, for example? Does the temperature come and go, for example? Is the gas produced
Yes.
with inside the
Yes.
container, or have you just added it to the container? Is the gas dispersing into the environment? Is the water in the environment?
Yeah, that's
In your imaginary
all fine.
container?
Yeah, I can imagine that.
Okay,
Of course.
so it'd be like the Earth then, right? A very, very, very dynamic thermodynamic system. Right? That's what the Earth
Yes.
is. It's a thermodynamic system. Now,
As
within
everything
the
is.
laws and definitions of thermodynamics, to have this environment, the thermodynamic system must be closed.
mà từ thông tin đấy để suy ra được tam giác nào bằng tam giác nào. Đấy, cứ so sánh
Someone
từ
hot
tam giác
micing?
sẽ
Or am
mò
I
ra được
going
tam giác
crazy right
nào.
now?
Từ tam giác đích
No,
đấy
that-
suy ra hai góc bằng nhau.
What the hell's going on?
Tam giác mục tiêu, gặp tam giác mục tiêu.
Why would you enter the chat with an open mic having a conversation with somebody?
I'm talking about a thermodynamic system. For it to exist the way that it does, it must be closed.
Yeah, he was muted. Yeah, go on.
No, that's it. It must be closed.
Yeah. It doesn't have to be closed though.
Yeah, it does. Or the
I
gas
understand.
would expand into another available volume if that available volume was vacuous and available space. If the gas is not contained, entropy will increase and the gas will continue to expand because of the energy that's held within the gas is given to it by temperature. So because of the temperature, the gas is always going to move and collide. Because of these random collisions, it's expanding. You need a closed system to keep the gas in.
But if it was expanding, like how would you be able to like live in a in an enclosed environment? Like if you
What?
And I feel like if you like right now, of course, like the sun is putting
The sun?
energy.
No, we're talking about gas behavior, right?
Yes,
We're
I
talking
understand
about
that.
how
Yeah.
it expands into volumes and how we have pressure. We got to the question after discovering that there's a gas pressure gradient. The question was, what causes that? Well, within thermodynamic law, we're going to require a container to stop the expansion. The consequence of the containment is pressure.
No, but you have
No,
you don't even have to like refer to
sorry, you
gravity
said
because
no.
you
No, we're
have,
not talking about gravity. We're talking about what caused gas pressure. And at the moment, I'm waiting for you to concede that yes, containers cause gas pressure.
it does what?
I'm
What
waiting for
causes
you
what?
to concede that yes, a container, a limitation of volume that holds gas, is the necessary antecedent for gas pressure. It's the consequence of containment. PV equals nRT, the force that the gas exerts upon the walls of its container.
Yeah, but it's not the cause though.
Sorry, it is not the cause.
It's not.
So it's not the cause. The gas
container.
exerting its pressure upon the walls of its fixed environment, a closed system. Like, for example, when you put gas inside a tyre, by consequence of you putting that gas inside that fixed volume, because of the movement of gas and the density of that gas, it will be under pressure because it can't go anywhere.
Yeah, but what's the cause is the pressure itself. It's not the container. In that case, like it's the same.
Again,
it's the same,
listen. Force
it's the same.
over area. Gas pressure is caused by the force of the gas pressing against the walls of its container. If you don't have a container to press against, you don't have pressure.
Yeah, and then we go back to gravity, and then all of a sudden it's completely different.
You go back to gravity. I'm still waiting for you to concede.
About a, I mean, I
Gas is caused by the
understand.
force of the gas exerted upon the walls of its container.
Well, the cause thing is the problem that I have right now.
Okay.
Because I was told that you can't really. You can go deeper and deeper and deeper at some point.
No, I can put gas inside a container, and by consequence of that action, the gas is under pressure. Because the way that gas behaves is it wants to expand. It can't. The container's in the fucking way.
Yeah, I understand that. Yeah, I agree with you.
Yeah, good. So that's what happened then. In my little experiment.
If I say that gravity creates a gradient, and someone
then
tells
you
me,
can say that, but you would have to demonstrate that in an experiment.
See, like that's the difference. Like,
yeah, you can't do an experiment. I've just given you one, and you keep going, nuh-uh.
No, the demonstration would be pretty fucking obvious if you go up a mountain. Shit,
no,
right?
that's you begging the question and affirming the consequent.
No, it's a experiment towards something.
No, it's not an experiment. It's the observation of a phenomena.
Yeah, and okay, what we can use a different word than gravity.
It's not an experiment yet. It's not even a hypothesis until you make a supposition of cause of the phenomena that you witness. At the moment, it's the caveman changing his altitude and finding it hard to breathe or not.
Yeah, which has been done.
Yeah, so that's the phenomena.
And
we agree. And what causes that?
Yeah, that's the same thing. Like it's the cause.
Yes, what I asked you 15 minutes ago. Yeah.
Down. Yeah, so like you can't put it down to a cause at some point.
No, we're asking what causes it, and now you're saying no, we can't. Put it down to cause, even though you want to assert the cause is gravity. Like, can you stumble over any more words?
No, at some point, of course, it is. It would be gravity, but of course, like if you don't accept that, then
it's not whether we accept it; it's whether there's evidence or not.
Yeah, that's the thing. I mean,
you don't have the evidence. So yeah, that's the thing. The real question is, how come you accepted it without evidence? That's the real question. They showed you a diagram
Well,
in freaking
I'm just
kindergarten. Oh,
no,
look, this
I'm
is how
I'm
it works. And they drew a circle and they drew a bunch of arrows to the middle of the circle. And they're like, this is what holds the gas down, these arrows. You're like, okay, teacher,
no,
I believe you.
I'm just using a word
It doesn't
to
matter what you call
explain
it.
a concept.
It
All right, like everyone else does.
yeah. But what I'm saying is there's no evidence that concept is actual existent in reality.
It depends what evidence you accept.
Experiment.
What's your
Yes.
What's your
Oh.
evidence? What's
What
your
evidence do you
evidence?
accept?
But as a like you can first off you can drop an object, of course, it goes down to the ground.
God.
You can have a satellite.
Are you like in some
that
weird loop,
orbits.
dude?
Are we talking about the
Yes,
behaviour of
circular
rocks?
reasoning loop.
Sorry, we're not talking about the behaviour of rocks. We're talking about the behaviour of gases. So, in your analogy or
No,
your demonstration, can you use a gas?
it's a completely different thing, which we just talked about.
Rusty P, the airbender. I want to see you throw gas.
Here's your reasoning. I really want
Once you
to
drop gas.
pass out his reasoning, bro. Like, okay, so he goes, we have a 14.7 at sea level. I climb the mountain and it's like 11, right? PSI. And you say, what causes that? And he goes, gravity. And he goes, and then we say, oh, what's your evidence of that? And he says, well, there's 14.7 PSI at sea level and 11 on top of the mountain. That's my evidence.
No,
It's circular reasoning. Yes, that's what you
I'm not-
literally did. I've been listening to
No.
you.
yeah, but we are talking about one specific thing, about the gas pressure. And I'm not saying like, of course, like there's gravity underlying the whole concept of it. But I'm not saying like it's like if we just look at the gas pressure decreasing the higher you go, you don't have to invoke gravity or whatever. It's just like an observation. Like you don't have to make any you don't have to like what do you say it?
Come to a conclusion?
Yeah, you don't have to draw any conclusions to it. Yeah.
Okay, so it was a waste of time for the caveman to go up the fucking mountain in the first place then.
No,
Not being as we're
you
not
don't
coming
have
to any
to-
conclusions, otherwise we just observe a change in gas pressure and it's harder to breathe up the mountain. According to you, you don't need to reach any more conclusions.
No, the thing is, if you go again, like if you can observe that you can go up a mountain, right? And you can just increase your elevation and you feel that the gas pressure is decreasing, right?
Mm-hmm.
What would that like for like I mean,
Getting
if you're talking about
further
flat Earth,
away
right?
from where the
This-
gas is produced.
No, it doesn't have to be.
Hold on,
where
you're
it's
gaining
produced.
altitude within your example, going up the top of a mountain. Gas is produced on and within the surface of the Earth. I mean, let's take an observation of our whole environment. It's also cold up a mountain. We should probably take into effect the changes in temperature.
Yeah. Awesome.
Yeah,
course.
fucking dynamics. Let's include the temperature as shit. Let's also include where and how the gas is produced and cycled and reabsorbed into the environment.
Yeah, and what like could you like draw some information from that?
Yeah, the further I get away from where the gas is produced, it appears to get less dense. The temperature also appears to decrease. It's cold up a mountain.
Yes.
Yeah, cool.
Yeah.
So we seem to be talking about thermodynamics, temperature held with gas, its behavior relative to where it's produced and its environment, the changes in the environment over time. Sometimes it's warmer up a mountain.
Yeah, but compared
Seasons.
to the base of the mountain, and
Y-
at the same
yeah,
time, probably
yeah.
like colder, right?
Yeah, sometimes, and I say sometimes, like
Not
throughout the year, shit changes.
all the fucking time, basically.
Yeah, shit changes. Weather changes. Yeah, all of these things. Yeah, the amount of water
think-
held within the gas in the atmosphere changes. Yeah, all of these things, dude.
I understand that, but
Good. I'm glad.
again, it's-
Why did we start talking about gravity? You haven't even mentioned any of the other
the-
observable things. Got cold up that mountain, didn't it?
no, the thing is that you can derive
Sorry,
information.
we're talking about gas behavior.
Yes.
Yeah, that's
Again,
going to include the temperature of the gas, isn't it? We understand how
Not
different
really.
temperatures of gases are going to act differently because of the amount of energy that's held within the gas.
Mm.
Hot air rises, for example, cold air sinks.
Right.
It,
Oh damn! I got a fucking.
I feel like I'm educating
what that
you,
means.
your caveman. You're asking what conclusions we reached, dude, and you just want to jump to gravity. Haven't mentioned anything else.
I don't have to. I
Just
don't
gravity.
have to do it. It's just that gravity is a name of a thing that people
A
understand,
thing?
right?
That
Sorry.
has nothing to do with gas pressure.
Yes.
You can look through all the books on the kinetic theory of
I was-
gas, and you're not going to see any gravity mentioned in any of it.
Yeah, here we do, though.
Not even within the kinetic theory of gases, it tells you there is no force of attraction between the container walls and the gases. The container wall isn't acting upon the gas and, over space and time or whatever, pulling the gas towards it. Gas moves freely and randomly in all directions, dude, colliding with itself and the walls of its container. We don't have to talk about gravity because it's not included. It's not observed.
Okay. Well, you claim that. That's fine.
Just cited the kinetic theory of gases. Would you like me to put it in the side chat? There's no mention of the
If
word
you want
gravity
to.
here. There's also not a
There
G in
doesn't
P
have to
equals
be.
nRT.
That doesn't have to be, and I haven't even
It
said
doesn't
anything
have to
about it.
be gravity in gas behavior, even though you're trying to shoehorn it in, saying it does actually act on gas.
No, I'm saying that we can observe certain things, and you don't have to refer to gravity at some point. Like I did it, but
Yeah, we understand that. You're making the same arguments over and over again. They're addressed. We don't care what you call it. We don't care about any of that shit. We're talking about its possibility. Is it possible to
Yeah,
restrict the behavior of a gas based upon some force? Call it gravity, call it whatever you want. The observation we have is low pressure on the mountain, high pressure on the at a lower elevation. So what? Doesn't logically follow that continues forever or stops at any particular point. We have a surface on the surface of the Earth. That's fine. Where's the other surface?
the other surface.
Yeah, you need another surface, dude. Gas pressure is the force exerted on the walls of the container. If you don't have a surface at the other side of the fucking boundary,
It's
the
not-
gas just fucks up to forever.
Okay, if you think that, like there's
It's what's demonstrated in
It's not-
nature.
it's
It's not what
not.
I think, dude. I can demonstrate this in nature.
okay. Demonstrate it, please. You can just explain it to me. Please
You're being
explain it.
serious right now.
Explain it to me how gas pressure only is able to exist in a container, please.
Can you demonstrate it in any other way?
You
I'm
said
asking
demonstrate
him.
it, right?
No, you demonstrate it.
Yeah, okay. Got a bike?
The claim that you have.
You got a bike?
I have a bike, yes.
Okay. Try to pump up the rim.
The what?
The rim. Pump up the rim. Great gas pressure next to the
Okay, yeah.
fucking rim without the tire, dude. The rim is one surface, right? There's no opposite surface.
Uh-huh.
Use your pump to pump up the rim.
Okay. Hmm?
Okay, you can't do that, right? But if I take a tire, I take an opposite boundary. Now I can create pressure. Wow. Now you have gas pressure because you have a container. No container, no gas pressure. Container, gas pressure.
What's around you right now?
I don't know, but it's not fucking nothing.
Yeah, but isn't there like a gas pressure thing going on around you right now?
Yeah. The gas that
correct.
I'm surrounded by is pressing inwards in all directions into the space that I occupy. Yep.
Yeah. And Indio says that if you put pressure into a tire, or whatever he said, that's only the gas pressure. So there's gas pressure existing in a container, of course, which would be the tire. But right now, around us, also there is gas pressure.
Yeah, what causes that?
Existing around it.
Yeah, what causes that?
Well, again, we would go to gravity again, but
no, again we would go to a container. Fuck.
But why? But why? Like you're saying. You're saying
are so brainwashed you can't even admit this clear and obvious truth. You require a container. As soon as I asked you what causes the gas pressure that surrounds us, you jump to gravity and completely disavow any mention of the word container. Are you sick and tired?
We have just talked. We have just talked about gas pressure in a container when I guess Indio was it about pumping up his fucking bike tire.
Yeah,
right?
We're looking for another causal mechanism that causes gas pressure that we can demonstrate, or the claim that you say that we can't demonstrate this. It's called entropy. Every single time we open a container of gas to a lower pressure environment, the entropy increases and the gas fills the space and might equalize in a low volume.
Yes.
Completely. You don't have an experiment for your claim, though. That's why Injo put the gas inside a tire. He did that. You can do that. Now, what can we do for gravity apart from go up a mountain and make big ass jumps of logic?
To go to gravity, it's just a thing where when you claim gas pressure cannot exist without a container,
then show another way that can.
But it's like fucking obvious. Like
no, it's not obvious until you demonstrate it. Apparently, it would be obvious to you that there was a container unless we demonstrated to you 5 times. So we're going to need demonstration.
Oh my God.
Actual physical reality taking place.
Yes, physical reality is taking place all the fucking time, and you just
can't fucking see it. Broken. Just give an experiment where you very manipulate gravity to cause the phenomena of pressure.
We're not talking about gravity.
You keep fucking bringing it up. You wanted to 2 minutes ago, then you got upset. Are you really this broken?
I said before that I didn't want to bring up gravity.
And stop bringing it up.
I didn't bring it up. You brought it up.
Okay, so the gas around us that we're surrounded by, what was your point?
There's no point.
Oh, so again, he brings up a subject that has no fucking point. I swear it was gravity. Please follow your own fucking words. I am. You're not making any sense, and you keep contradicting yourself.
No, I don't. If we are agreeing that
stop him.
We don't...
Someone.
What are you saying, bro? Like, if we agree that we don't bring up...
You said you didn't want to bring up gravity.
Yes.
So what was the point of us being surrounded by gas? According to you, no point.
The question is on you.
You're just lying.
The question is on you, man. The question is on fucking you.
What? To demonstrate there is no other way to cause pressure?
Yeah, you said that like gas pressure can't exist.
You're making a claim it's caused by gravity. That's your claim.
No,
your claim is in violation of the second law of thermodynamics. We've been over and over and over it with you.
No, you are cycling back about the gravity shit. Again, I
Yeah,
said
someone else talked to me.
no, you you did it. Again, like I said we go away from the whole like gravity shit from the like
You brought
overall.
up two examples: one, a caveman going up a mountain and experiencing it hard to
Yes.
breathe, and then you brought up there's gas
That wa-
surrounding us.
Mhm.
At no
I
point
did.
in these conversations did you want to bring up gravity.
Yes, I especially
Oh, you do
said
now.
because you bring it all you bring it up all the
Stop
way like
tripping
all the
over your
time.
fucking self, dude. Have some fucking humility. Like,
Yeah,
please,
all
I'm
right.
begging to your better nature.
Yeah, I understand. Like, come on, like
I'm going to go walk my invisible dog. Someone else can talk to you.
yeah, go on. Is there any flat earther still here that wants to debate?
I mean, what are we debating exactly? Ideas versus evidence.
Yeah, again, the same thing that who was it? Person before me that left. So I guess he misunderstood the whole fucking debate, or he deflected. I don't understand.
Who, Jedi? Who are you talking
Yeah,
about?
Jedi. Yep. Yeah. He, like Jedi. Yeah, probably. Which is the person that I was debating about against. I mean, it seemed
Well, I
like he
mean,
was just
like I told you,
deflecting.
this is a common thing that happens. You have ideas. We have evidence. You won't let go of your ideas. When you first heard the idea of outer space and that gravity creates gas pressure, how did you evaluate whether that claim was true or not? Like, what did you do?
That was the thing where we ended up at the end of our debate. Like I was trying to say that okay, we don't use that word. We don't use the word gravity. We
Why are
don't
you
use
addressing what
that.
I said? That has nothing to do with what I'm talking about. I'm asking how you evaluated it in the first place.
Well, we had that debate topic at the beginning of our discussion that I had with them, but
Talk about you. When you first heard it, when you were a little kid, what did you do to evaluate its truth?
I'll just look around at reality. It's not specifically gravity, but
You looked around
kind
at
of
reality and you concluded that there's no container for the earth.
that's not the conclusion that I made when I was a kid.
I just want to know where you get the idea that somehow gas pressure is the way you think it is for the reason you think it is.
Could you form a conclusive question, please?
And I just want to
Like
know
an
why
example?
you think that gas pressure is the way it is for the reason you think it is. And you
For the
can't tell me
reason.
the reason. You're actually trying to reject your own reasoning. You're trying to throw
I mean-
gravity under the bus and say, hey, let's not use that word.
Okay,
But
so
there's
it's
no
like,
other mechanism you can point to say, hey, we have gas pressure without a container.
well, that's actually kind of what it is. It's the best explanation that I have for how if you want to say gas pressure, of course, but everything around the Earth, like how the physics work, kind of. Yeah, gravity is
We're
kind
giving
of
you the physics. They don't work.
Well, they kind of give the best explanation.
But the best explanation has no evidence. So if that's the best explanation, it's like, I don't know what to tell you. If your best explanation has no supporting evidence, I don't know what to tell you, dude.
well, there hasn't been any other big explanation or big evidence thing that has been coming out that explains the word any differently. So
That
what am I going to
explains the
believe
gas
in?
pressure gradient.
Yeah, gas pressure gradient.
Here's one.
Pretty conclusive.
That gases
pretty
are
conclusive.
created on the surface of the Earth. And what you have is diffusion, the diffusing of gases from the surface. And that's why there's a gas pressure gradient.
Okay, I haven't really experienced that. That things.
What are you talking about? It would be exactly like what you experience now.
If gases like are being expulsed from the Earth.
Not only that, but they're being created on the surface of the Earth, as in, because of thermodynamic processes, chemical reactions, things like that, gases are created on the surface of the Earth. Right? So when you have so what happens when you have a chemical reaction that turns some group of molecules into some other group of molecules, and then it emits a gas? That gas pressure in that region goes up, right? But then the gas diffuses into the surrounding area, and you will have a gas pressure gradient from the point of the chemical reaction going out radially from there.
Yeah, so
yeah, there's your explanation.
All right. I mean,
and funny,
I wasn't asking
this is what the
how
Chinese.
gases
This is what
are.
the Chinese thought way back in the day. They had a name for it. It was called the air wind or something like that.
Yeah, but like do you think that we live in an enclosed space?
Yeah,
So
you have to.
is
And that's what
Is
we've been trying to
there-
tell you for 2 hours now, is that we have to. It's not opinion.
yeah, but
Like
wouldn't
opinion,
we- what-
the second law of thermodynamics is a natural law. It's a law of nature. It's not an opinion. It's not what I think. I go, hey, what does the second law predict? It predicts this. Okay, that's what's going to happen.
Yeah, but it doesn't. It's not a law that applies to your worldview.
What are you talking about? I'm talking about the second law right now. You're not. You're making up your own bullshit.
No, if you would be in an enclosed space, at some point the energy would increase more and more and more, and you would just fucking die because it's getting hotter and hotter.
Because temperature radiates infrared radiation, so the energy would. So, for instance, if you take a blowtorch and you heat up poker, it doesn't heat up forever. It'll reach a certain level of equilibrium where it stops heating up. Right, 500 degrees Celsius, whatever it is. It'll reach an equilibrium.
Yeah,
But the
because
Earth is a system that is in constant flux. It is dynamic. It's never going to reach equilibrium, probably not in your lifetime at least. And it radiates heat through electromagnetic radiation. So it's never going to keep, the temperature's not going to go up and up and up forever.
well, if it's I mean, in real life, as like if you are a glober, of course, yeah, that makes sense. But if you are if you think that the Earth is enclosed in a, I don't know, like a dome or something like that, then that whole system doesn't make fucking sense.
Is that like your argument? So your
Like
counter argument to what I said was, if
where-
you're a flat earther, that whole argument doesn't make sense. That's your counter argument.
Yeah, if you think that the Earth is enclosed in a dome or whatever,
Yeah, it don't make fucking
the
sense. That's your
energy-
argument. Great argument.
Yeah,
It don't make
yeah.
sense. Great argument.
it doesn't make, like, scientifically, it doesn't make sense. Yes,
I just told you why it doesn't make sense. I gave you the reason.
Okay, so where is the energy going again?
It's being radiated. Radiated. What is
Like-
radiation?
It's the energy that-
Electromagnetic radiation.
Yeah. So go on.
And it's being radiated away from the Earth.
From the Earth, away from the Earth. Okay.
Away from the Earth. Like the electromagnetic
How-
radiation. So
Yeah, I
you have
understand that.
you have
don't
a
have to-
closed
you don't have to
system,
argue.
bro. Okay, you have closed systems and open systems. Okay,
What is the Earth?
in a closed system, energy can pass, but matter can't. In an open system, matter and energy passes. Okay, so we're in a closed system, as in the energy can pass, but the matter can't.
All right.
Now, do you understand? So we can emit radiation. We can take in radiation. We take in radiation from the sun. We emit radiation. It's called radiative cooling, in fact.
Yeah, but again, like if you would be able
This is
to
okay. You're going to tell me that we're not using physics now?
no, but if you have like a
Is that physics, dude? Yes or no? Is that the common modern version of physics, of thermodynamics?
I'm saying about physics though. Like there's no fucking point.
Thermodynamics.
Yes, I understand that.
How can heat transfer? There's 3 ways. Can you tell me the ways?
What?
There's 3 ways for heat to transfer. Can you tell me the ways?
Right now, radiation probably is one of them.
Radiation, convection, and conduction.
Mm.
Okay.
Wait a minute.
Anything with a temperature
else?
emits radiation.
I gotta go.
All right.
We're gonna wait
I'll see you later.
5 minutes.
It was very convenient.
Wouldn't it be the same if the Earth was flat? You know, we would still be in the Earth next to a vacuum, floating
No.
in a space.
No, bro. I don't know how you've been here for this long and you still think that you're still trying to put the flat Earth inside the globe model, right? You're trying to fit the flat Earth inside the heliocentric concept of the universe, which is a big giant space vacuum. The flat Earth does not reside within the fantasy heliocentric model of outer space.
No, I'm generally talking about the space, you know, the space, the stars, the sun, whatever we see may not be whatever the scientists are trying to tell us, but they do exist, right? I mean,
Yeah, but why is it a vacuum? Why, we don't know what they are. We don't know if it's a big, giant, vast vacuum. In fact, it's not possible for it to be that, and there's no evidence of it as that. Okay, that's just a story that we were told growing up about what we're seeing in the sky. And it came from a whole bunch of assumptions made by ancient philosophers and cult leaders like Pythagoras and whatnot, based on crazy ideas, right? Based on just guesswork, right? Not actual empiricism. So yeah, if you want to claim that there's a big giant space vacuum in the sky and that the Earth is an object inside the space vacuum, that's a crazy claim, right? You're going to have to back that claim up. Like the image that you posted yesterday of the disk in space, that's propaganda, Made up by the media.
The images I uploaded,
Yeah, like the disc. Yeah, you put it in the chat yesterday. You asked us if this was flat Earth, and it was like a disc floating in space with a dome over the top.
oh, it was not yesterday. It was, I think, 2 weeks or maybe.
No, it was just a day or two ago.
Either way, you know the meme that he's referring to, or the image that you posted. You do recall that, right?
I mean, yeah, in that time, I thought that was the model all of the flat earthers were agreeing on. But later.
He's explaining to you that that's propaganda. That comes from the Flat Earth Society, which is a group that tries to propose that the Earth is accelerating upward at a certain speed, and that's what causes things to fall. Okay? That's not what we propose here or promote or think. And if I may add, because I have been listening for a quick minute, as far as all your space stuff there, you know, the theory that's proposed is a Big Bang, a little tiny dot of pure energy that exploded and started expanding outward, and everything started becoming into existence, whether it's Mars or Earth or anything that they tell you. Backup theory to that is the Big Crunch. That eventually one day it's going to stop expanding and it's going to start falling back in on itself and crush back into that small little dot of pure energy. Seriously? Like, these are people telling you stuff. They have nothing to back it up with. They pull it out of thin air. In fact, the Big Bang Theory itself was proposed by a priest. Like, the guy just thought it up, spewed it out, and everybody went with it. Yep, that's what happened. Nothing, bang, everything. So I just want you to chew on that for a little while. Big Bang, Big Crunch. It's moving outward. One day it's going to move inward. I don't know who came up with that, how they came up with it, what evidence or any research they have to back any of those statements up, but that's where we're at with the mainstream NASA, astronomy, Neil deGrasse Tyson stuff. You know, we're going into space, people. Sure we are. Screw the homeless. Screw the problems here. You know, the sky, the stars, the moon, the sun, what we're observing up there is just what we're observing. To claim that it's raining diamonds on one of those lights in the sky, I have no right to say that. Nobody has the right to say that.
No, actually, that was not my problem. Actually, a few days ago, one of these flat earthers actually explained to me that there is no certain model that every flat earther agrees on. And I accept that, okay, it's okay. I was just saying that regardless of the shape and, the situation of the Earth, okay, we are living in, some kind of condition with a huge amount of oxygen and gas around us. And whether the Earth is flat or ground, it is going to be like beside a vacuum or space. I know you want to say that the space is fake, yeah, but I mean, what the shape of the Earth has to do with it? See what I mean?
Okay, no. The shape of the Earth, what the topic is that it is observably flat and stationary. We are told it's curving and spinning. We do not observe that. The only time we observe it is when we're given an image from NASA, or when we look through a fisheye lens, we might see the horizon bending left to right. But we don't see it moving. Any experiment done to prove that it's spinning or moving has failed. We don't see it bending left to right, front to back, no matter the height we go to. We see too far. There's no drop over distance, whether it's the Bonneville Salt Flats or a large body of water. Water doesn't bend or curve. You want to go to waves? Okay, yeah, waves bend and curve, but long distances, large bodies of water, it doesn't drop. Okay?
Yeah.
We're being told the earth curves, it spins, we went to the moon, we're going to Mars. We're being told things about space that we can't verify. Right? The topic was space, wasn't it?
Yeah, I see where you're coming from, but the thing is, I am beyond this, okay? It's been about 1 or 2 weeks that I'm in this channel, and I have been explained all of the things that you
So where are you at?
trying to explain me. No, just DJ was, saying to the guy that just left the channel that about the vacuum and the non-existence of the container and how the gas is not being spread into the space, so the space is fake and stuff like that. And I was just wondering and asking him that even if the earth was flat or even if it is globe, like this atmosphere, this gas must go somewhere, right? So I just am struggling hard to understand what it has to do with because if debunks the globe earth, it must debunk the flat earth too. See what I mean?
Well, no, I'm not following you there. I don't know why you're saying it has to go somewhere. And if the earth is visually flat, I don't know how it can debunk that it's visually flat. It's observably flat. You don't see it curving. You don't feel it's moving. You don't see it spinning. Any experiment done to prove it's moving has failed. So it's stationary. In other words, the airplane can take off and land on a solid surface that's not moving. If it was moving left to right, up or down, it'd have a bit of an issue getting off the ground or landing back on the ground. It would either have to land in the direction it's take off in the direction it's spinning, or failure. You'd always have to be landing and taking off in that one direction. You couldn't land north to south, whatever. You couldn't have runways running in different compass directions: northeast, southeast, north, west, east. You couldn't have runways running like that. They'd all have to run the same direction. So it's not moving. It doesn't curve left to right. That supposed boat you saw disappear while you were standing at the edge of the ocean, it disappeared pretty quickly. It should come up behind you pretty fast. That's a pretty small ball you're living on. And if you take out something such as a telescope or a camera that can zoom in beyond where our naked eye saw it disappear, lo and behold, we can see the whole thing further out. So it didn't go behind any hump. It's not gone behind a curve. So it's visibly flat. Space, as far as up in the sky, Mars, Jupiter, Pluto, all that stuff, it's all what we're told and shown. Either from the European Space Agency, NASA, Elon Musk and his SpaceX stuff. It's all visually shown to us on screens. You know, Hollywood fakes it better than NASA does. I believe Hollywood movies and films that I watch about space more than I believe NASA's footage. And Hollywood admits that's all, smoke and mirrors. It's all special effects. None of it's real. We did it all down here on the ground, but we made it look like we were floating out in space. Yet for some reason, the average taxpayer and hardworking man or woman seems to accept all of this stuff. Yeah, we're growing lettuce on the ISS. We're really going into space. And, gas went up another $1 a liter? That's okay. I don't know.
Yeah, I have.
I'm not sure where you are with all of this, but space, what we're told is just that, what we're told. We can't go and confirm it ourselves. Earth is visually flat, not bending, not spinning. It's not a disk in space accelerating upward. When you are thinking on the flat Earth topic, you have to remove your heliocentric paradigm altogether. You can't think of the Earth the way you did when you're thinking of your globe spinning water ball. You have to have a new perspective. Open your eyes, open your mind. Mind's like a parachute. It won't open if it's closed.
Actually, no. I have seen the videos too about the NASA, like the famous astronaut guy who is brushing his teeth in a satellite or something, and the video goes in fast mode, but the background, the second layer, the objects were not in fast mode. So I have seen those videos too, and I'm here to just increase my vision and increase my.
Yeah, Mohammed's very good faith, flat man. He's been here for quite a while, and he's just going through the different thought processes that are required to come to a conclusion. He's doing the right thing. I think at the moment he's a little bit confused on the gas pressure argument, right? And the outer space, right? And how Earth, like how the atmosphere would work and that kind of thing. Right, Mohammed? Or wrong?
I mean, I know that asking you about a model or anything would not be right because that's not even the subject. But could you please give me your perspective about what is keeping this amount of gas toward the Earth and avoiding it from like spreading into the outer space or something?
Yeah. So there is no outer space, right? That's why it's not spreading into the outer space, right? There's no outer space as you're taught in the globe model. Okay, so outer space in the globe is a 10 to the negative 17 torr vacuum, right? That's it's about 100,000 times more powerful than any vacuum chamber that we can create on the Earth here, right? So to have an ecosystem, to have gas pressure in itself, you need to have a container. Do you know what a terrarium is or a vivarium?
It must be some kind of container or something, right?
Yeah, it's like when you have like a big glass tank or something like that, right? And it's got like an ecosystem on the inside where you have like plants and animals and a little pond and fish, and it's completely enclosed. But it's a self-contained ecosystem. It looks after itself. Essentially, you could just keep the container closed, and you don't ever have to open it. Okay, and it has all its own systems inside of it, condensation and gas cycles and things like that. Let me show you an example. This is an example of a very small one in the side chat that I'm going to post. Just give me a second. I was just looking for this to show you.
Meanwhile, you are searching.
I've got it. All right.
Yeah. I just want to ask that, so the air is, getting thinner and thinner the more we get high. So
yes.
It is like it must get stopped at somewhere or something.
Well, there's only a certain height that we can measure the pressure up until, and it's not that high. I think it's about 40 kilometers high. Okay, because you can't use a barometer above that height. Okay, and we can't really get up higher than that as well. Okay, so once you get to what they call the mesosphere, nobody has any pressure readings, right? It's just done on a computer model based off the globe model. So they're going to tell you that it's a certain pressure once you get up higher, except we can't validate that. Okay, even the meteorologists admit that you can't use a barometer above about 20 kilometers. Okay, you can get a special type that can go up to about 35 kilometers, but above that, you can't use a barometer. Okay, they're not calibrated for that, and they're just not able to. They don't work above that height. You can look that up. But this is the thing. You look up the definition of gas pressure in the first place, okay? Gas pressure, the definition is the force that the gas particles exert on the walls of their container, okay, as kinetic energy makes the gas particles move, right? And the gas particles move in all directions, okay? And the gas pressure that you're reading is when the gas particles are bouncing off each other and off the walls of their container. You need to have the container or the area to be able to have the gas pressure in the first place. I'll get you the definition. Yeah, do you need the definition? I can pull up the definition for you.
No, I have searched that before, like yesterday. I just understood about this concept.
It's an antecedent. It's a requirement to be able to have gas pressure. For example, if you have a car tire, okay, or if you want to have any gas pressure higher than the atmospheric gas pressure, you need to have a container. So if you want to have like a balloon or a car tire or a soda can or something like that, obviously you need a physical container to contain the pressure. You can't have it without having a container. Now, what happens when you put a hole in a car tire? The air is going to rush out of the high pressure system every single time, right? Because that is a gas, that's a natural law. That's what happens. The high pressure will go to the low pressure and the gas particles will try to fill the available space. So very quickly, it will equalize with the outside pressure. Like that's why stop me because I want you to understand it. So if I say something that you're not sure about, just stop me and
the
clarify.
thing is, I had been watching some debates on the YouTube. Like right now, I am watching this guy, Whittlist. I'm sorry,
Whitsitt,
yeah,
Austin Whitsitt.
Yeah, versus William Harris, and a term that I am hearing so often is collapse of the gas. Is it the same as like what you are trying to say, like feeling the empty space, empty
Yeah, so the reason gas particles move is because of heat, right? So as soon as they have any heat, they have kinetic energy, and that's what makes them move, right? And then they will move in straight lines. Okay, they'll move in a straight path, and they will only change that straight path if they bounce off of each other or off the walls of their container. Now, they don't have a directional bias. Okay, they don't have like a downward bias or anything like that. They'll just move in random motion. Okay, and as long as you have heat, then the gas particles will continue to move very, very quickly in random motion, and they will try to fill any available space. Okay, so have a look at what I posted in the side chat. Okay, and don't hit play yet. Can you see what I posted?
I have seen this like multiple times in this channel.
All right, well, just let me explain it one more time, okay? Or can you explain it? Do you want to try to explain the argument here to me?
Well, I think the point you were trying to make and what is actually obvious is that when we give the gas some freedom and it is in a container, it will automatically fill any available space that it has any access to, right?
Yeah. So what would the top container here in the demonstration? What does that represent? It's a vacuum. What is a vacuum? Okay. If we're gonna associate this with the thing in question, which is outer space and the Earth and the gas pressure that we have here. So the top chamber will represent outer space, right? Which is a vacuum. Okay. So above us is supposed to be a big space vacuum. Okay, and then the chamber in the bottom, that would be represent what we're breathing right now, which would be the gas pressure here on the Earth. So we have a high pressure system, and then we have a vacuum, okay, above our heads. Okay, and now the only reason that the gas pressure is staying in the chamber at the bottom is because there's a physical barrier stopping the high pressure from doing what gas does and filling available space. So you'll notice that when you hit play, as soon as he releases the valve, the high pressure is instantly going to equalize with the low pressure system. Now that's a big problem for the globe because they're telling us that we are a very, 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 on a universal scale, we're just a tiny little ball covered in gas inside a giant vacuum chamber, right? And they're saying it's with no barrier, no physical barrier. When we put this to the test in a lab, it doesn't work, right? Gas laws apply, and obviously the gas will fill the available space. Now,
sorry for cutting you right there. I asked this from artificial intelligence, like 2 days ago, and he answered me that for keeping the gas in a space, you must have one of these two conditions: one, a physical container, or some kind of two, like a force that keeps the thing downwards. Like as you said, I'm just trying to say what you said, that we have to give a term to justify this behavior. See what I mean?
right, so this is the globe's explanation, right? They say gravity acts like the container, and gravity is stopping the high pressure from equalizing with the low pressure. That's the claim on the table. Notice that magical gravity comes into play once again, right? It's the same thing that's going to be why we can have water sticking to the outside of a globe and all of these things, right? It's say the word gravity and that's just the explanation, right? So it's an explanation that doesn't have any scientific backing through experimentation. Okay, it's a theoretical mathematical concept. It's something that's required to be able to have the globe Earth work in the first place. It's not something that's been validated. Now, this is the problem. If it's also contradicting the definition of gas particle movement. Do you know the definition of gas particle movement?
No, I don't.
Just look up the official definition, but it's basically gas particles. Okay, so gas particle movement is defined as constant, random, high-speed motion in straight lines until collision occurs. Okay, so gas particles don't have a directional bias. Gas particles move in all directions. Okay, they're not being pulled down to the Earth by gravity. Okay, and that's when we ask people right now, show us a test anywhere on the Earth, right, or anywhere in a lab where you can show us gas particles being pulled down to the Earth by gravity. It doesn't exist. It goes against, like, why would they say that gas particles move in straight lines until a collision occurs? Okay, so if a gas particle is going upward at 45 degrees, for example, or any degree up, it's going to continue. It's going to continue going in a straight line.
Yeah, and not even
until
like gravity, any kind of force to keep the gas not, filling the empty available space. I don't think that any kind of experiment exists in that subject.
It doesn't exist, exactly. It's one of those things where you just have to have faith in the explanation. Okay, you can't ever test it. This is what they'll tell you. It's impossible to test because you'd have to have a test that's as big as the Earth, right, and replicate the whole system, which is impossible to do. So they said that basically there's no way to test it. You just have to believe it, right? Because you can never empirically verify it. Any time that we try to do it on a smaller scale, obviously it completely destroys the explanation, right? It doesn't work. There's not a single experiment where we can show gravity pulling gas pressure downward. Okay, you can have, just say you have a container, right? Let's say we have a tank, a glass tank that's enclosed, and it has a lid on the top. Okay, and it has a higher pressure inside the container. Okay, and then we take the lid off the container. Gravity doesn't hold any of the higher pressure down in that container. It all will just equalize. It will just fill the available space, and within no time at all, it'll just be the same pressure as the surrounding air, right? Gravity's not holding any of that gas down. Even if you take a heavy gas, like sulfur hexafluoride, SF6 gas, it's a very, very dense, heavy gas, right? And you put it in a fish tank, within about 20 minutes or something like that, it's all going to be gone. Gravity's not going to hold any of that SF6 in the tank. because all of the gas particles are going to be doing what gas particles do. They're going to be bouncing around, and they're going to mix with the surrounding air, and everything's going to blend in together, and it's just going to become all as one big medium in the room, right? There's not going to be anything left in the tank except for the same air that's surrounding the tank. So I think you were saying something earlier about why is there a gradient? Well, just before we get to the gradient, are you still there?
Yeah, of course. Just listen.
Okay, just look at the image that I put underneath that example there. I'll just read it out quickly, right? So it's the guy, he's got like a big glass bottle. Okay, thriving since 1960, my garden in a bottle, seedling sealed in its own ecosystem, watered just once in 53 years. Okay, so 53 years ago, he put some water in there and shut it, and he's never opened it. Okay, that system has continued to thrive by itself, right? It's a self-contained ecosystem. What do you think would happen if you got a big vacuum chamber and you put that inside the vacuum chamber and then you removed the container, you removed the glass? Everything would die, right? The water would boil, everything would die very quickly, right? Obviously. Okay, because if you put water in a vacuum chamber, it boils. Okay, so you can't have an ecosystem inside a vacuum chamber. Obviously, you need containment to be able to have the gas pressure system, to be able to have the dynamic system that he has here, where it has all of these cycles and whatnot. Now, there's bigger versions of this as well, and they're freaking amazing. Like if you look up vivariums, like the world's biggest vivarium, I'll post a video in the side chat because it's really cool. Giant vivarium.
I'm sorry.
Right.
Meanwhile,
Hold on. I am getting to a point.
Yeah, I just had a question about the picture.
Yeah. Go ahead.
So, like, he poured some water in the bottle, and how that water is not being consumed by the plant species. See what I mean?
Well, it's everything's being cycled. Everything's being cycled inside of the container. Okay, it's being consumed, but it's cycling just like what happens here on the Earth, right? You have evaporation and all of that kind of thing, which is going to make
interesting. Yeah,
yeah. You can just that's what you can do in your house as well. Like, just say you have a completely sealed room, you can have put plants inside a room in your house and keep it completely sealed, and the plants will be able to feed themselves, right? Because they're using the oxygen, and everything's being cycled. Okay, so have a look at these two other examples, right? This guy puts like little crocodiles, and he puts like fish and animals, and it's just kind of like a little world inside these big giant vivariums that these people make. And you don't have to open them, right? It's a self-contained ecosystem. The Earth behaves just like this, right? Obviously, it doesn't work if it's in a vacuum, but it works in a sealed container. Now, these ecosystems have a gas pressure gradient as well, because guess where the gas is being produced, right? And we can use the Earth as an example here as well. Where is the gas produced, right? Most of the gas is produced at ground level, or in the ocean, or under the ground, right? Like 80% of the oxygen in the air is created by ocean plankton, sea plankton. And then we have all of these other complex cycles in nature where we have nitrogen cycles and all of that kind of thing. It's called a dynamic system, right? It's a big giant ecosystem that has all of these different cycles going on, which works in perfect harmony to keep the system going. That requires containment, right? To have the gas pressure in the first place requires containment, right? To have a gas pressure gradient in the first place requires containment as well. And there's no evidence otherwise that you can have anything other than that, other than a container to have gas pressure. Now, we don't know exactly how the sky works. We don't know exactly how this place is contained. All we know is that there are gas laws, there are natural laws, we have thermodynamics, and we can test all of these things over and over and over again, and we get consistent results. Right? None of them match with what they're telling us is happening in relationship to the heliocentric model and the vacuum of outer space.
So, just curious, okay? If such a thing as a a vacuum, and the space we are being told doesn't even exist at the first place, so would you say that like our atmosphere is like going on and on, like without any limit or something? I'm just trying to understand.
I don't think so. I think that we can only speculate about what's too high for us to test. Okay, so what we don't need to speculate about is that we have gas pressure, right? That the gas is created at ground level, where we have more gas, right? Approximately 14.7 psi at sea level. And then we have a gas pressure gradient, right? It also gets much colder as you go up as well, which is going to affect the movement of the gas particles as well. Okay, we also have these terrariums and vivariums, like I'm showing you now. They also have gas pressure gradients inside of them. Not as large of a gradient change as we have on the Earth, because they're very small, right? The bigger you make them, the more of a gradient that they have. But yeah, what do we know? We know that there's gas laws. Gas pressure needs a container. Okay, all of the ancient cultures all depicted a contained system. Okay, so that's not proof, right? But that's interesting information to take into consideration. All of the ancient cultures all thought the same thing, right? A flat Earth within a contained system. And we don't know exactly how the sky works. We don't know exactly what medium is up in the sky. We don't know how the containment works. We know how we can, you need a physical container to be able to have gas pressure. We know that on a smaller scale. That's how it works. Okay, but above a certain height, we can't keep measuring the pressure. It's not being done. There's no gas pressure readings when you go up 50 kilometers high. Right, where they say the mesosphere is. If you look into how they know what the pressure is up there, they just use computer models.
So, like, all the answers that is going to be said from globers or scientists would be gravity, refraction,
Yeah, gravity and refraction. That's right.
But I just want to analyze one kind of logic with you, okay? I have been watching some YouTube video, and the guy, I forgot his name, said that, like as you said, nobody is explaining gravity. Nobody is explaining what gravity is actually at the first place. They say that, yeah, it just exists, okay? But the thing is, he said that when we see the effect of one phenomenon like gravity itself, if it exists, okay, that's their claim, on different objects, and we see the results over and over again, we can confirm that such a thing exists, okay? So,
yeah,
do you kind of agree that's logic, or it kind of not?
Okay, so this is the case. When we put things in a vacuum, they're going to fall at roughly the same rate. Okay, not exactly. They're going to fall at roughly the same rate. But then,
would you repeat
gas particles?
Sorry.
Yeah. So when we put things in a vacuum, they fall at roughly 9.8 meters per second squared, 9.81 meters per second squared. That's roughly the speed at which things fall if you put them into a vacuum chamber. And that's where that comes from. It's an agreed upon average that things fall at roughly the same rate if you lift them up and then drop them in a vacuum chamber. Okay, that's an effect. Okay, that's something that we can all observe. And that's what a lot of people refer to when they say gravity. They think that that's what gravity is, right? Just the effect. But on the globe Earth, they're claiming the cause of the effect. Okay, that's where you're running into the pseudoscience. That's where you're running into the make-believe or the mathematical concept of gravity. When you start trying to claim the cause of the effect, we all agree on the effect that things fall at roughly the same rate in a vacuum, unless we have gas, right? They say gas has mass as well. That's what the mainstream says. But gas particles don't fall at 9.8 meters per second squared. They should if gravity existed, but they don't. Okay, gas particles don't have a downward bias. So it seems gravity's forgotten about gas particles, but you'd need gravity to be affecting gas particles to be able to have this ecosystem that we have here on the Earth in the heliocentric model. So there's big contradictions. Huge contradictions. But yeah, the effect of gravity, if you're referring to gravity as just things falling at a certain speed, sure. But when you're starting to claim the cause of the effect is mass attracting mass, or the bending and warping of space-time, right? That's when you start getting into the weeds. That's when you start getting into textbook definition pseudoscience. Does that make sense?
Yeah, I mean, when you try to explain such a thing, such a phenomenon, you have nothing except giving an assumption. See what I mean? Like gravity, and that's it.
That's it. Yeah.
So,
Yeah, they'll say like the Earth somehow, like an object somehow generates gravity. How does it generate gravity? Where does the gravity come from? What is the gravity? They have no freaking idea. It's ridiculous. It's just ridiculous when you really ask them questions. It's like, what is the gravity? And how does the mass, the massive object, how does it generate gravity? What is the gravity? They don't have an answer for any of that at all. They'll just say, oh, we have no idea. It just has to be there to have this globe model.
just trying to be fair, okay?
Mm-hmm.
Can't we like resemble this to your situation? Like there are things that you flat earthers cannot explain neither, right? So there might be that some explanations that they cannot explain either. Am I right?
Like what? Yeah, like what? We don't claim to be able to explain everything. We're not claiming a be-all and end-all model of the entire system that we live in. We're not claiming to know everything. Okay, we're claiming that the things that we can test empirically debunk the globe, and that there's no empirical evidence of the requirements to have a globe in the first place. But we don't. Falsification is independent of replacement. We don't have to have a replacement answer to some bullshit, if you know what I mean, right? If they say that they claim to know how something works, okay, and then we say, oh, well, you can't validate that at all empirically. That they can't turn around and say, oh, well, now you have to explain it. You have to explain how it works. It's like a burden of proof reversal. We're not making the claim. Okay, we can explain why things rise or sink very easily. Okay, we don't have a crazy claim here. Okay, we're not claiming a ball covered in water inside a vacuum, a giant space vacuum. We don't need to make crazy claims like, to have that, you need to have gravity. You can't have the globe without gravity. You can't have gravity without the globe. They go hand in hand. It's kind of like the Band-Aid for all of the logical holes in the heliocentric model. Okay, you just say gravity. Oh, gravity takes care of that. Gravity takes care of this. Oh, refraction takes care of this. Refraction takes care of that. It's nonsense. But we don't have that claim, right? We can say, well, why does a helium balloon go up? Because it's less dense than the air. Okay, why does something more dense than a helium balloon go down? Because it's more dense than the air. Okay, why does it go down in the first place? Because it got lifted up, it got displaced. Okay, a rock sitting on the ground isn't ever going to move unless some outside source of energy displaces it. Okay, it's already on the ground. It's never going to go anywhere else if nothing else moves it. Okay, if I come along and I exchange some of my energy to displace the rock, it's just going to re-seek its natural place of rest in the medium. Okay, because it's more dense than the air, it's just going to sink back down to where it was. Or if I push a tennis ball down in the water, it's going to go back up to its place of rest, right, which will be at the top of the tank of water because it's less dense than the water. It's very easy to explain this. It's something that we can test and repeat anywhere, anytime, and we get the same results every single time. And it explains why every single thing in nature goes up or goes down.
I mean, I would like to give this to them, to the scientists, that yeah, okay, we should not expect them to like demonstrate what actually gravity is, because they don't have the literal experiments and tools and technology to like experience the center of the Earth. It kind of is impossible. But the thing is, when you are trying to justify a thing, by you I mean globers, okay, I mean scientists.
Yeah.
When you are trying to justify a thing, you cannot just like justify it with an assumption. See what I mean? That is what is kind of annoying. But because just to make my point, as I have been in here like for 2 weeks or less, maybe all the conclusions and the lines that cross each other between you guys, you flat earthers, and globers is like just refraction and gravity. Okay, that's it. These two things, and sometimes religion. Okay, just these two things. It is not much more. So yeah, as long as we do not like demonstrate gravity, we cannot like go further in the discussion.
Well, yeah. So until then, it's just a concept that they come up with. It's pseudoscience, right? Because they're claiming it as a scientific, something that's been proven scientifically, but it hasn't been put through the scientific method. And that's the definition of pseudoscience: a collection of beliefs or practices mistakenly being regarded as based on the scientific method. That's the definition of pseudoscience. So yeah, space science, a lot of the heliocentric model is based on pseudoscience. Okay, we can back up everything that we claim. Okay, we can back up that everyone's experience, even the globe earthers' experience, is just a flat Earth, right? A flat stationary Earth. That's what we experience. Then we can back up that there's no curvature over distances where there would have to be curvature. Now that debunks gravity at the same time, because if gravity's real, then the water has to be curving at a certain rate. Has to be. Have to have 66 foot of curvature over 10 miles on a globe. It has to be there. And if it's not there, you can't have gravity and flat water at the same time. Impossible. So that debunks gravity. It debunks the globe. Flat water debunks the entire heliocentric model from the start. Okay, because that's the requirement for any of the heliocentric model to be accurate. Now, we can back up what we're saying about gas as well. Okay, so any test that we do backs up what we're saying about gas. All of the mainstream science regarding gas, right? That also aligns with what we're saying. So, then what is their motion? Even Einstein said there's no way to prove if the Earth's moving, orbiting around the sun. There's no way to prove that. He said there's no optical experiment to prove that. It's impossible. So there's no proof that the Earth orbits around the sun. It doesn't exist. It's just a model, theory, a concept, whatever you want to call it. It's not really a model, especially not a scientific model.
In reality, Einstein did talk about the orbit of the Earth around the Sun. That was explicitly said. But in reality, he's talking about any type of motion, because for him, all motions are relative. So not just the orbit, it will be the spin of the Earth around itself too. So for him, you can't distinguish between stationary, a real stationary Earth, not orbiting, but it's still spinning around itself. No, a complete stationary Earth and the one that is moving. So you can't tell which one you're in using relativity. So he explicitly talks about the orbit of the Earth around the Sun, but implicitly he talks about every type of motion that the Earth can do.
You know, and even worse than the gravity, the lack of scientific validation for their gravity claim is the refraction claim. The refraction is the worst nightmare for the globe earthers, right? Even though it's one of their copes, right? It's the only thing they can say. It's the only way that they can try to resolve these observations where we can see orders of magnitude further than you would be able to see on a globe. They're forced to have to use mental gymnastics and spit out a word like refraction when most of the time, they have no idea what they're talking about when it comes to refraction. Absolutely no idea what they're talking about whatsoever. They learn how to say that word with their mouth, right? They don't, most of them don't know anything about it for beyond that, right? And then you ask them to define it, they'll just say, oh, the light bends. And then that explains, right? That explains the observation. It's debunked. We debunked it by saying refraction. They have no idea what they're talking about. As soon as you start questioning them, it's like, what's the mechanism behind it? What's the formula? Who accounted for it in a single observation throughout all of history? And then that observation matched up with the globe. Not one. There isn't one. It's not even possible to account for in totality to say that we've accounted for this particular observation's weather conditions and it matches up with the globe. Now, if we just assume the Earth is a globe, right, and use refraction as a hostile witness based on what the mainstream globe earthers claim about refraction, it still debunks the globe. Okay, because standard refraction is 7/6R. Right, so they're presupposing that the Earth's a globe in their calculation, in their formula. Right, it's also calculated by the refraction coefficient, whereas 0 would be making an observation and it matches up perfectly with the globe geometry, right? As if you're looking through a medium that doesn't have any refraction at all, like a vacuum. Okay, so if you're 1 foot high, the horizon would be at 1.225 miles every single time. Now, then they say that we apply standard refraction, okay, and that increases the size of the globe, right? That's how it's kind of like a fallacious way of talking about refraction, because they're pre-assuming a globe, and then they say, okay, so standard refraction is 7/6R, so it makes the size of the radius a bit bigger. Okay, and with the K factor, right, I was just talking about the K factor of 0, it's the same thing. Now, all of a sudden, standard refraction would be a K factor of 0.17, and it would mean that you would be able to see like 15% further. So instead of the horizon being at 1.225 miles from a 1 foot observer height, it would be at like 1.3 or 1.4 miles or something like that because of standard refraction. They're just inflating the size of the globe by a little bit. Now, there's also not one observation that matches up even with standard refraction. Okay, so you can account for standard refraction, and they say it's standard, right? This is like the average. This is like what it's like most of the time. Okay, so you make an observation, and then you can apply for standard refraction. Okay, account for standard refraction. So, now the horizon should be at 1.225 miles. We'll account for refraction. Now it should be at like, say, 1.4 miles or whatever. I don't know the exact amount, but it's just a little bit further. But that doesn't exist. There's not one observation where the horizon is at that distance accounting for standard refraction. Okay, so where's the standard refraction? That's another thing that doesn't exist either. Okay, we're seeing consistently orders of magnitude further than you would be able to see on a globe. We're seeing the horizon 500% further away. Not 15% further away. Not 20% further away. But usually a minimum of 500%. Usually thousands and thousands of percent further than it should be on a globe. There's not one observation that matches up with the globe to prove that the geometric horizon exists at all in the first place. So refraction is the globe earther's worst nightmare. They butcher it, and they don't even realize that they're shooting themselves in the foot when they say the word refraction.
May I ask you a question, DJ?
Mm-hmm.
So, are you sure about what you said? Because I don't know. I never researched that. So, about refraction, standard refraction. So, when you use standard refraction, instead of like for 6-foot observer, 3 mile point 4 or 6, it will be like 3.8 or 0.9. So that will be the difference if you just take account of refraction?
Standard refraction, yep. It's 7/6R, or it's like it's usually like 8 to 15%.
Okay, and have you ever tried to verify about extreme refraction? What would be the difference?
Yeah, so with extreme refraction, once you start getting more extreme conditions, you start going into miraging territory. Okay, you start getting obvious inferior and superior mirages. Okay, because what's right, so let's go over atmospheric refraction. Okay, we don't even need to talk about flat Earth. This is just using it as a hostile witness, right? This is the mainstream definition of atmospheric refraction in the side chat here. So essentially, the light will deviate towards the denser medium, the denser portion of a medium. So it's similar to Snell's law, okay, that the light will deviate towards the denser medium, except we have a different situation where we just have a gradient inside a single medium. Okay, so instead of instead of it just deviating at that sharp boundary layer between the two mediums, it slowly deviates, right, towards the denser portion of the single medium. Right, and that will cause these small effects when you don't have much of a gradient within the single medium. You just have a tiny little change in the refractive index, and you just get very slight effects of like a little bit of looming or sinking. Right, but once you start getting a steeper gradient, which would be what they consider like more refraction, strong refraction, super refraction, these kinds of things, that's where you have like a very steep gradient change, where you have an inferior mirage, for example. The easiest one to test, you get a hot piece of concrete and then you look across it. You get down low and you look across it. And because the hot concrete heats up the air just above the surface, right, the air, it goes from very hot to very cool very quickly. And the light will deviate upward towards the denser medium. Okay, and that's when you'll start getting that inferior miraging effect. And it will cause things in the distance to look like they're displaced downwards, and you'll get total internal reflection because the deviation of the light, it goes over your head. Okay, it doesn't go into your eye, it goes over your head, and that's when you see that mirroring effect on the ground. So once you start getting beyond this standard refraction, you start getting miraging effects. Okay, we're not presenting observations that have these miraging effects.
Yeah, and the point of my question was because I was surprised by that small difference between no refraction, and if you account for standard refraction, it would be that small difference from 1.2 miles to like 1.6 or 5, something like that. So it's just small difference. So we may say that, yeah, we accounted for standard refraction on those observations that are magnitudes farther than that that horizon and where it should be with that standard refraction. Like, for example, with our black swan observations. So if they say that, you didn't account for refraction, we can say that, yes, we accounted for refraction, standard refraction, and that's magnitude farther than where it should be. Accounting when refraction is there. So 10 miles is not like the 1.6, or even you can give them 2 miles with standard refraction, but that's not 10 miles like in the black swan.
Yeah. So 1.2 miles plus strong refraction, say 20%, right? That just makes it 1.47 miles. But we see the horizon way beyond 10 miles.
Yeah. So
Yeah,
if
it's
someone
thousands,
says that,
it's over 1,000% in that situation. Further.
so if someone says that you didn't account for refraction, so are you denying refraction? We can say that yes, we accounted for refraction. So with refraction, it won't be that far, 10 miles. It will be this and this, those specific distances that they give in the proper model.
Yeah, it's atmospheric refraction just in itself has nothing to do with the Earth being a globe. The definition doesn't say anything about the Earth being a globe, and you can demonstrate it in your living room, like sky freeze observations. Okay, you can set up some blocks across your flat floor, and then you can manipulate the temperature conditions in the room, and you can make it look like the blocks start to go over a horizon. The only thing that was manipulated was the temperature, and that fits with the definition of what atmospheric refraction is. It has nothing to do with the globe. The globe earthers, they take that and then they hijack it, and then they try to bake their radius value into it. That's when it starts getting into the fallacious territory, right? Because they're begging the question, and they're trying to account for certain observations by including the globe in, and they're just basically trying to increase the size of the globe. Now, this is the crazy thing. So that's why I was saying earlier, we don't need to worry about flat Earth. We can just say, if we assume the Earth's a globe, to explain the observations that we have, you would have to have so much refraction that the Earth would look flat. Okay? Because you can use Walter Bislin's calculator, and it has a refraction slider, uses the refraction coefficient, and it has a scale between 0 and 1. 0 meaning that there's no refraction at all, and 1 meaning that there's so much refraction the Earth would look flat. Okay, so that means that if you've got something hidden in the distance that's 15 miles away, something visible in the distance that's 15 miles away, it should be hidden by a certain amount of Earth curvature. Okay, you need to slide that refraction slider up to 1, or just close to 1, to have no hidden height if the Earth were a globe. And that's the case in nearly all of the observations, right? Like the Great Salt Lake, the windmill ones with Dr. John Dee, the 3-inch lake observation in Canada, the Black Swan, right? You have to slide that refraction slider up to the point where there would be so much refraction that the Earth would just look flat anyway. That's how ridiculous it is. Okay, and then you start looking into how is that possible? Has anyone ever measured that? And what sort of meteorological conditions would have to be present to have that much refraction on a globe? Okay, and it's impossible. And especially impossible to have such consistent results of being able to see too far.
By the way, I watched the Black Swan, video, and I was like analyzing it sentence to sentence, and I even like checked the numbers and the calculations for the hidden heights needed to be applied to the turbines in the distance for each of them, like 8 mile, 8.3 till 11 miles. Okay, and I know that any kind of considering any kind of refraction to justify the non-existence of that hidden height on those turbines would be kind of ridiculous. Okay, I admit that. But the thing is that lady that was explaining the whole theory, she himself, I'm sorry, she herself told that there is a big mirage, like in some of the like in some distance. But I'm just curious why she didn't imply it in her calculations.
There's no miraging effects between the target, right? So the wind turbines don't show any sign of any mirage that exists whatsoever. It's crystal clear. It looks the same as what it looks like from close up. The right out, really far out into the ocean, you're going to start getting some disturbance because you're looking through a really thick air over a huge distance, right? Like you can see the boat that's 14 miles out. Okay, if the Earth were a globe, you wouldn't even be able to see that boat at all. Okay, and then in some of the footage, there's another boat that's even further out than that. Now, there's so much air between you and that boat, you're going to get some effects. You're going to get some atmospheric effects that happen over that distance, right? That's such a long distance, and you have all of that air, right? So over huge distances, you're always going to get some effects that are going to be taken into account. But looking out at the turbines that are 11 miles away, it's extremely clear, right? There's no waves. There's no wind, obviously, because there would be waves and ripples and things like that. So there's hardly any wind. Okay, and then there's no miraging effects on those windmills. Okay, the windmills look the same from 12 miles away as they do from close up.
Yeah, you can bring up.
So what miraging effect? Like what miraging effect is there? Like, look, I'm going to post a close up. Right, here we go. Just a second. I've got it right here. Okay, so this is what they look like close up. And
you can bring up types of mirages, and you can see the observation that won't align with any type of mirage. There is no mirroring, no upside down image, nothing.
Yeah, so have a look at the images here. Okay, so look at the pole on the right hand side of the first image I posted, and then look at the poles from 12 miles away, 11 miles away. Looks the same.
And besides, you can't have a mirage on a ball. You can only have them on a flat Earth.
Yeah, Dr. John D actually goes into detail towards the end of that video about how mirages, inferior and superior mirages, are impossible on a globe.
In the same video?
In the same video, yep. Towards the end.
That.
Oh, yeah, it's really good information. He shows examples. He goes over it step by step. So yeah, I don't see any mirage here. Like, there's a list of different miraging effects. Okay, so we can count them off one by one. Okay, so Fata Morgana. Okay, obviously this is not a Fata Morgana. Doesn't have any of the characteristics. Okay, cross that off the list. Superior and inferior mirage, right? They both have total internal reflection and they're super obvious. Okay, superior mirage will have things look like they're floating in the sky. Inferior mirage will have things look like they're sinking, cut off bottom up. And both of them will have total internal reflection and just optical chaos, right? Okay, so we can cross off those two, right? So now we've crossed off the three main types of mirages. Okay, after that we have towering and stooping, which is when things look stretched out, being towering, and when things look squished and compressed, which is the opposite of towering, it's called stooping. We don't have that in this either. Okay, so that's most of the mirages crossed off. Now, what do we have left? We have super mild versions of inferior and superior mirages called looming and sinking. Okay, so those are very, very minor effects. Neither looming nor sinking is going to flatten out 11 miles of water and allow you to have no obstruction of things 11.2 miles away, right, from a 3.5 foot observation height. Impossible. Okay, that's pretty much it. That's all of the mirages accounted for, right? So, yeah, it's wouldn't be a good rebuttal.
Is impossible.
Oh yeah. whole bottom looks like it's missing, right? Okay, so that's just a random picture of the ship. Yeah, so some glober could cherry pick this and say, look, it's behind the curvature of the Earth. Yeah? No, this is a known effect, right, called sinking. Okay, it usually happens during the night or early in the morning when the water temperature is still much warmer than the ambient air temperature above it. Okay, and it causes the light to bend upward because light will deviate towards the cooler air because it's more dense. And it can cause things in the distance to look like they're sinking. Okay, it's like a form of an inferior mirage. Now, what this guy does is he actually stays in the same location, and as the temperature warms up, okay, it exceeds the temperature of the water. Okay, so this sinking effect starts to go away as the day goes on. So over the next 3 hours, he keeps zooming in from the same location on the same boat, which is anchored. And then 3 hours later, we can see the entire boat again. So I'll post the...
Did you do this
video.
yourself? And if not, how do you not know that this is fake?
No, it's not faked, right? So, because now
How
we're
do you
going to... Okay, so there's tons of examples of this, right? And it's a well-known effect that happens. And also there's a video that goes along with it. So how do you think do you think the video is CGI? Is that
so the reason I am being facetious, but the reason I say this is because I can use your same logic against you. And if you show me a video or picture, I can say what the flat earthers say. Well, it's fake. It's CGI. Do you see how it's like a
no? When did someone present a long distance observation that we said was CGI? Name one.
Well, not in this current conversation, but I can send pictures that you have to admit is CGI, otherwise it debunks the flat Earth model.
Is it a long distance observation?
It is indeed.
Okay, go.
Hold
on a second. Hold on a second, now, because I'm not finished my point yet. But I'm going to hold you to this because that's absolute nonsense, right? No flat earthers claim that any long distance observations done in an analogous to the ones that we're talking about, like from the Earth, right, looking out over large bodies of water and whatnot, a CGI. No one's claiming that. That's ridiculous. Okay, so what I'm going to do now, I'm just going to post some citations from subject matter experts
from
which are global. No, .edu, all .edu, Oxford, like physics books. Yeah, so let's go over them, right? Because you don't have any idea when it comes to atmospheric refraction, right? Globers don't do any research. They just learn how to make the noise with their mouth, refraction, and they think that fixes the observation.
Yeah, right, got it. Can you do me the due diligence of putting that picture I sent you in the chat, please?
No, not yet, because I'm not finished, right? So because you're going to have to throw the mainstream science under the bus right now. Okay, so do you agree? You know what sinking is? You know what inferior mirage is?
I'm aware of inferior mirage, yeah.
Yeah, so sinking's a form of inferior mirage when you don't have enough of a temperature gradient change to cause the full-blown inferior mirage with the total internal reflection.
Let me interject here, please, because it was
you can just listen to this, bro. Like, I'm gonna read out the citations now. Yeah, it doesn't matter.
All right,
doesn't matter. Okay, so
You're
Andrew
quite
Thomas Young.
scatterbrained alcoholic. Sorry to interrupt you.
Yeah,
but just
Andrew Thomas.
Take a moment and listen to what DJ is trying to explain.
I've been doing that for the past 5 minutes.
Listen to Andrew.
A TikTok brain, man.
Yeah, listen to this. Is not me talking, right? This is Andrew Thomas Young's words. I'm just reading them out. Okay, so optics of the atmosphere, reports on progress in physics. Okay, so atmospheric refraction can bend light rays in such that.
Who's Andrew Thomas Young?
You can look him up. He's like a leading subject matter expert. He's got his own .edu website. Okay, right. He's like one of the experts that writes books on refraction and miraging and that kind of thing. He's known as like the leading expert on refraction and that kind of thing. You can look him up. Anyway, so basically, I'll just be quick, right? So atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. Okay, and then it goes on to explain how it happens. Right, there's another citation under it, and look, just the last one I'm going to read, right, it's from Oxford. Okay, what is sinking? Okay, a refraction effect in which an object normally visible on the geographical horizon apparently sinks beneath it. Okay, so if you guys want to show an observation that perfectly matches sinking, the definition of sinking, the mainstream definition, and you haven't accounted for that, right, then that we can dismiss that observation as being the cause of it being Earth curvature. Because you haven't accounted for the variables and also ocean source. All right, now I'm going to check your.
Yeah, so this is why I asked you to put the picture that I sent you in the chat, because I think this is
twisting
difficult.
torso. Wow, never heard this one before.
Say what? Twisting what?
Twisting torso, turning torso.
Yeah, I don't know what that is.
It's the name of the building in your observation.
Right. So I'll put it in the chat for everyone to observe. So
fucking hell. Really? This is what took you 20 minutes to fucking post?
Did it? Did it take me 20 minutes?
Yeah.
Yeah, the photo's taken from the north looking to the south, and so the sun reflecting off the water is distorting the image.
No, but why the further you get away from it, does the building appear to descend?
It's called diffraction.
That doesn't explain it. You just saying
it does explain it when you understand physics.
Can someone post him the windmills being stretched and distorted?
Yeah, I mean, windmills are an interesting one because the whole southern hemisphere doesn't actually make any sense on a flat Earth model. And I know you don't. You say you don't have a model.
But hold on, keep your fucking scatterbrain yourself, man. One thing at a time.
This guy, man.
You're jumping all over there. You're going to go with southern hemispheres, blah blah blah. Let's just go through your shitty observation here. Explain to you how you're not understanding what you're looking at.
The David Weiss app doesn't mean that you know more than what physicists.
What are you talking about, man? We're the guys that attempted to invite David Weiss in so we could school him on fucking how to do his presentations better.
What do you think about the final experiment?
We're not talking about that.
Not an experiment. Debunked, Jared.
Do you think it was rigged?
Debunked. No, I don't think it was. What do you mean by rigged? What
do you think it was fake?
Was what fake?
The final experiment.
Like, no.
You do know we already established the Earth was flat like long before that came into existence, right?
No. See, so usually flat earthers.
No. They went away with their own like straw man model of what they think the flat Earth is.
Flat earthers say
to debunk that. So
that there shouldn't be a 24-hour sun in Antarctica. Lo and behold, there was. So you have to just say that it was CGI or
based on what?
Yeah, so the heliocentric model will predict that there's a 24-hour sun in Antarctica. Of course there was, because the Earth's not a pancake.
But we've already established the surface doesn't curve. You get that?
No, but
like that was an objective fact of reality when they were setting up to go and do the final experiment, thinking something in the sky may save the globe when it's already been empirically destroyed. So
just entertain me.
Whatever the sun is or isn't doing, whatever the validity of that experiment may or may not be.
Can you at least try
doing it over a flat surface? Sorry to report that to you.
At least try.
Try what?
Try and explain why there wasn't a 24-hour sun.
I don't have to. This is not 24-hour sun server. Flat Earth. The ground measures flat.
No, yeah, sorry, that's what I meant. How there was a 24-hour sun. The Flat Earth model predicts that the 24-hour sun is impossible.
No, it doesn't, dude. Right, there was some dumbass flat earthers trying to claim that the AE map globe projection, right, was the map of the flat Earth.
So what model do you go by?
We don't have a model, dude. We don't claim to know the shape of the Earth, right? But you've got a model that we debunked easily every single
DJ,
observation.
Here's the issue.
No, bro. Here's the issue, right? You try to straw man us with a model, okay, that we don't claim, and then you laugh because we don't claim it. We're not even claiming to know the shape of the Earth. Now, you guys claim to have a model that falls apart, right, at stage 1, curvature, right? You don't have a model that matches reality, right? And you think a model, you don't even know what a model is, most likely. You think a model is like a mini version of an object, most likely. Okay, we're not claiming an object. What do you think a model is then? You're talking about a scientific model? Define what you mean by model.
Yeah, I'm not talking about a fucking miniature globe, am I? I'm talking about something that has predictive power in determining what will happen, and it correlates with what we observe.
You guys always parrot that phrase predictive power, but you never demonstrate any predictive power from your model.
Well,
yeah, what does it predict? What does it predict?
You'll go to eclipses, you'll claim, oh, we've got the predictive power for eclipses, and then we'll show you. No, you
Einstein
actually
said,
don't.
if I'm right,
Bro,
this will happen on this date. This lunar eclipse or solar eclipse or some shit.
Right. So if your model is accurate, the surface
predictive
should
power.
be curving at a specific rate. We go out, we measure, we don't find that curvature.
Well, we do, because
model's wrong.
everything,
Get over it, bro.
the physics follows that the higher we
No, you
rise,
don't. No, you
the
don't.
more the horizon
You don't even know
descends
how to
below
begin
our
to
eye.
attempt to prove that you may have surface curvature or not. Look at the
So
observations
I'll
you're
put another
posting.
picture. DJ, if you do me the honors of putting this picture in the chat.
Yeah, hold on. After you back up your claim, right? You can't just claim stack. That's what you keep doing. You keep shifting the goalpost and just changing the topic from one thing to another as you keep getting owned on the previous thing that you brought up. Okay, now you said that you have a model that makes predictions. Okay, what predictions does your model make?
Well, as I said, things like lunar eclipses, solar
No.
eclipses.
Those would be postdictions. Okay, and that would have been flat. That's based off the Saros cycle, which was invented by flat earthers. Okay, so what's next? What else have you got? That's a F, big L on that one. So what's next? What else can you predict? Predict, not postdict, right? Not something that happens in cycles. That's been happening for all known history, right? And we know that it's going to happen on this particular time.
Yeah, so if you're depending on what hemisphere you're in, you can predict what these celestial bodies will appear to rotate as.
How are you predicting that? It's been recorded since before anyone thought the Earth were a globe. Hasn't changed since then.
It's like, so he just explained the Saros cycle to you. You think they paid enough attention to discover the cyclical nature of eclipses, but they just ignored all the stars and the constellations while they were at it. Didn't track any of that.
Eclipses.
Yo, hey, Talis of Miletus, who predicted an eclipse, was he a flat earther or a globe earther?
I don't know who that is.
He's the guy that first predicted the eclipse.
Well, it depends when it was. I mean, all people were flat earthers at one point.
Okay, well then, if he was a flat earther and he predicted the eclipse, how'd he do it?
Whimsical luck, I guess.
Whimsical luck. Wow, dude.
If I'm to give you the honest answer, fuck should I know? I don't study this shit. And
Yeah. You know what else you don't know? You don't know how they predict eclipses now.
That's true.
You don't know either.
That's true.
Exactly. So then how in the world are you trying to use it as evidence that you know anything?
I'm taking a scattergun approach, just saying why I believe that the Earth's probably a globe.
Well, let's do predictions. So if the Earth was a ball and the Moon was a ball, and the one ball was casting a shadow on the other ball, that would result in a complex curve. which would be evidence with a sinusoid pattern, which is exactly how it looks if you take an actual ball and try to cast a shadow on an actual ball. So since you never see a sinusoid on the moon, it's not the Earth's shadow and of anything
What is
being
it
a
then?
globe. Doesn't matter.
Is it like raw or what's it like?
It doesn't matter, dude. You made the affirmative case that it has predictive power and that these things are the shadows of one object and the other. It doesn't match actual modeling, so it's false.
If you say it's not, then shouldn't you at least try and?
No. I don't care. Okay, you could think that I should or shouldn't. Appeal to my motives is irrelevant. Your claim. No, I don't need to make a system. This is the problem with you.
It's like consistent.
No, I don't need to be consistent, dude. What in the heck? No, bro. See, in your interpretation, you think the name consistent means, or the word consistent means that if I debunk your claim, that I have to have some other claim. That's not true.
I'd say it would help to, for example, if you say that evolution isn't true, it would help for you to present a worldview in which what could replace evolution. For example, even if you say God did it, I can at least be sympathetic to that view because at least you're trying, as wrong as you may be. If you say that...
It doesn't matter. It doesn't matter, dude. If you have an idea about how something happened and somebody debunks your idea on its face, they don't need any counter story. Your idea is debunked. Okay, you may not. Listen, you can reject someone debunking your claim by simply saying, "Well, you don't have a different view about what's causing it, and that means you didn't debunk mine." That would be illogical and retarded.
Okay, so just to entertain the conversation, what would you speculate that it is?
What is?
That is causing a lunar eclipse.
Who knows, dude? But describe a lunar eclipse to me.
Well, it's basically when the Earth gets in the way of the...
Oh, no.
Sun and the moon.
No.
They line up.
Not give me a story about what you don't see. Describe what you actually see when you see a lunar eclipse. Describe what you actually see.
Well, it just looks like a body is passing over the moon.
No, dude, you're doing more inferences. Try your hardest to actually reduce it to the actual observation if you can, sir.
I can't deduce it anymore.
Well, let me help you out.
It's passing over the moon.
No, it doesn't, dude.
All right, what does it look like then? Please enlighten me.
Okay, it looks like the moon, right, is bright in some parts and dark in other parts. That's what it looks like. And then the darkness appears to move across the face, and there's more darkness and less brightness. That's what you actually see. All the rest of the stuff you said was pure inferences and imaginations. You never saw any of that.
It's empirical observation. No, I can guarantee you I did. Else, what was that?
Okay, so your claim then is you saw a body in between, and you saw it moving. No, you didn't, sir. And if you say you did, we all know you're lying.
So, I saw something pass over the moon. It seemed like a body.
No, you didn't, dude. No, you didn't.
You can keep saying that, but you're not actually saying anything of.
No, we all know you didn't. So here's the thing, brother. In the arts, we practice this thing with the children. It's called draw what you see, not what you know. Okay, if you're going to draw a moon that looks like an eclipse, okay, what you're going to draw is you're going to draw a circle, and then you're going to color a portion of the moon in white, or whatever color you think the moon is, gray, whatever, and then you're going to darken the other portion. That's how you represent what's occurring. Nowhere in there do you have to draw another body, because it's not in the information present.
Okay. So if it's not another body that's obstructed, then
what?
If it's not a body that is obstructing the moon, then what is it, in your humble opinion?
Okay, let me help you out, friend. I'm going to tell you this answer, and this is the answer. And it is the true and genuine answer. And it has no bearing on the fact that I previously debunked your answer. So here's the answer. 3 simple words. I know it's hard for you to comprehend these words. It's called I don't know.
I appreciate that answer. Now apply that.
Now, since I said I don't know, hold on, friend, be honest here. Since I said I don't know, does me not knowing have any bearing on the fact that when you actually model a sphere, casting a shadow on another sphere, it gives you a sinusoid shadow, and you never see that type of shadow or form on the moon, and therefore it can't possibly be a sphere casting a shadow on another sphere?
Yes. So that answer you gave me it gave me a bit of hope. That was a stroke of sentience that I detected there that you don't know. Now, could it be possible that maybe you just don't know as much as you think you did, and you're the physical embodiment?
Hey, how about you answer my question about the fact that a curve casting a shadow on another curve results in a complex curve. We don't see a complex curve on the moon, therefore it's not a shadow in that manner. Oh, like a sinusoid, an S, a wave, instead of just a singular continuous arc?
Can you give me some evidence for that, please?
Sure. I'll also give you a demonstration that you can do. You take a ball and you take a light and then you cast a shadow on another ball and then you see what happens with your own two eyeballs in your head.
If I can share my screen, I'll do it live. And then if it works, I'll admit that I'm a flat earther. I've got a globe right
now. No, wrong,
allow
sir.
me to share my screen. And
you will not admit you're a flat earther because we will not allow you to be retarded. We will tell you that what's occurring on the moon doesn't determine the shape of the earth. So we will not accept your conclusion that you're a flat earther because the shadow on the moon is not the shadow you thought it was.
Would you believe me if I said I was once a flat earther?
Not for those reasons.
No, but I genuinely not taking the piss. I once was as retarded as these people. I actually thought the earth was flat.
What?
Listen,
dude. Stop. Listen, hey, dude. Stop gaslighting yourself, okay?
I do. I'm not lying. I'll prove it. I'll actually prove it.
Well, what you might present is that you accepted the Earth is flat as a proposition for stupid reasons. That might be what you present. And then because your stupid reasons were contradicted, then you said, "Oh, I might as well just, get on my knees and take NASA in the face."
Yours. All right, I'll give you my reasons. The biggest one for me was the gas pressure argument. They said that.
Okay, fair enough. That's irrelevant to the shape of the Earth. Move on. That's irrelevant to the shape of the Earth. Move on.
I'm giving you my reason as to why I thought it could be flat. It's because they said that gas pressure can't exist next to a vacuum, and I thought about it intuitively, and I thought, you know what? I think they might be fucking on something. How can it possibly exist adjacent next to a vacuum? But then I guess I just stopped smoking copious amounts of drugs and I came to my senses.
Okay, so you actually didn't think about it. You actually didn't think about it at all, and you gave no conclusion as to why it was certain that gas pressure requires a container, or that you reasoned yourself out of that position. You just said, "I stopped taking drugs and I changed my position." So that makes no sense.
I can explain it.
No, I don't care. I'll accept that you changed your mind on that because that wouldn't tell you whether the Earth is flat or not. So get to the part where you had a piece of evidence that convinced you the Earth was flat.
So that was one. The other was long distance observations. I thought things like the Chicago skyline was, given the maths, that's 6 inches per mile squared or some shit, 9 inches per mile.
Yeah, you got the evidence. You got the evidence that you were ever actually in this position, and you're not just retroactively creating a story to give yourself a sympathetic leg up in the conversation.
So frankly, why would I sabotage my reputation by admitting that I was a flat earther? I'm just saying this purely just
for sympathetic argumentation, dude. Duh.
So if I can share my screen, I'll show you the books. I've got 100 proofs that the Earth's not a globe.
Yeah, you're not sharing your screen, man.
But mate, well, if you want proof, I can give you proof.
Nobody fucking cares, man. You're just deflecting with a stupid fucking tangent to get away from all the points AI's making to you.
Yeah,
you don't actually ever answer anything. You don't address nothing, man.
All right, and present the question.
Oh, by the way, alcohol, bro. I did your art homework for you, and I'm going to give you the answers because, I realized you weren't a very good art student, and I didn't have time to take you through 3 years of art. So I just did your drawing for you. and I'll post it here shortly after you tell me your third reason why you were a flat earther.
What type of art do you do? Oh, sorry. Yeah, I'm not trying to tangent. The third reason, gravity was again. This is why I say I was a manifestation of the Dunning-Kruger effect. I didn't know anything, so I thought this was simple. I thought, well, it must be flat. Because I didn't understand it, it seemed easy to me, and then I realized that it's all bollocks, and it's a lot more complex than I can possibly fathom.
All right, wait, one more time. Repeat that third one for a second.
Gravity.
Oh, gravity. What about it? What?
This guy should be banned for being a liar. Why?
No, just like, what about gravity? I mean, all I heard was you just said the word. You didn't explain anything about it. Like, why is it relevant?
Yeah, so basically I just thought, why does like the three body problem?
You were a flat earther. Someone came along and said gravity to you again. You became a glober again.
No, I'm saying
what you're
if you tuned your ears in, you'd know what I'm saying. I'm saying gravity was my lack of understanding in gravity was one of the reasons I thought it was flat. I thought the whole
perfect. Right. So you have a more advanced understanding of gravity now. Can you go through it with us?
When I envisioned the heliocentric model of all these fucking marbles,
can you describe your misunderstanding of it first, actually, and then
let me get a sentence
give
out.
us the updated
This will
one?
go a lot smoother if you just let me get a sentence out.
No,
I imagine the heliocentric model of all these fucking tennis balls spinning around each other, and I thought the shit makes zero sense. How they don't interact with each other or collide, or so again, my understanding of gravity was one of the reasons.
I'm sorry, bro. You are a fucking larp, aren't you?
I'm just giving you my honest fucking.
Well, then I agree. You shouldn't have become a flat
Did you
earther
say
in the
you got
first
off
place.
the drugs, by the way? You shouldn't get on them more.
Well, that's a whole different conversation.
Because do you know
your
that
original
someone that thinks
misunderstanding
that
of gravity is because you were thinking about tennis balls.
one sec. Someone who thinks that they live on a ball can have that misconception as well, bro. They can have that lack of knowledge about the supposed dynamics of a solar system, of planets orbiting around the sun.
Sorry, I've just
so you should not have become a flat earther. If that was your basis for becoming a flat earther, you shouldn't have.
Yeah, no, sorry, I just realised what it was about gravity that didn't make sense to me. It was.
What was
I
it?
was thinking if gravity is that strong to hold all of the oceans to the Earth, how can like birds and butterflies and shit fly? Like, shouldn't they be like magnetized to the Earth? Again, I don't know if I.
Hey, dude. Hey, alcoholic. What you just demonstrated is why we're so scrutinous of each other in our forums. We don't let these retarded flat Earth arguments that supposedly have anything to do with the Earth being flat fly in our forums, bro. We scrutinize them to the umpteenth degree. That's fair, bro. Listen. I agree with you that that might have blow smoke up your dress, and for a fleeting second you thought you were something other than what you were versus a glober versus flat. Okay, we understand that, but those are stupid arguments. Okay.
Of course they are. That's why I'm not a flat earther anymore.
No, dude. None of those arguments, except maybe the long distance observations, has anything to do with the Earth being flat. It should have never made you a flat earther, nor should it have made you not a flat earther.
Of course it does. So flat earthers don't believe in gravity.
Can I tell you what made me a flat
God,
earther?
dude, you're dumb, dude.
Can I tell you what made me a flat
real
earther?
quick, obviously, B, before you go on, I just want to point out to the audience what he just said there is very telling. He didn't say what made me accept that the Earth is flat. He said a flat earther. This is what flat earthers say. So he was just associating with things a group says. All right, go ahead.
I'm saying what I believed, but yeah, go on.
Yeah, so precisely what made me realize the Earth was flat was that there is no curvature in reality. Therefore, we can't be on a ball.
What about the pictures from satellites and stuff?
Who gives a shit? Go out in reality, doesn't verify as what's in the image.
So it's up to you to disprove these pictures.
No, sorry, who gives a shit? Go out into reality, you can't find curvature. Doesn't line up with what's in the image. The image is bullshit.
You're essentially saying, but what about this thing on TV, bro? And he's telling you about reality, going outside into directly experiencing physical reality, and you're saying, yeah, but the TV screen, bro.
Well, who gives not necessarily. It's I think if you're going to say it's CGI, I think it's the burden of proof is on you to
I'm not
explain
saying
why
it's
it's
CGI.
CGI.
I'm not saying it's CGI. I'll give you it. I'll say, okay, this may be true. All right, let's go verify it. The image presents a spherical Earth, meaning there's curving surface, right, at a certain rate. We go and test for that. We don't find it in reality. So you make of the image what you will after that fact, right? And if you still want to assert it's real, then you might need to go in for like some tests. But that's to do with you.
Yeah, so my understanding is certain buildings have to take into account the curvature of the Earth.
Can you address what was
That's incorrect, but find some supporting evidence for that baseless claim.
Yeah, it's baseless. I will try and find some evidence. Give me a sec.
Hey, make sure you find the article that I've already critiqued 100 times about the Verrazano Narrows Bridge, in which the guy doing the article specifically states that the variance was never actually measured in practical reality and they only applied a model. Yeah, make sure you find that article, bro.
I'm sure he will.
I don't care.
Alcoholic, you got a bad habit. Somebody asks you a direct question and then you deflect to something else. It's like you're your own ex-girlfriend.
Presupposing I ever have touched a woman to begin with.
Well, to be fair, a lot of women have boyfriends who think they're boyfriends, but they're just using them, to take them to meet Chad. Can I get a ride?
Is it like your wife's boyfriend?
So yeah, alcoholic. In everything you said about your time as a flat earther, you never once mentioned the ground. That's pretty fucking stupid, wouldn't you admit?
Right, obvious. See your profile picture. What that is.
I'm not talking about my profile picture.
No, but just hear me out. Hear me out, please. This is very important.
No. Don't you think it's fucking stupid?
All right, go on. You
the very thing in contention was never even mentioned in your list of reasons why you were.
Well, he came close. He said long distance observations.
Please.
No, he said no. I'm correcting him. He said no long distance observations. But he never.
Yeah, that was one of my.
He never substantively parsed that out.
All right, so hear me out.
Well, I missed that part when you said that, so I retract what.
Yeah, because you've got selective hearing. You.
No, just missed it. Right, so, I just turned my attention for a second. Very important. Listening to everyone else. Gas pressure argument and then fucking tennis ball gravity.
I don't care.
Yeah, it wouldn't be such a big deal if you actually were a flat earther for them reasons. And you can tell us the reasons, and we say, yeah.
What reason do I have to lie about
their weak argument? No, I'm not saying you're lying. I'm just saying if you would go about it a bit more respectfully, right? And you don't have to interject with things like I used to be just as retarded as these people.
Am I being disingenuous? Did I say
we would
that?
just, as I told you, said, oh, all right, yeah, you fell for some pretty weak arguments,
That's true, yeah. Hence why I came out.
Would you like us to tell you proper arguments that the Globers can't refute?
I'd love for you to explain your most convincing arguments as to why you think it's flat.
That's what I'm saying. If you would just come into this engagement like that, we'd be more than happy to.
Do you want me to hold your hand or something?
And yeah, you did turn it into, I used to be A, like you guys with a bunch of pejorative connotations attached to it. That is what you did, my friend. And we all heard it with our own ears. But nice try.
Yeah, and we're explicitly not like you. We didn't fall for some dumb ideas and Dunning-Krugered our way into a belief in a flat Earth and then jumped out of it into a belief in a globe again with no evidence.
Yeah, cool. So, what is your best evidence that it's flat? And
ground is measured flat.
Can you back that up with a source?
Yeah, a bunch of laser measurements.
Let's see it. Let's see it. Because respectfully, I'm not just going to believe what you say. I'm not going to.
Yeah, I'm not asking you to believe me. What I'm asking you to do is go out and check the ground for yourself. That's how we got all these laser measurements.
Well, can I see it? Can I see an example of it?
Yeah, I'm looking for stuff to drop for you in the chat.
Don't worry, alcoholic. While he's getting that, I told you I'd help you out. If you go scroll up to my last post there where I tagged you, I did your artwork for you, and I posted what the flat Earth horizon would look like if the Earth was flat.
Where's this?
Where you have the sky, you have the water. This is it's in the chat, dude.
That blurry ass fucking.
Yeah, dude. You said if it goes out, it's going to be blurry. There's going to be like a blurriness between the water and the sky. And so, like, I drew it for you because you were having trouble. So I just was helping you out.
More blurry than that.
Dude, that's really blurry, bro.
Essentially, what I mean is like a fade from blue to.
Hold on. Okay, dude. Let me help you out. I'll do it. I'll even make it even more blurry, okay? Good grief, dude. Give me a second.
Let's just reduce
hold on.
Your pixel.
I know, yeah, just 1 pixel. A gradient of 1 pixel. 1 pixel gradient. All right, hold on, bro. I'm going to help you out. All right, now, okay. Now, you better accept this one, dude, or I'm failing you for my art class. All right, here it is. I'm not going to ping anybody. I'm just going to post it.
David
right?
Weiss video, man. Jeez.
All right, look at that, dude. That's the horizon on a flat Earth home.
Accept that.
All blurry, all really blurry. Okay, is that blurry enough for you?
It's close, but yeah, I'll accept it. I'll let you off.
You will? Okay, great. Now let me show you where I took that photo. Everybody, look in the chat. Everybody see what I did there? You got played, fool.
Oh, you little minx.
So what you showed us there was a building disappearing off into the offing and into the angular reduction limits and a blurry horizon, just like you said would happen if the Earth was flat. There you go. The Earth's flat.
Oh, what's your explanation as to why the building is disappearing bottom up?
I just told you.
Well, that's not an explanation, is it? You can do better than that, surely.
Yeah, well, here, step 1. People are mistakenly think that we see an ideal perspective. We don't. Ideal perspective is an artist technique. It only exists with perfect lines and rays. And in reality, light interferes with itself.
I'm really intrigued.
Let me see. Maybe I will. All right. However, okay. I got an artwork that I'll post here shortly, which is exactly analogous to what we're talking about.
No,
but the moral of the story here is that we don't see in perfectly linear perspective because light is actually physically present in the world and it doesn't exist as an ideal space. So light can actually interfere with itself. The available angles that you have in your angular field of view are limited. The available resolving power of your sensor is limited. The light interferes on the sensor. It also interferes when it passes the aperture, which is the hole, which is where the Rayleigh criterion comes from, which is what determines your angular resolution maximum capacity. You then have other effects, obviously, here, like the atmosphere, all kinds of compounding effects. It's not just one thing. But angular resolution loss alone is sufficient to make the bottom of something disappear once it reaches a critical angle.
Meanwhile, in order to reify the globe into existence, you must ignore all of that and just point and say, "Oh, it's a globe."
Well, I didn't do that, did I? Again.
Oh, yes, you did.
Yeah. Oh, right, I did. Yeah, cool. The analogy I gave of if you're standing above a table and you move a coin further and further away, that coin will never descend below your eye level. It's physically impossible. There's no law of perspective that will allow that to happen. Case closed.
Dude, what I just tell you? You completely glossed over the fact that ideal perspective laws don't apply to reality.
So what do they apply to?
Just like there's no platonic shapes in reality. You didn't know that ideals don't exist in tangible, three-dimensional, free space reality? You aren't aware of that? What, do we need to go back to school or something?
You're just saying a load of words that just think.
Oh yeah, I'm saying a lot of words. Are they too big words? You want me to do them again in Play-Doh?
Yeah, he needs to go back to school.
Interpretive dance.
Yeah, if you can.
Here's another. I got another artwork for you, bro. Here you go. There you go. I gave myself an A+ since I'm a fully accredited art educator. There you go. A+.
No, right, that's good. I can work with that. Right, so from that perspective, the yellow dot, if you've got an object that's moving away, further and further away, it will never appear to descend below your eye level if the Earth's flat. It's just it's a fundamental fact. It's how.
It's very easy to show you. If you stand underneath a light pole, will that light pole ever appear to descend down below your eye level?
That's a really good question. I'm glad you brought that up because it highlights your abject spasticity. So it will appear. Oh, hear me out. Yeah, and let me.
All right, go ahead.
So the lampposts will appear to descend. Now.
Oh, it will.
Oh, Trace, please calm yourself.
I thought you said it wouldn't.
Oh my god! Fucking tune your ears, son. I'm not saying.
You don't even know, Jace. You don't even know how hard he screwed himself, but I'm going to let him do it.
Right,
go ahead.
Please. This will go a lot smoother. Just let me get a sense of. I'm not denying that things appear to descend due to perspective. What they don't do is descend below your eye level. So see the picture that guy put in the chat. What these lampposts will never do.
Yeah. Do you see the lampposts beyond the limit of his vision?
What they will never appear to do is.
No, you do not see them. So they're below what you think is your eye level. You think it's actually below your physical location, but it's actually just optically appearing that way.
It's always above. This is so intuitive that it actually hurts.
No, you're ignoring optics and how things perceive to your eyes, and claiming they're physically they're dropping below your eye level.
You're offending your own intelligence.
Yeah, listen, I understand what you're saying, brother, and what Drace has said is good. But here's the problem, friend.
It's offensive.
What you basically just said is that it is impossible for an object to not be projectively geometrically located in your field of view where its ideal geometry would have it located. Whether you realize it or not, what you just said
I'm obsessed with ideals.
Is that it's impossible for something that is below the curve of the Earth from your vantage point to ever be seen. Are you sure you want to accept that consequences?
I do.
Okay, great. So everyone heard him say that if something is below the curve of the Earth, it can never be seen. We all heard him say it. Now we all know. Hold on, my bro. We all know. We all know. Hey, dude, don't interrupt me to address things in the chat. Okay, super annoying. Type in the chat if you want to address the person in the chat. Now we all know. If he's claiming that you can never see something once it's gone behind the curve of the Earth, we could show him hundreds upon hundreds of images of things that should never be seen. And that would debunk his claim that the Earth is a globe. So he said he's willing to accept those consequences. Too bad, so sad. You sure you want to accept or you want to retract? The answer is you want to retract, and I'm going to do it for you as the judge because you're clearly incompetent to represent yourself. So, what must be going on if what we see doesn't match ideal geometry? Let me spell it out for you, friend. Ideal geometry doesn't exist.
Man, calm the fuck
Does that
down.
help? Thank you, sir. I'll take my Xanax. Okay. Now that we all have made it clear that ideal geometry doesn't exist, can we talk about reality? Okay, your rebuttal requires imposing artist perspective laws onto reality and ideal geometry onto reality. Since we know those two don't actually apply to reality, you have literally no point, sir. So take a minute, go to the back of the class, use a piece of scratch paper, come up with a better idea. If you need a para, I'll send one to the back of the room for you. Yeah, what's Fraunhofer versus Fresnel diffraction? What's near field versus far field? What's depth of field versus angle of focus? What's the Rayleigh criterion? What's the largest waveform of color? You know, actual real physics? What's total internal reflection versus specular or diffuse reflection? What's refraction versus Fermat's principle? Oh yeah, that's right. You don't know anything. I forgot.
When we go out and take long distance observations, we can see orders of magnitude further than you should be able to see on a globe. Okay, so if we go to say a 20-mile lake, for example, okay, there should be 293 foot of curvature over 20 miles. Okay, that's quite a lot. So we can go to a 20-mile lake and perform different types of observations and laser tests and things like that, right, to try to find that curvature, right? We're looking for things being hidden by the curvature of the Earth in the distance behind what would be the geometric horizon, okay? So the horizon should be at a certain distance, and then you should have obstruction of things beyond the horizon due to the curvature of the Earth. When we go out and take these observations, it doesn't match up. Now, I have to go in a second, so I can't present much, but I can post a few videos in the side chat that you can have a look at where, you know, people have done the long distance observations. They go over all of the mathematics, all of the details and everything. So
I don't know, but us just casually going out, and you can't have these types of observations just with the human eye. Also, we're with our height, we're too low to the ground to discover anything.
Yeah. So we're using high-powered optics for the observations, right? Or we're using high-powered lasers for the laser tests. Okay, and we can calculate how far away the horizon should be. Okay, if you're 6 foot tall, the horizon should be at 3 miles. Okay, so we can go and test for that horizon that would have to be there at 3 miles. Okay, and it's not there consistently or ever.
But where do you get the info from? That is 3 miles.
Okay, so these observations are logged, right? High definition videos, PDF files, right? These are logged, right? And anyone can go and reproduce these themselves. I've done a whole series of long distance observations myself, right? Just to clarify it for myself. But I'm gonna post some for you now, and you can watch the videos if you want, right? And come to your own conclusion.
what is the starting point and ending point of flat Earth? Like if it is flat, there should be a starting point and ending point.
Well, we're not claiming
on the land.
Yeah, we're
land
not
ends.
claiming. We're not. Okay, so you got to remember that flat's not a shape. Okay, we're not claiming to know the shape of the Earth. And what most people do is they try to replace the globe. Okay, they picture the globe model, and then they try to replace the globe with a flat planet. Okay, that's incorrect. Flat earthers are not claiming that the Earth is a flat disc-shaped planet floating around inside the globe Earth version of outer space.
Away. Sorry, before we continue and drift away from the subject, are you familiar?
Oh no, we're right on subject. I'm not drifting away at all.
The proof for the orbit existing.
Okay, prove that Jupiter can orbit the sun. Show me one full orbit.
Are you familiar with Kepler's law?
No. I want to see a full orbit. I don't want mathematics involved. You can calculate anything you want, but I want measurement.
Well, doesn't measurement is measurement not a part of mathematics?
Yes, but there's actual action involved and not hypothetical theory.
Who measured the gravity of the sun to be able to calculate the orbits?
Newton. He invented gravity.
He measured the sun? Wow, you guys are amazing.
Thank you.
Did you know gas balls don't form in vacuums or fireballs either? He is really amazing.
But look, if we can't directly measure the sun's gravity, but if you consider the planetary motion, which combines Kepler's and Newton's law, you can see that planets orbit the sun. And using Kepler's third law, T2,
Okay, I'll give you all the gravity. I'll give you all of your scientific theories. Let's go measure the surface of the Earth. How about that?
Well, I'm going to get him to go ahead, and he's going to admit here in a second that he's full of shit. Watch.
Well, what was your question?
Well, we already know he's full of shit, Professor Triangles, because he came in here saying that the Earth was flat because he drove from whatever country he said all the way to Russia, Germany to Russia, and that proves the Earth is flat.
I didn't do it, but that was hypothetically.
Oh, so you don't do these things we talk about.
You said that you came in here and said that you knew the Earth was flat, and now you're saying Kepler's motions prove that we're in a solar system.
We just want to confront you and with the facts and try to understand what you think.
Well,
who's we? Who's we? How many of you are there that I have to deal with right now?
Where to?
We're college students trying to gather information for a study.
Oh yeah, just go to the lake. You can see it's flat and level. You don't need to come in here to see it's flat and level.
But from what school teaches us.
In school, do you sit there and learn about the globe in school?
Yes.
Oh, sure. Go ahead and give me the number or the title of the book that you learned the globe in.
Oh, we don't use books.
You don't use books. You just use imagination.
That's why we're here. We don't think it's true.
Just go outside and look for yourself.
Tells us
we use our teacher.
Just go outside and look for yourself, and stop looking in the sky and believing in pretend laws of orbits that don't ever exist that nobody can prove.
Well,
Tony, if you're 185 centimeters tall and you're standing at the edge of the water on the beach and you look at the horizon, how far away is the horizon?
I don't know, like very far.
Well, give me a number.
Well,
it depends on the beach.
I'd have to calculate that.
Any beach, sea level.
Do you want us to measure?
You know what sea level is, right? You know what sea level is, right?
Of course.
Sea level means that it's 0 degrees in altitude and 0 degrees in depth because it's the same level as all of the oceans in the world. So how far away is the horizon if you're 185 centimeters tall, 1.85 meters?
Very far, I'd say.
Wow,
Give me
you
a
guys
number.
are
How many kilometers?
you guys are morons. I thought you came in here. You guys are all in a big group, and you just it's very big. Is your answer?
Give me a distance, Tony.
Okay, what was your question again? Just
how far away is the horizon?
I'd have to ask my teacher.
Okay.
He knows that. He knows everything.
Go ask your teacher.
Yeah, go ask your teacher and come back.
On your height above the ground. So you mean like if we're like on the sea level, you mean?
If you're standing at the edge of the water, okay, and you're looking out towards the horizon, approximately what distance do you think it would be if you were 6 foot tall looking out? Okay, and if you don't know the answer, say I don't know the answer.
Maybe about like
No, we don't know the answer.
Approximately.
The Giggle Brothers are here.
I know, flat Earth is stupid. I can't believe these guys think the Earth is flat. They don't know anything.
Oh, I thought he proved he was on flat Earth. He believed in flat Earth.
As we
all coming in here trying to defend the globe, but they know the least about the globe of anyone in the room.
We can see way too far for the Earth to be flat, so it has to be for the Earth to be round, so it has to be flat.
Well, go and argue with your teachers, and don't come in here and argue with us about it.
We just have to gather. We already gathered some information for our study.
Do you guys think the Earth is flat?
You don't come in here to gather information on your study.
For instance, if you fly.
No, I don't fly. I don't have wings. I don't have wings, and I don't know anybody in here that can fly either.
Bring your teacher in here. Bring your teacher in here.
Well, I'm not going to invite him to my home.
No, we want him. We want somebody that actually knows something.
To your home? Is that how you guys do things over the computer? You guys go to each other's house? You guys are weird.
That's called hanging out?
What hangs out? What do you guys have hanging out?
Or what are you trying to prove?
I'm trying to figure out what you guys have hanging out.
We are just trying to, for our school assignment, everyone in our school.
You don't have a school assignment about flat Earth.
I'm on the French lycée. How do you say lycée? The French High School of Berlin. You can look it up. It's you can see our program.
No one cares about dumb high schoolers, really. They're not smart. They just believe anything they're told.
No, we do not believe everything that we are told. That's why we are here. And we are working on a study for our school to prove our point.
Tony. So, in order for the Earth to be a ball, water has to curve around it, right?
Yes.
If the water is not curving, that means the Earth is flat, right?
Yes.
If the Earth is flat, then the distance, what the sun, moon, stars, and planets are completely different than what they told you it was. Their distances are different. Their movements are different. Everything is different. It's no longer the story they told you.
Then update us.
So to come in here and tell me about Kepler's laws and say that orbits happen the way that they happen because of heliocentrism, you first need to prove that the Earth is a sphere in order to even begin to hypotheticalize what's going on in the sky.
That's what we are getting taught in school, and we do not think that this is right.
Argue with your teacher then.
Yes, we are trying to argue. Look, that's why we're here. We need a study as an example or as like a proof.
Water is flat and level. Water is flat and level when at rest.
What are your arguments? For instance, what are your arguments that we can write down right now for
water is flat and level when it rests.
Water is flat, you say?
And level when at rest.
Yeah, write this all down because you guys use pencil and paper in class now.
We don't use paper and pencil in our class.
Great. So water is flat and level.
But
that's it.
No. Also, we were just interrupted by somebody. I'm very sorry. What we are getting teach in school is that water always settles perpendicular.
Yeah, perpendicular is a flat Earth thing. There's no perpendicular on a globe.
Yo, why are you trying to rage bait us?
There's no perpendicular on a globe. I'm giggling like you guys.
Just right. You came in here. You thought this was going to be a funny joke.
Now he's raging out. He came in here to troll us and found out he's starting to rage out. That's fun.
Anyway, looks like we got Thomas in here. There was a girl in here earlier too. We missed the opportunity to talk to her. So, yeah, Tony, if you're really just watching and wanting to learn, then just hang out, man. Eventually, a conversation will happen, and you'll get to see the full argument in play. You'll understand that there is no argument anymore because the data and measurements point to a flat Earth.
But what is this flat Earth Discord like all about? Like, as a genuine question.
Educating people on the tools that they need to use in order to go out and determine that the Earth is flat on their own. Because I can't make you believe what I believe, right? I have to give you the tools and let you go figure it out for yourself. I can't make you walk through the door, Neo. You have to do it. I can only show you the door.
And I actually know the Earth is flat, and then you will also know the Earth is flat, and you won't even have to believe in it.
Wait, just my last argument. If we look at the Earth's shadow during a lunar eclipse.
No.
It's not the Earth's shadow. You got to prove the Earth is a ball first.
Earth.
We can move on now. We can move on. You haven't proved you live on a ball yet.
And only a sphere, like a round object.
Space is fake.
From every single angle. What do you think about this?
I think space is fake and you're lying to me.
Do you believe in the...
Define space, please.
You define it.
Do you believe in the moon landing?
Wow, you guys are all over the place. This is how you study flat Earth. You ask about moon landings?
Space is the vast region.
They thought they were going to work as a group and come in here and be able to just make us look bad, and they found out they're sitting there in silence. They don't even know what to do anymore.
Yeah, the moon landing never happened. The original crew that was supposed to go to the moon ended up being killed during a training exercise and was replaced with people who were willing to cooperate for the sake of advancing the American ideology.
What other globe proof do you have? That's that. Who's next?
Yep. What's up, Thomas?
What?
We said that's that. You guys are done. You and your class, you and your friends that are studying to be flat earthers. You guys are done.
Why are you raging out like this all of a sudden?
No one's raging out at all.
Hold on.
We're just showing you pie in your face. You got the pie in your face.
Yeah, we're just moving on to the next guy.
What's up, Thomas?
Thomas with the always hot microphone.
I don't have much time. Like I can more or less be in here as help or whatever, but y'all want me to start an event? What should I title the event? Globe Earth, a study review.
Yeah, just put in whatever. Let's get more people in.
Oh, we lost our trolls. They just left.
Both of them. There we go.
So just since there's no one in here at the moment, just back to that list quickly. I came in when you guys were like already well into the conversation, but you're up to the number 46, the time zones question. Now, a lot of the things in the list have just been completely taken out of context by some flat earthers. They're thinking that, oh, this is like a list of things you're not allowed to talk about, or things that people shouldn't be talking about, or arguments that shouldn't be made. That's not true. That's like not the point of the list. And some of the things on the list are great arguments, but some of them are used really poorly. And like the time zone one, for example, that you guys were talking about, right? Like if a flat earther were to say, which we hear sometimes, unfortunately, is that if the earth was a globe, there would be equal time zones in the south and in the north. And because there's not, therefore it debunks the globe. Like, I don't think anyone would disagree that that's a poor argument if a flat earther made that argument. And that's all that one's referring to.
I'm going to give you a little bit of context, DJ, for Miguel. Miguel said that when I was giving the argument about the time zones, not that I made that statement or a bad statement or whatever, but that phrasing, that sentence, that number 46 appeared on the list as I was making that argument. And I said, well, I wouldn't make that bad of an argument, but it sounds like maybe Yoder was trying to get ahead of a bad argument. And he just wanted to put that out there because there are people that would make that bad argument. And that's all I was trying to say. Like, it had nothing to do with me. I don't care if Yoder puts one of my arguments on the list. I don't think I make bad arguments.
I don't think that's an argument that you made, but maybe that sparked an idea. And I was like, when you mentioned that, he's like, oh yeah, that's another one we meant to add to the list, right? Some flat earthers saying that it debunks the globe because the time zones aren't even, whereas time zones are obviously like politically designated and all that kind of thing. It doesn't really, it's not really an argument that would prove anything.
I agree with that. And Sheepdog was talking to the Glober. I was here. Yeah. So Sheepdog was talking to the Glober and answering his questions. The guy did bring time zones. And Sheepdog did talk about it, and he did say, at China there's only one time zone, so it's political, and that's it. So
yeah, that's the way to, that's a good thing to point out, because that's the Glober's argument quite often, is explain time zones. Most of the time in the English Hub server, when they say time zones, they're just talking about daytime and nighttime. That's what I've noticed in this one. But in more English-speaking servers, when they say time zones, they'll be talking about maybe it's very rare that they're talking about politically designated time zones, I think.
Yeah, but it's a man-made concept, all right? Construction. Yeah.
Gotcha.
Another thing, of course, there's some good. There's some points that it's ridiculous, so there's some people, some flat earthers, maybe at TikToks and Facebook, claiming that the rainbow proves, a firmament or whatever. So that's ridiculous, of course. But it's
exactly, man. Look, each of the things on the list should probably have a paragraph of explanation below it, so people don't get confused about what Yoda was meaning with each one. Because if we explain what was meant by each one, it makes sense.
Yesterday I was at Facebook and I saw some Glober claiming that flat earthers say rainbow proves
Bro, they do. Some flat earthers, they love. So there's some flat earthers out there that, like, on TikTok and places like that, it's like they love that argument. Yep.
So I did the answer to that Glober, and it said, "That's ridiculous, man. It's that guy is not a flat earther. I can show you a rainbow from above, like a circle. There's some videos. You can see from above. You see a rainbow. If the rainbow depends off the point of view. But if you, I think I have it. So there's a video. The guy is going up. You can see a circle. So it depends of location.
I think the biggest takeaway from that is like, as a flat earther, you shouldn't be like, the Globers are going to strawman us. we should not be straw manning them. We should be steel manning them and disassembling and dismembering that steel man.
Exactly. Because for example, that guy, that Glover, at Facebook claiming that that's how you say that's a belief from flat earthers claiming that the rainbow proves the firmament, or so it's ridiculous. The guy is just did listen, or just one guy, and the guy is making a false stereotype, generation about flat earthers, So, so it's ridiculous.
Exactly, man. And that's a perfectly good one to put on the list. It's probably on there already.
Let me see. I think I have.
Abi, welcome to the channel. I see Abi's typing something in the side chat. What's up, Abi?
For sure, man. And just for another clarity too, like I get a lot of people when I've had arguments against, arguing back and forth over the globe or flat Earth, when they say when we say the radius, and they say, "Oh, that's a straw man," that is literally the steel man right there. So for anybody out there listening, if you ever get somebody saying, "Oh, you're just trying to straw man the globe," no. The globe is a specific size. It's a closed loop. So don't let them squirm away from that. That's not a straw man.
So I did found that one full circle rainbow. Let's see.
Yeah, I've seen them, man. Yeah, there's one. Yep.
Yeah, those are cool.
Cool.
I would like to see one of those one day. Y'all want to know something weird? The color fuchsia and magenta, those two colors, are not real colors. They're fabricated colors. That was something interesting because, like, if you look at all the colors in the spectrum, all natural colors come from the rainbow, right? But where does purple and pink intermix? Or purple and red? Not to get too deep in the weeds on that one, but just food for thought. That was a cool.
Can't you make any if you have the primary colors? If you have the primary colors, can't you can make any color, like by making.
It makes you wonder.
A different color and then mixing it with another color that you made, right? It's just combining them. And I don't know. I need to ask my wife. She's an artist.
Okay, yeah, no, do that, man. Because yes, I agree. You can mix and match any color, but to say it's a natural color, like natural colors come from the rainbow, right? Or at least that's the argument that I heard. I'm like, that kind of makes sense. When you look at the hue and the saturation panel, when you're doing art design, like on a computer or something like that, like you see it in the format of a rainbow. And so you move your slider, your little square or circle over the rainbow. But where does purple and red intersect? They're on opposite ends of the spectrum.
And that concludes our lesson on colors for the day from the Flat Earth channel.
Yeah, so if you're a glober, don't go eat your crayons.
We got Silver back in the chat. I think we've spoken to Silver a bunch. What's up, Silver?
I think I've met Silver at least once or twice.
Yeah, what's up, everybody?
What's going on, man? Welcome back. Where did we leave off last time?
I actually don't remember, but all is good, man.
Cool. Let us know if you have any questions. You're a globe earther, aren't you?
Come again?
Do you think the Earth's a globe? I forget our conversations.
No, I don't. No, I don't think so.
Oh, okay. All right. Well, that's no fun.
That's not okay. That's not fun. I think most of us here flat earthers, right?
Yeah, everyone in here. Yep.
Well, not Professor Triangles. He's in denial.
Okay. The flat discounts.
Yeah, I'm waiting for the globe proof because I'm a glober waiting to go back. You guys can't prove that the Earth is a globe either, so I'm stuck.
Glober in crisis.
For all we know, the Earth is a triangle.
Hey now. So I have to go to a Christmas party tonight, and I don't drink. I mean, not that I've never drank or anything, but I just don't do that normally. So I was thinking about drinking some wine tonight and breaking the news to everybody. Or presenting, have you heard the good news, everybody? I haven't figured out which one yet. It depends on if they piss me. If they piss me off, they're getting a flat earth speech tonight because it's a family thing.
Oh,
Hey,
man.
just don't get
I wish I could be a
Coriolis.
fly on the wall at that.
Right, you may have to come in live stream and or just in one of the rooms and just leave your mic open. See what happens. Saying DJ, make sure Professor Triangles doesn't get Coriolis because he may prove the spin of the Earth.
Uh-oh. Well, you can prove it in a way. If you look at your ceiling fan, how it spins, Earth is a globe.
Oh yeah, it's just relative at that point. The fan's not spinning, the Earth is spinning.
Well, that's how relativity works. If you're a little microbe on that fan, don't you wonder how come when I wake up some days the whole room is spinning?
Mohammed, did you find any evidence of globe Earth yet?
That seems to be the trend. It's just crickets for globe proof. Hey, do you have any globe proof? Crickets.
Maybe Yina has some globe proof. Welcome, Yina. Do you have any globe proof? Proof that the Earth is actually a globe. That's what we're looking for.
No. Oh well, I mean, go ahead.
No, Yina said no.
I was gonna say that's kind of what the topic of the room is right now. It's the globe in review. We're reviewing the globe. I could see Professor Triangles at his party handing out a piece of paper to everybody in the room being this is a one question test. If you get it right, then we can have a conversation.
And everybody is from the military, like around my age there. This will be fun. It's going to be a fun night.
You know, it's funny. The snipers that I know that teach shooting, right? They're like, oh no, we account for the Coriolis. No, you don't. You just say that so that way you sound smart to the person they keep giving you money. And they look at me like all sad, like I can't believe you said that. Yeah, bro, it's the same thing with everything else. Like you just keep something in your back pocket that nobody knows about. You hope nobody figures it out so you can keep selling it.
In case anybody missed it, Miguel posted how rainbows are made. There's a rainbow making truck going down a highway. And if you walk through that mist, the rainbow will attach itself to you and you won't know what you are either.
Hey, Triangles. So did you hear I started calling Werner von Braun the greatest flat earther of all time?
Oh, okay. Well, that makes sense.
He created NASA.
Rockets only work in air pressure, so they don't have air pressure on a globe.
He created NASA in a pressurized system. Should I start the event? I mean, some people are trickling in, but I know if I start the event, people will pop in like rabbits. Looking like little bunny foo-foo, bopping them on the head.
Go ahead, sucker them in here. Get them to start spiraling so I can knock them out with my little gold hammer.
Hey, do you want to put your triangle test up there so that way you can question them?
Not yet. Not yet. I like to surprise people. I don't want them getting anything in advance.
Yeah, I don't. We're not allowed to start an event right now because there's a stage event.
Oh, I didn't see the stage event.
Yeah.
I'll
keep an eye on it as soon as it's finished, though.
Okay. Yeah, that was my bad. I didn't see a staged event coming up. I didn't see a staged event at that moment. It must have just popped up. Like I see the supporters and the peace thing going on up there, but there's a Let's see. But yeah, just to kind of finalize and cap off about the whole argument about the time zones and everything like that from my perspective and what we were talking about earlier, Miguel. I don't even take offense to what Yoder did. I think the statement that Yoder made for that number is perfectly valid for, just helping people remember not to make a poor argument on a good argument, right? Like, what is the real argument? Like DJ was saying, like, context matters. And to just say, oh, the Earth can't be a globe because of time zone, like, that's just a poor argument. So that's all. I think he's trying to show us what the straw mans look like. So that way we stay away from those. We don't make poor arguments. We don't look foolish. Because at the end of the day, it's laziness.
Yeah, or just not being, not learning the argument correctly the first time. Because, you heard it on some TikTok video. Like just someone that's new to Flat Earth, they might watch a bunch of like TikTok videos or Instagram videos or go on Facebook and they'll see some memes or something like that. And then they'll go take that argument that they saw in the meme and use it somewhere else and make us look like fools. The memes, like when I scroll through occasionally I'll just jump on Facebook and just scroll down like my recommended posts or whatever. And for some reason, there's all of these like Flat Earth Facebook groups that are posting shit in my feed. And every single meme's like a freaking 2015 style meme that's just absolute junk. I'm like, and then the Globers are just tearing it to shreds. It's almost like it's like being done on purpose. Like the new style of Flat Earth Society, just like spam all the dumbest memes possible and act like Flat Earth is a claiming this is what Flat Earthers claim. I hope it's that. Anyway, I hope it's not actual Flat Earthers sharing all these dumb arguments.
Yeah, honestly, I think it's psyops, DJ. I think it's anti-Flat Earthers making stupid memes. Like, I've seen anti-Flat Earthers spread arguments for Flat Earth and then laugh because it's Flat Earthers are using that poor argument.
Yeah, but today I was at Facebook, and there was this Glober claiming Flat Earthers claiming a cylindric Earth shape. I mean, that's so ridiculous, man. The guy is doing propaganda.
Yeah. Jackie, welcome.
Hi.
Hello. Be dat.
Yeah, hello.
Hey man, welcome to the channel.
Yeah. Thank you.
What brings you into the Flat Earth channel?
I know, just I come across it.
Cool. Have you been in here before?
No,
Have you looked into the topic?
I'm just a newcomer here.
Mm-hmm.
And
Have you looked? Yep, go ahead.
where are you from?
Australia.
And I'm from Vietnam. Yeah, nice to meet you.
From where, sorry?
Vietnam.
Vietnam. Cool, cool. Awesome. Nice country.
Yeah. So this chat is what subject about? Like what topic?
What topic?
Yeah, what topic?
Oh, you left. Or did you not leave?
Oh yeah.
Oh, there you are. Topic is that the globe, globe Earth, globes.
Yeah.
The topic is that the globe that we live on, when we measure it, is actually flat. It's a flat globe, apparently. What do you think about that?
No, I think he left.
That's like everyone at Professor Triangle's party later.
We'll see what they have there. If they have tequila, it's probably over for them. My wife will probably be making me leave early.
Beijing, are you on here?
Sorry about that, DJ. I tried to mark interested and it started the event, so I restarted or re-put it up.
Yeah, it's all good. They don't have really anyone in their stage event anyway. It's like 3 people in there. So. Oh well.
There's someone in the side chat claiming Earth is a globe. Unmute me. They left. That guy is someone is here in the voice chat. Sheepdog, you did change from sheepdog to swole dog. I was searching swole dog, but it gives me shot dodge. Refers to a popular edit of dodge, which imagines the character having an extremely muscular human body. Is that correct? It's not a real race dog, right? It's just some character. You know, when I saw your first, when I saw your name, profile name, Sheepdog, I was thinking that it was some kind of joke name, but actually it's a race of dogs, right? Sheepdog. And I did search it, and there's even a Portuguese sheepdog.
6, 7.
What's up?
Who's that? Would hey at the bottom?
Yeah.
What's up?
Good.
good is good, globe is a sphere, and flat is flat.
What?
What do you think
Your
about
voice is not there.
what do you think about Earth? You think it's a ball?
Yeah, Earth is a round ball where all living creatures live.
Okay, can you prove that?
What? What to prove?
Yeah, prove that ball Earth.
Prove Earth is round.
Round, you can have a round table. You can go around a house.
Earth is round. We can't feel round because it is very long. So that's why.
It's long, like it's so long that it's flat.
It is very large, no?
Very large, big, so big. So you cannot see, you cannot prove your ball, Earth.
You can not prove your ball.
Yeah, you claim it. The Earth is a ball, but you cannot prove it.
How? If you can say it by gravity. Say it like it is round because gravity is pushing us down.
Oh my god! So you change from specific shapes, and now you jump to some theory, trying to prove shapes, geometric shape. How do you if you claim it's a ball, you have to have a circumference or a radius. You cannot say it's too long, too big. Or you can say Narnia. Oh, because Narnia. I mean, that's running away from. We were talking anyway. You are talking because of Narnia. There's a Narnia force that is making a ball.
No, it's because gravity. Gravity makes balls.
Yeah, I say that.
You say gravity makes balls?
No, I say gravity is in the core of the Earth.
Oh, yeah, no, you're wrong.
No,
Yeah, see how easy that was?
Was it always in the core of the Earth?
Yeah.
Yeah. Always there?
How big is it? Because the core can go all the way down to like a pinhead, isn't it? Like that's the tiny dot. That's like how the universe started from the head of a pin, and then that blew up and everything formed from the head of a pin. Like the hair on top of your head and all that came from that explosion. Isn't that weird?
Sounds very outlandish.
You wouldn't understand because you don't have a high IQ like the rest of us.
Yeah, you have very high IQ. I can't understand you.
You consider like 80 to be a good high IQ with all your friends?
Let's not get racist just because
Can you
he's an
explain why
Indian
Earth is round?
guy. He has a low IQ.
Racist?
He was talking to me, by the way, just then.
Why?
Yeah, why
Can
would
you
that be
explain why
racist?
Earth is round?
Round?
Yeah.
It's not round.
Why is
You
it
need
like
to
a
explain
ball?
why you think it's round, dude. Because listen, that's weird that you said that because really you said, can we explain why it's round? If you're seeing a round Earth, you might have mental disabilities right now.
Why Earth is round? Like a ball?
Holy crap.
hey, Udhay. Why does the Earth spin? Why does the globe spin? How's that work?
It's a perpetual motion machine.
How did it start spinning in the first place?
Bro, I am 15. I don't know.
It's okay.
You can explain me why it is like a ball.
It's not a ball.
What is it then?
It's a flat plane.
You are genius.
But how is it spinning then? Wait, that's something. Wait, sorry.
It's not spinning.
Yeah, exactly. But why are the other planets?
They're not
Wait,
either.
that just only means that Earth is not the only flat planet. That means the sun is flat.
No,
the moon
none
is
of the
flat.
other ones are. None of the other ones are spinning. So that doesn't mean they're flat because they're not spinning either. What's wrong with you?
I'm just asking you a question.
Flat Earth is not a planet. We don't think hold on. We don't think the Earth is a planet, like another planet. Like when you said another planet, like you were thinking that Earth's a planet. It's not.
What it is then?
Yeah, what is it then? If it's not a planet.
The Earth is the Earth. Yeah, so the Earth is what we live on, which measures as a flat plane. You could probably think of it like the floor or the foundation of the system that we live in.
It's not flat, that we all know, because we got mountains and all that. So if the Earth would be flat.
Oh man, that's good. You win. You win, dude. You're a winner. You won the debate. Yeah, you won the debate.
No, I'm just saying it's like it's not.
We agree with you.
Flat. It's a textured.
Bro is really.
You didn't think that we thought that there's no mountains, really?
Well, we can see because the moon doesn't have mountains. The moon only has holes.
Doesn't it? It only has holes. Well, the moon has nothing to do. Like the moon is not the Earth. It's not a similar thing as.
I'm just saying. I'm just saying because the Earth can't be totally flat because the moon has craters.
Right. So it would be called a topographical plane because there's topography, but most of the surface of the Earth is covered in water. Oceans, seas, yeah. So yeah, and the surface of the water is not curving over distance, and we tested that over and over and over again using all kinds of different methods, and there's no curvature. So it would be considered a topographical plane. We're not claiming to know the shape of the Earth. Flat's not a shape. The description of a surface, like you said. Okay, so yeah. If it were a globe, water would have to be curving and sticking to the outside of the globe, right? Curved oceans, curved water, curved lakes.
Well, I get your point, but at the same time, the math is not mathing.
The math that we're given, that the Earth is a globe, is not mathing. That is correct. When we go and test the math,
because it doesn't make sense that every other, let's say, world in our solar system are circular, but ours is the only one who isn't. Make that make sense?
No. Well, because you're trying to insert the flat Earth inside the globe Earth model of outer space. Okay, so you've been taught your whole life that there's a big giant vacuum, which is outer space, and then you've got all of these big round balls floating around in the vacuum, and that you're on one of them.
Well, I haven't been
and then
told
when you hear, let me finish. Let me. Well, that's what they say. They say it's a 10 to the negative 17 torr vacuum. And then when you hear about flat Earth, you try to change the globe that you've been taught that you live on into a flat planet. And that's not what we're claiming. This is a completely different system, a different way of looking at the place where we live. Not trying to insert the flat Earth inside the globe model. It's not compatible.
Okay.
You are saying Earth is flat.
Yes, just like we all experience every day when we go out onto the Earth. If you go to a large body of water, you're going to have a flat surface over the water, roughly, right? Roughly, approximately flat. Obviously, there could be waves or ripples. But over distance, it doesn't curve. And we would say that to have a large body of water, you must have a container. It's absolute common sense, and it checks out with reality. So a lake, right, or a sea or an ocean, that would be the low spot in the land where the water gathers, and then the surface of the water is flat. Definitely not a crazy claim to be making.
Yeah, we don't look up in the sky and deny that Jupiter is up there. If we just can't prove that it's like Earth, where you can land on it and walk around, and or Mars or Venus. Like we see them up there, they look like lights in the sky. We just don't have this like awkward little story about how we can go there one day and colonize it. When I look up in the sky, I don't feel the Earth moving. I see the sun move, right? I see the moon move. Everything moves above the Earth, and the Earth just seems to be the center of all of that.
Well, I can kind of understand why the Earth would be flat, but at the same time, I'm finding it so hard to believe because naturally and technology and like everything just goes against the Earth being flat.
No, that's not true. Everything the Earth is flat. Everything says the Earth is flat and stationary. Everything. Nothing says the Earth is a ball flying through a vacuum. Nothing at all.
Okay, first of all, no need to get heisty.
It's hard to believe because you were taught at a very young age that the Earth was a globe, and nobody ever gave you any evidence, and you just believed it.
No, I was actually taught that the Earth had many different shapes. It could be oval, it could be many things, but they don't know the size of it. And I also got taught that the universe is just like the sky; it doesn't have a floor or a roof, and it's cold. Nobody told me that it doesn't have any oxygen in it.
They said they do know the size. And as far as oxygen, we can test for oxygen. There's ways to do that.
Well, why would they need helmets in space movies if there was oxygen up there?
Bro, didn't you hear me? We were talking about what I got taught when I was little. Nobody told me when I was little. We are talking like, I'm like a grown up, I was going to say. I'm 18. Yeah, we're talking about 9 years ago.
So you still think that there's oxygen up there? Okay.
No, but I think it's like...
Yeah, so no oxygen means vacuum. So now you're stuck on
but you're not getting sucked.
A spinning ball.
Well, you're kind of not getting sucked in like the vacuum does.
No, that's different. That you don't understand. Vacuum is low pressure.
I would say that's a pressure chamber, not vacuum. But again, space doesn't have... Can we just have some better things to do than discussing if the Earth is flat or not? Like, is there an end of the universe?
No, the universe is flat too, according to NASA. So now you got flat universes and flat Earth.
What would be better than talking about flat Earth? Should we just talk about celebrities?
Flat universes?
No. I meant like the surroundings of the thousand stars, the night sky, the atmosphere. If that one is flat.
Yeah.
Because if it's flat, where's the bottom? Where's the core? Where's the end?
How do you have a flat table? Is there a core in your kitchen table?
A what?
A core. It's your table's flat. Where's the core?
Yeah.
Where's the core?
Let me ask this. How do you explain
There's got to be a middle part, probably, I would think, if you could figure it out, but I don't know.
How do you explain the universe being flat?
Yeah, that's what my question is. If the universe is flat, how the fuck do you explain that? Because no one hit the bottom.
It's a
If
silly
the Earth
story.
is flat, then we're walking on the bottom of the
Your
Earth.
guys' story. Yeah, that's your guys' story that you made up about the universe that it's flat. We didn't make that up.
We are the ones believing that the Earth is flat and everything around.
No. We tested the Earth, so we know that the surface of the Earth is not curving. But NASA and Harvard University and Cambridge University and all of these so-called prestigious universities and agencies, right? They claim that the universe is flat, like a pancake.
Did any one of these guys go to space?
You can't go to space.
From the flat Earth believers, did any one of them go to space?
Break the news to him. Break the news to him.
Yeah, so space, as you've been told, is not as you've been told. And NASA faked, I'm sorry to break this to you, but NASA faked the moon landing.
Oh God, Jesus. We're doing this.
Hey, wake up, throw water on your face. Go over to the sink quick. Splash water on your face.
Why? I got snow around me.
Yeah,
Why?
go run around in the snow so you wake up, so you don't faint because of the good news we're giving you. Have you heard the good news?
No, it's not. It's not. I mean, it's not good news. It's just
yes, it's very good news. You don't have to worry about asteroids hitting your house anymore.
Fuck. I'd like to know. Well,
Hey, Rudolph, how tall are you?
Not too tall, so I would technically go underneath as an alien. I was going to say.
I'm just give me a number. How tall are you?
158.
158 centimeters. So from 158 centimeters, if you go out to the beach and you look out over the water at the horizon, how far away do you think the horizon is?
Well, I don't know. Just a few 100 meters. Maybe less. Ouch.
100 meters, huh?
A few. That means a couple more than just 100.
What? So 300 meters, like a football pitch?
Probs. I don't know. I don't really think about that when I see the beach. I just know that it doesn't curve. Oh my God. Y'all bitches are actually smart. It doesn't actually curve down. It goes straight.
You all right?
Yeah, I'm actually because the last time I joined in, I got told that I'm the height of an alien. I'm not going to believe that I am an alien. But it actually makes sense why the Earth is flat now.
Why would you be told you're the height of an alien? Aliens don't exist. What's wrong with you? Or unless you're talking about the Mexicans that do our landscaping. But
Yeah,
most of those guys are not aliens. Most of those guys actually just live around here.
Yeah, no, don't ask me. I just joined
I was chasing them around with pitchforks the one day. I was trying to chase them out of the country the one day, and they said, wait, no, we live here. And I said, oh, okay. And then I went back home.
You know, there was some flat earthers that were just like alien freaks that said, yeah, and you know
There's
what?
no such thing as aliens with flat earthers. That's the craziest thing.
Oh, there is a thing. Haven't you?
Oh, no, there's not.
Well, no, he was ginger, had a red beard, and had like crazy ass setup in the background, and he was like total freak of the universe.
Yeah, that guy, yeah, he is a crazy freak. Yeah, he's not a flat earther.
Well, I did not believe him on that one, but
I don't believe him either.
I'm kind of believing it now. If NASA faked the landing on the moon, that must mean that no one has reached the moon.
Ta-da!
So has the AI been in the game longer than we've known?
AI? Where did you get that from? How did AI
because
come into play?
How the fuck did they get pictures from, let's say, Earth and the moon
They didn't.
if they never made it to the moon.
They didn't. They didn't get pictures. Those are paintings. And they put them on TV, and then you guys all said, "Wow, look at that! It looks so real. How can it not be fake?"
But the things on the internet then must be AI, because you can't put paintings on the internet that looks like that unless it's modified.
No, if you go to NASA's website, they tell you straight up all of their images are just Photoshop or whatever, composites. So none of them are actual photos. So they don't use anything real either. And that's not AI. That's a guy just sitting there at a computer drawing circles.
Yeah, look, have a look in the side. Can you see the side chat, Rudolph?
No, actually, right now I can't.
Yeah. Well, open it up. Have a look.
I'll have time for it in a moment. Ah.
Can you see it?
Yeah, I'm just finishing feeding the last horse. Stop bitching. Let's see. What message am I supposed to see?
Well, you could see what Stark posted. Okay, so that's the famous blue marble.
Yeah.
From NASA, and it was admitted by NASA to be made in Photoshop. And you can tell when you zoom in on it, you'll see clouds copy pasted, like repeating clouds. But NASA admits that they actually make it in Photoshop. And then underneath that, you'll see what Miguel Sousa posted.
Yeah.
Okay, there's a guy
what the fuck?
Yeah, he's painting a planet. I mean, I was asking my wife about this because she's got a master's degree in art, and she said, "Yeah, that's super easy to." No, that's Jupiter. That's meant to be Jupiter. But
they could.
And then have a look at this. I'm going to show you this. Right, this is actual NASA footage, claiming that this is from the moon landing. So this is the lunar module or whatever orbiting the moon. Now check this out. Tell me if you think this looks realistic, or you think it looks like maybe like a little miniature model in a studio or something similar. Because when I look at this, it doesn't look realistic to me. It looks completely fake. Maybe this was able to trick some people.
That looks like something out of Roblox.
Exactly. This is actual, if you go on NASA's official YouTube channel or the Smithsonian Air Space Museum YouTube channel, you'll find all of these videos. And they claimed to be real.
Down. Yeah, calm the fuck down now. It's not my fault that you did that.
Yeah, one more.
هتلاقي نفسك انا ممكن اتكلم عادي يعني بص.
You have to speak English, my friend.
No.
Right, one more.
What are you doing?
Here's another one. Rudolph.
Oh fuck, yeah.
Yep. Can you see this next one? This is meant to be the astronauts leaving the moon. All of them. All of the astronauts are in there.
Yeah.
Wearing nappies. Yep. Taking off from the moon.
Is that from 2025 or is that from 1980s?
That's from Apollo 11.
Isn't he dead?
Wow. We need to be able to clip that one. That should go viral. We have bots in here? Yes, we do. All right.
So yeah, and then, it looks like stop motion. Like Miguel Sousa just posted a bit. It says stop motion is a filmmaking technique where physical objects are manipulated in tiny increments between individually photographed frames, creating the illusion of movement when played in sequence. Yeah, maybe it's something like that. But it just, at the end of the day, it just looks completely ridiculously fake.
Come on.
And then, are you listening still?
Oh.
Or are you fighting with horses or something?
Well, at the moment I got one in, but it's okay. I'll peek in the chat.
All right.
Continue.
Okay, so when they interviewed NASA a few years ago, and they interviewed one of the astronauts at NASA, and they said, how come NASA doesn't go back to the moon? He said that, we destroyed the technology to go back to the moon, and that it would be a painful process to build it back. He was saying how he'd love to go back to the moon, but they can't because they destroyed the technology.
Okay, so all the satellite information that NASA and Elon Musk and all those billionaires have claimed that they have made is also fake. Because if they never went to the moon, they also never made it past the ozone layer. Because
also, Bill Nye, the science guy, says that we can never leave lower Earth orbit. We live in an enclosed system. There's nowhere else to go. And even Elon Musk, when he put his Starman in the Tesla in space, he's like, you could tell it's real because it looks so fake. And he even tweeted out when one of his spaceships that went into space and it's floating in space. They're like a new view for Dragon or whatever, and he retweets it saying, "The closest to in space you'll get under a dome."
Uh-huh.
I'll put that in the side chat for you. I got a screenshot.
Yeah, do that.
So here is the Starman in studio.
Yep.
And then here is Elon Musk. Give me a second. There we go. Here's the Elon Musk tweet for SpaceX.
Huh. What I don't understand is why bullshit the rest of the world and lie. Typical men thing, huh?
Well, money, control, power, world supreme, to make the rest of the world think that they're the best and can do what no other country can do.
Is that why they made nuclear bombs? Because they found out they couldn't buy the moon.
No, nobody made those either.
So the Earth is flat now.
Yeah, so this is what it comes down to. Like, we're told that the Earth is a certain size and that most of the surface is covered in water. So that means if we go to the beach, for example, or a giant lake, and say it's 10 miles across the lake, we can calculate how much curvature there should be over that distance. Okay, so over a 10-mile lake, which is 16 kilometers, okay, there should be 66 feet of curvature, which is 22 meters. That's like a 6-story building. That's a huge amount. So we can easily go and test for that. That's easy
But
to find.
have they hit like the inner core magma? As they say in the middle?
The deepest hole anyone's ever dug was dug by the Soviets, and that was just 7.6 miles deep. They couldn't dig any deeper than that. They kept breaking their equipment. That's the deepest anyone's ever dug down.
Maybe.
Well,
I'm starting to believe that
the official record. If you check,
I'm starting to believe that space is also bullshit, and that the Milky Way is also bullshit. That it's just the Earth.
Well, yeah, like when you see all of these pictures,
there's no one hitting the bottom.
Yeah, we don't know how deep the Earth is. We're not even claiming to know the shape of the Earth. We're just, when we test the shape of the globe, that, in reality, it's not there. Like the water is not curving over distance.
How do you know when you're at the bottom?
When you can't go any longer. I was gonna say.
So that's 7.6 miles right now. They can't go any farther.
Yeah, no, but we know that we can go further.
No, how do you know that you can't go any farther? How do you know you can and you can't?
Because one day, like in Minecraft, no, JK. I don't know. You just gotta, if it can produce soil and all that, it gotta means that there's still life. So
Look, I work in the oil field. I'm telling you right now, oil is not what you think it is.
no, that I know. It's all like dead animals.
It's made from a stone called shale, Shale. And what happens is all of the carbon, methane, smog that gets up in the sky, when it rains, it all falls back down on the earth, and it's heavier than things, and it seeps back down into the ground, and then it restores in those reservoirs, reforming shellstone again, and then eventually dissolving back into liquid oil. It's a constant revolving cycle. The reason why the Saudi Arabians are so wealthy is because a long time ago, America decided to make Saudi Arabia dig up all their oil. Well, after they dug up most of their oil that they thought they had, when they went back to the old oil wells, they found out that the oil had returned. It's cyclical. We are in a truly homeostasis environment that's dynamic and constantly in motion, and it's beautiful and perpetual, and it's full of life, and that's just the way it is. Like, all life is here on Earth. There is no life up in the sky. It's okay. Sorry, I didn't mean to kill the room. Was that a good one-liner? That's what we do.
Words.
Does anyone have the video for the frozen lake test with the multiple colored lights? I just put a meme in the side chat. I would like to watch the video if anyone has it.
I think I have it. Just a second.
Thanks, man.
Okay, let's see. Let's see if there's this. Is this one? Is that one, right?
Oh, yep, that's the one. Awesome, thanks.
It says part 1. Maybe there's part 2. Let me see this one. It's just some links. I have it. Save it. Anyway, yeah, I have to see if there's part 2 of that one. I'm gonna do the YouTube channel.
Awesome, thanks.
Okay, so let's see. That's from Rock Lake. Okay, there's a part 2. Let's see, I'm gonna copy the link. But there's more videos there you can watch.
Awesome. Thank you very much.
No problem. Anytime. I think I have to save maybe the videos because, you know, who knows if the channel, they just shut down the channel. You have a joker there. Somebody left. Thank you. In the part 2, I was watching the part 2. At 3 minutes, is doing like a simulation. What it should start. You know, there's on the table. It has a. It puts some pencils. I think Sphere Graphics. But it is. It put its camera. You have to watch it. So it's amazing. What did
Yeah, I was just looking at the middle one that you posted, the Chad Preston official Utah Lake laser test.
Yeah, all these links I have in the same folder.
Yeah, I sent you an invite to my server. It's pretty big now. It's a big library, and
you have a lot of files there already, or you are?
Yeah. Click into it, have a look. It's a pretty big server now. In terms of how many, it's like a library. It's like all categorized, tons of different information. I know you've got a ton of stuff, so it would be cool to.
Okay.
There's an observations section, and I'm adding a bunch of this stuff that you're posting now into that. But yeah, there's already a ton of stuff in there. Yep.
Thank you. I saw a few weeks, I think, maybe 1 or 2 weeks ago. I saw, but I don't remember the details. There was a guy. I don't know where I saw that. Someone did post it. I don't know if it was Logi.
Oh yeah.
The guy was using some camera, and Globers talk about you see planets and and so on around, and that guy was doing it with a camera. He was having like different objects, and but I don't I don't remember the details. So he was showing how some optical effect that it turns even a square into a circle. So, but I don't remember. I just saw.
Yeah. I've got that video saved somewhere.
Okay.
Yeah, it's pretty cool. Yeah, the one I saw, the guy he breaks off like some pieces of glass, and then he shines and the glass is all different shapes, and he holds a board up to the glass and shines a light on the glass, and then the light that's reflecting off the glass, it takes the shape of the broken glass on the board. So some of the bits of glass look like a square shape, and then when it reflects the light onto the board that's close to the glass, you see like a square light. And then so he's got a bunch of different shaped bits of broken glass, and then what he does is he moves the board further and further and further away from the glass, and then at a certain point, every single reflection of the glass turns into a perfect circle. It's
exactly.
Trippy.
I think that's the one.
Yeah.
So, Rayleigh Criterion did post another link. It's from the same YouTube channel. Thank you. Okay. Do you have that link, DJ?
To the one you were just talking about, or the one I was just?
Yes, the one that you were talking about. Or maybe you can find later.
Yeah, I'll see if I can find it. It's somewhere in my giant folder of it's like my downloads folder. So it's crazy at the moment. I need to go through it and categorize everything.
It's a lot of gigabytes going on there right now. No. Yeah. So I think it was that one, but I just saw someone did post it. I don't know if it was Logi, but I don't remember. I just did watch it and I didn't save the link. But yeah, it was a very interesting one. there's a I was thinking, so that there's sometimes you see this video, and it helps to explain some things that Lobos are asking. Or it debunks some of what they are making claims, but yeah, there's sometimes there's some interesting videos out there and observations. Even normal people are doing just some videos, and we can use it. For example, I think maybe if it was yesterday or today, yeah, it was today. On Facebook, I was reading a comment from a Glover, and he was claiming that the sun, was traveling, doing a straight line, a straight path, sorry, during the day, And actually, I did said to him, actually, he's not doing a straight path, and I did. Because I did work even this summer as a watchtower, so there's a big protractor, laid down horizontally. You guys have a different name. Let me see where I can find that. It has a specific name in English, but it's a protractor, and it has 360 degrees. So 360, or let's say 0 degrees, it's pointing north, specific directed to north. So east it will be 90 degrees. So so opposite side it was west. So 270 degrees. It will be west. So he's claimed that the part of this. First, he did say that the sun it travels. So that was very interesting. But then he was claiming that it was doing during the day a straight path, and actually it's not, because my observations, and with that instrument, I could of course you have the analemma, so each day of the year you see the sun setting or rising at different positions. But so I did watch one day. I have some videos, but I have to organize that. So through that, in the middle of that protractor, there's a monocle or a scope, and there's, so you point to a direction, and at the same time there's a metal bar that you can see the degree horizontal. So yeah, I did watch sunrises, and it was not exactly at 9 degrees. Sometimes it was less 10 degrees, so it's a huge difference. So it was like starting at east, let's say 80 degrees. It was like that. So it was not exactly at 90 degrees, and then as it was appearing rising, I saw going from 80 degrees until 90 degrees, and past that, even at 100 degrees. So it's not doing a straight path from east to west. And then, I couldn't do more observation because, as it's rising up, I don't have that scope. It cannot. I have a roof, so I cannot follow. Even the scope cannot rise, inclinate, too much. But then I saw. So in that day, I did went to a job at 8 a.m. So, and then I left at 4 p.m. But in the next day, I did enter at 4 p.m. and then so I could see sun settings. So yeah, even that doing observation, pointing the scope into the sun, it was hard sometimes because you can get blind. But I saw as it was going to winter, so it was October. So I was watching the sun setting not at exactly 270 degrees, so it was less, 10 degrees less. So and each day there was less than that. So yeah, so the sun is not doing a straight path. Of course, there's perspective. You have to account perspective, but but yeah, it's not during the day. Is not doing a straight path. So that's my observation, and you can account, let's say, margin of error like 1 degree. But even that, we have a lot of degrees there that already debunks. So it's not doing a straight path from east to west. It's doing like an arc, and that's it. I don't know if someone can do like some kind of simulation. How would it will be like on a ball Earth, the sun crossing the sky, but there's a lot of degrees there that already debunks. Some Globers, they say, oh, sunsets proves the globe, and that's not true. Even I did this summer an observation. So the sun was going away, and it was it was in that place that I was. It was getting less light, and the sun was above the horizon. So that's I was getting less light. So yeah, sunset doesn't prove anything of a globe. It was getting dark, and the sun was still above the horizon. So that means that of course there's weather conditions, but it means that even the light of the sun has range. Even a single cloud can block the sunlight. And as the sun is going away, you have a lot of things between you and the sun that can interfere with the observation. At night, I even with a flashlight, sometimes has some wind, and you can see dust particles in there. That during the day you cannot see it. So it's amazing. There was a documentary a few weeks. I saw it. The guy was talking that people think that that the air is transparent, but actually there's a lot of things going on. Even at summer, you can have a clean sky, blue sky, and because of the too much hot, there's this white haze. I saw that even half of a mile because it was too hot. And there was a fireman, the guy did. Actually, he was my friend, and he did. He was there at the same time. I was there in the watchtower. They were on prevention that day. A lot of firemen, different departments, let's say. So from different regions, they were there, just standing by in that spot that I was, So even that fireman, he did when he did come, up to my tower, and he was talking about that, because of the hot, you see this white haze. So he was know about that. Yeah, it's interesting, The day that I saw, so I was watching the sun at the morning, appearing, at the horizon at east, and I was working near to the border with Spain, Portugal to Spain, and had a window, so it was pointing directly to east, and the sun was appearing, and it was not. I was not seeing the sun directly through that window, So, but as the hours, it's a few hours was passing by, or a few minutes, the sun was appearing. It was already above the horizon, if you could look at that window at the left. But I was sitting, and the sun was not directly in front of me. So, and then a few minutes or half an hour, it was there, in front of me. So yeah, I did realize that at that day, yeah, what's going on here? So it's not, the sun is not doing a straight path between, from east to west. So I did realize that, with that observation. Even did put, a compass, from the app of my phone. So I realized that the sun, when it's rising, appearing, the morning, it was not doing a straight path. It's doing like an arc from left to right, and that's it. It's very interesting. Sometimes you are working, and at the same time you are doing some observations.
Found that video for you, Miguel. It's in the side chat.
Okay, let's see. Thank you. Yeah, that's a good one.
So it's almost 2026, and we still got people that think they live on a spinning ball. Is that correct?
Yeah. Some of them, they think they came from monkeys.
The only reason they think that, Miguel, is because they haven't really thought about it. If you know what I mean.
Welcome, Inkle. How have you been? Everything else
doing good. All the way from Kentucky, USA. How about you, man? You're in Portugal, right?
Yeah. Next to Spain.
Everything's going good there, I hope.
Yeah, we are not in war, so we are better.
Happy New Year to everybody that's listening, and you yourself, Miguel.
Thank you. You too.
Bye. Yeah, people are still convinced they live on a spinning ball. Crazy, man.
The spinning and
ball.
Well, who's there? Let's see. Jean? Oh, Jesus Christ, who is talking? Welcome.
Hello, whoever said something right now. Can you talk? Who was that, Miguel?
I see two open mics, so I don't know if it was Christ or the other guy. The other guy just left, so maybe it was the other guy.
Well, we're here patiently waiting to discuss the nature of reality. And here's some globe evidence if you think it's a spinning ball. I dare you. Looking over the panel here, Miguel, I don't see any obvious globe believers. It looks like all crazy flat earthers.
Crazy in the good way, right?
Yeah, the crazy guys that accept reality as it presents itself. I mean, can you imagine that?
A globe earther.
Who's the globe earther? Who said that? Swastik? Hello.
Yeah, hello.
You think you live on a spinning ball? Is that correct?
I accept the concept of globe earth.
All right. How good is your English? I'm not sure if I'll be able to talk to you.
I said I accept the concept of. I said I accept the concept of globe earth.
Okay. Do you have any evidence for the globe earth?
Yep. The evidence I take is from the oldest written
Good
book.
afternoon, guys.
The
One
what?
of the oldest written book. One of the oldest written book. Surya Siddhant I take from there.
So your evidence that the Earth is actually a physical globe is what somebody wrote in a book a long time ago. Is that correct?
Yep. And it is written by Indians. I can give you every.
You're okay with that? You wouldn't rather have something like measurements of Earth curvature or anything like that?
The measurement is given. How did they come up with that number? Now I cannot say that because the original text lost and that text was given by to sun god to Maya demon in Sati Yuga. That is the golden age, but it was lost, and we have from 4th to 5th century. We have a copy of this book from 4th to 5th century CE. We are having, and since we don't have the original text, we only have the number given, not the number given.
You kind of lost me, whatever you're talking about. Are you listening, Miguel? Want to respond?
Yeah, the numbers are given, but the text is but how did they come up with the numbers? That is not given. That is not sure. Only the numbers are given in the text.
Has anybody ever measured the curvature of the Earth? Are you saying somebody a long time ago did?
Said now this text is given.
Go ahead, TW. There.
To Maya Dima.
I think he might be saying that they don't give those details. But I ask you, does it say that everybody lives on the outside of the globe?
I haven't. By the way, let me say this. This text is I can give you the exact the what is they're taking as the measurement. Wait, let me just find out the measurement.
Does it say that people live on the outside, on the exterior of the globe or the ball? Or could it be possible that it's could it be possible that it's talking about living on the inside of a globe?
Neither of the it is talking from a geocentric. First of all, let me say this: the model they are using is geocentric model, but the Earth they are using is globe. Hello. Hello. Is anyone there?
Yes, it's wrong.
We're still here. Are you talking about the Quran? What somebody wrote in the Quran? Is that right, Tito?
No, this text was given by, I said, the sun god gave it to Maya demon in the golden age.
But you don't see a problem with seeing stuff from whatever century you said written in a book, that proves to you that the Earth is a physical globe.
Yeah,
true.
because the Sanskrit word for the Earth to be a globe is what we call as Bhugol. And Bhugol, if we translate to English, it literally means the Earth is globe. Or Earth is
I'm not
round.
sure I can help you. Does anybody else want to try?
Yeah, I'm talking about the Sanskrit word for globe Earth is, or the Earth round is Bhugol. If we break down the word, goal here means round. Round means it is spherical. And Bhu means Earth. So Earth is spherical.
So if it's spherical, why can't we measure it?
We can measure it using various tools, even if those are available.
Okay, name one. Name one way to measure the curvature of the Earth. Go ahead. What's your first tool you're going to use?
By the way, I'm using this text to actually prove that Earth is round, and I'm using Surya Siddhant. The copy of the Surya Siddhant is from 4th to 5th century, which is Varahamir's copy. But the original text that is given by sun god to Maya demon is lost.
I understand you believe that whole story, man, but you're not talking about Earth curvature again. Does anybody else want to try?
Yeah, I got your point. If it's Earth's curvature, and I gave you every details of Earth's curvature and everything.
We're talking about an actual physical measurement. Sorry, go ahead.
Well, now you've made a bunch of claims, and now we need to see the validation of the claims to make sure the claims are true.
Yeah.
Yeah.
By the way, let me say this: since the original text is lost, so we don't know how did they come. How the calculation was given. We only have we have the end result. That is, these numbers are given. We have the end. Have the
Well, that's unfortunate.
Calculation, because the original text was lost, so we don't have the calculation.
Okay. Well, then we can dismiss that one. What else do you have?
This is the only one we have, because this is used by in Indian astrology and astronomy. This text is used in Indian astronomy and astrology to calculate time. Any kind of rituals and festival.
So are you saying that's all you have is something somebody wrote in a book millions of years ago or whatever? Whatever you said. There
Because
you go, Earth crew, globe crew.
You can give the book's name. You can search it up.
Well, this disagrees with the mainstream claims as well. What you've posted, so
no, it does not, because this is used by Hindus only. This text is used by Hindus. Go on. This is our only Hindus. You can check up.
Yeah, but the numbers don't match up with the mainstream numbers.
This is actually I gave you the numbers does not match, because I gave you, look carefully, I gave you the unit actually, how yojanas are actually taken up. That is 8 to 15 kilometers. Now you can, that's an approximation. 8 to 15 kilometers.
Okay. Well, this is different to what the mainstream teaches.
Because it clearly says that if we take the yojanas as 8 to 15 kilometers, then we will get this approximation.
Well, 8 to 15, that's a big range.
Yeah. Any number it can be between 8 to 15, including 8 and 15. And that is where we are getting these numbers. That means Earth's diameter can be from 12,800 to 24,000 between. And the known measure being 12,756 kilometers.
Hey,
It
well,
is giving both.
yeah. So these are claims. I get it. These are claims. This is not. This is not proof. I'm saying that we now we need to validate the claims.
So only way to try validating it, you will only have to, because the problem with it, if you are asking for a claim, you are asking for a validation, and you are living in inside the earth. To actually literally validate the claim, you need to go to moon in order to validate it. Because
Well, we
from
can't
moon
validate it then. So you can't so we can't validate it.
There's another method we can use the elevation.
Everyone says that there is flat resistance.
Yeah, sorry. English only, please. Google person 02.
That's English.
I'm talking in English only.
No, it wasn't English.
I have some
English only, please.
problems in the pronunciation.
English only, please. So,
guess which country I am from?
I'm in the middle of a conversation with my friend Swastik.
I don't get that.
Okay, so
let me find the text first.
This is the problem, right? You can't back up the claims.
Okay, I got it. I got the text. You can check up the text. I got it. The text first. You can search this. Sorry. Wait. Wait. I'm just looking up and it's not coming. Why? Coming up. The problem is my net is getting slow. Wait, let me just find out the book because it's not coming actually. Wait, I'm looking for the evidence. I'm looking for the evidence actually.
Okay, I don't see anything.
Looking for it. Wait. Let me just this one. You can look up in this one. You need to search up and you can look up. It's here. I gave you a text. Hello. I gave you the text. You can check up.
We're looking for curvature. It's 2026. We're still looking for a curve.
All right, I'm checking what you linked.
It's a text, and it's the English translation of a Sanskrit
Yeah,
text.
yeah, I know, but this is the claim, right? This isn't the proof of the claim. This is just the claim
There are
again.
too much calculations given there. So you need to search
Yeah,
up
but
for.
calculations, we need to make sure the calculations match reality.
Yeah. You know, the calculation must match the reality.
Correct. So this is how we can test the calculations. Okay, so we can do some calculations of our own.
Given?
Yeah, think about
Yeah.
this. Okay, so the calculations means that if the Earth has the diameter that you said it does in the text, then if we go to a large body of water, like the ocean or a large lake, then we can calculate how much curvature there should be over a certain distance. Okay, the surface of the water should be curving a certain amount over a certain distance. Do you know what I mean?
Mm-hmm. Yeah.
So over, say, 16 kilometers, which is 10 miles, there should be about 20 meters of curvature. Just a bit more than 20 meters of curvature, which is 66 feet of curvature. When we go out to test for this curvature that should be there, it's not there. It's just flat. So it doesn't match the reality.
The flat that we are seeing is from our perspective. It's not.
Yeah. Hold on a second. What I mean, this is what I mean. Okay, so globe Earth or flat Earth, you would see it as flat. I agree. But there would be byproducts, right? Like things in the distance should be hidden behind the curvature of the Earth. So if there's 22 meters of curvature over 16 kilometers, I shouldn't be able to zoom in and see something that is 5 foot tall 16 kilometers away. It should be hidden behind the curvature of the Earth. So while you don't see the curvature, you would see the byproduct of the curvature. The result of the curvature would be obstruction of things in the distance. Make sense? Let me show you an example. Can you hear me?
Bring my point. Clear.
Your microphone was going crazy just then for me.
Okay, I said I can hear you.
Oh, okay. All right, so let's test the claim. See, when I say we should test the claim to make sure it matches reality, we went and tested the claim over and over and over again, many, many times. Okay, so here is some footage from one of the tests where we have a camera height of 1 meter and we have some windmill farms in the distance, like windmill towers. Can you see the observation?
Hello, everyone.
Hello. Welcome.
Thank you.
Yeah, we're just currently going over a long distance observation that is impossible if the Earth were a globe. It's in the side chat.
What is the topic?
Flat Earth.
Hey, could I ask some questions about this guy's? I don't know what he's doing.
Yeah, sure.
Okay. Well, about 5 or 4 years ago, I also used to be in like kind of a red pill group with some people. It was mainly during COVID, I believe, where I was introduced to the group. But later on, I lost touch with those people, and I started like just doing my own thing and not really bothering with those things anymore. And I was also kind of reading about flat Earth as well. And what was asked sometimes was, what is exactly the point of the people deceiving us with a globe? And then somehow it was linked with Christianity or something. I myself am Muslim. We do not. It's not necessarily mentioned in our text whether the world is a globe or flat. It's not really relevant to us. And I want to ask, why is
They're
it
not
exactly?
necessarily deceiving us with a globe.
What?
They're not necessarily deceiving us with the globe. So it's not necessarily that somebody is out there going, oh, Earth's flat. We must tell everybody that it's a globe instead. It's not like that. I don't see it that way anyway.
Okay, so how would you see it?
I see it as a long time ago, some people tried to make sense of some stuff that was happening in the sky and decided that in order to make sense of it, the Earth must have been a ball. Except the Earth doesn't agree with that sentiment, right? Despite that, they went ahead with it anyway and taught that to everyone, and it caught on. And finally, the most of the world accepted it as being true. And then some people came along and went, well, we don't really care if it's true or not. We're going to exploit that and tell people that we can actually go far away from the Earth to actually see it like that. And we're going to pretend to do things out in space, right? And tell them space is Earth's surrounded by a big giant vacuum, right? Yeah, that's what happened.
Okay, so they do know that it's flat, or?
No, they don't. They haven't actually been up there to see. That's the thing. They're pretending to do that. I don't think those people even really care if it is or not. They care about just pretending to be able to do things that they can't actually do.
Well, I just also want to ask him quickly what he means when he says they. Like, do you mean the government, or do you mean the professors or the scientists? Or...
Right. So while I, maybe I should have clarified that earlier. While I was in that community of mainly conspiracy theorists, it also, like, of course, came up that the government and, like, what was it called, like the cabal, deep state, whatever you want to call it, they knew that it was flat, and they kind of wanted to sell us that it's actually a globe. That's what I meant, but I'm not sure if that's actually true. I haven't researched that thoroughly, but it's just like what I've seen, like, a lot. And I'm just wondering what exactly the perspective here is on that.
It would probably be a lot of speculation involved in that claim. Yeah, you go ahead, Tino.
Well, the reasoning behind what I said is that in order for it to be the case that that it's flat, like that somebody knows it's flat, but they want people to think it's a ball, means that, like, everybody thought it was flat, and somebody went and, oh no, look, we can go far enough away. I'm sorry, guys, you were wrong. It's a ball. That's not how it happened, though. So why would you need to convince people that already think it's a ball that it's a ball? Doesn't make any sense. So that was I just wanted to explain some of the reasoning behind what I said earlier.
Okay, so here it's mainly for monetary gain, no?
No, it's because most people genuinely believe that the Earth's a globe. In my opinion, that's my opinion. Most people just were taught the globe growing up, and the people that taught them that it was a globe were also taught it was a globe. So it's kind of like something that's just assumed by most people as being correct because they got taught it in a textbook at school, and then it was reinforced throughout their life, and they never questioned it, they never tested it. Most people don't really know much about it when it comes to technicalities. It's just a belief system that people have. It's a theoretical, mathematical concept that has become the normal.
Okay, right. So there's no some kind of hidden agenda. It's just like an incorrect belief system that's in place.
Yeah, there's absolutely some deception behind it as well, but that's when it starts to get into the weeds a bit. Like, if someone asked me, write a list of people that know the Earth's flat, but they're lying about it and telling you it's a globe. It's very difficult to write a list of names and then prove that the people on the list are actually actively lying about it. I think that's an impossible task. So there's a lot of speculation. Sure, some people would have to be perhaps in on it, but you could even fake the moon missions like NASA did and still believe that the Earth's a globe. So most people that at NASA would genuinely believe that the Earth's a globe. Most people in the government genuinely believe that the Earth's a globe, for the most part. So I wouldn't say that they're lying. And your college professors and your scientists, for the most part, are absolutely not lying, in my opinion. They're just repeating information. That's kind of what they encourage in the education system. Memorization and regurgitation, and you get a pat on the back if you're good at that. Not questioning the core foundations of the globe model or the globe concept, whatever you want to call it.
Okay, thank you. That clears it up.
Good question. And there's also a killer observation in the side chat there at 38 minutes after the hour. That just destroys the globe as well.
Hey there, DJ. You still here?
G.
Hey, did you play that song I sent you last night?
I did not. I can play it right now, though. G, that's hilarious, man.
Say that again. My volume is down. Sorry.
I said that's hilarious. I love it.
Yeah, I had to steal that. Last night I was digging through the server, and then I was favoriting DJ Rakesh, and then that popped right in my head, and I'm like, it might make him mad for me stealing his character, but I got to.
That's hilarious. I love it. I'll add it to the DJ Rakesh section.
Yeah, cool. Are you able to download it from that link I sent you, or do you want me to download it and send it to you?
Oh yeah, I think you'll have to download it.
Okay, I'll do that here in a bit. Yeah.
Cheers, man. That's funny.
I mean, you have to admit, there's probably more than a few conversations happen exactly in that order. It starts with the first step and then goes to the second.
Definitely.
Yeah, I think the Globers are too afraid to step in today.
Unless Yuki. Maybe Yuki has the answers that we're looking for. Or maybe Yuki knows that the Earth's not a globe.
That was actually quicker than I expected. So there you go. It should be in your inbox any moment.
Welcome back, lads.
Yo, what's up?
Not a lot at the moment.
That's right. People are gonna come in eventually.
Welcome to the new people who have joined.
Space. It's completely different system, different way of thinking about this system that we live in.
Okay, do you believe in gravity?
Like, how long is this flat bed? Like, do you know? Like,
yeah, I don't know the size of the Earth in entirety. Right? We're just testing the surface and not finding any curvature consistently. Hold on, you're both asking questions. It's hard to answer both at the same time.
Okay.
And look for this video. Right, so in the side chat, this is a really good video. Okay, Dr. John D. Check it out when you have time. Right, this observation is impossible on a globe.
I have question. I have two questions. First is, do flat earthers believe in gravity, and what about you?
Gravity is something that's required to have a globe. Okay, so you guys need to be able to explain how you can have a globe in the first place. Okay, floating through space, spinning in all of these different directions at the same time at 1.5 plus million miles per hour. You need to be able to explain how you can have oceans sticking to the outside of a spinning ball. You need to be able to explain how you can have gas pressure on a ball, right? On the outside of a ball that's inside a big giant deep space vacuum. Okay, so all of these things, you guys are going to need some kind of explanation for all of these things that seem to defy logic and common sense. So you have gravity to try to explain all of those. We don't need to have such a thing in reality, okay? Because we live on a flat, stationary, enclosed system, okay, where we don't need gravity in the sense that you're thinking of gravity.
Exactly. Then why does stuff fall down rather than any other direction? Like, why?
Well, things, not everything goes down, right? So we have the air, right? That's what everything's in, the medium of air. Okay, so air is a very light medium. It's not very dense. And most matter, most objects are more dense than the air. Okay, so if you pick up a rock, it's more dense than the surrounding medium of air. So if you let it go, it's going to sink down to the ground. If you have a helium... Well, let me get to that. Okay, so if you have a helium balloon, it's going to go upward because it's less dense than the medium. Okay, now why is down, down, and why is up, up, right? These are like two primary directions that things will go, whether they're more or less dense than the medium. Nobody knows why down is down and why up is up. Nobody. Not from the globe side, right? Not from the flat earth side. But we can easily test and validate, why things are going, why something will fall and why something will rise without knowing why down is down and why up is up. Okay, down is down for every single person is the same direction on a flat earth. Whereas on a globe, down is a different direction for everyone depending on where they're located on the globe, and up is a different direction for everyone depending on where they're located on the globe.
Okay, I have another question. Okay, so it's either one of us, like the flat earthers or round earthers, is being gaslit, okay, and scammed, whatever the word is. Why do you think that? Like, what's the benefit?
Well, I don't think that. For the most part, I think people that genuinely believe the Earth's a globe are not lying. For the most part, right? Like your teachers, your university professors, most scientists, most people that work for the government, even most people that would work for NASA or SpaceX probably genuinely believe that the Earth is a globe. And they're just repeating the information that they were taught. Right? And they probably never actually went out and empirically tried to validate that, right? They just, they were just taught that from a young age. They've probably never been presented a solid alternative argument for something else that could be, right? Because they experience the Earth as flat and stationary, but they get told from a young age that, hey, you're just too small. Okay, so you don't see any curvature. You see the Earth as flat, and because you're so small and the Earth's so big, you don't feel it moving. Okay, so everyone experiences a flat, stationary Earth. Most people just believe that they live on a globe because that's what they were taught. Okay, it's a theoretical mathematical model or a concept that most people just blindly believe in, and most people don't really know much about it.
Can you talk about the moon? I don't know how to to come up with the question, but like I feel like the moon should say something. Like, why is it just floating there? You said you don't believe in a globe, you know, or like space. Like, what is the moon?
I try not to make claims about things that I can't empirically validate, right? Such as things that are too high for me to test, too high for me to validate, or too far away for me to reach. Okay, so when it comes to the sky, right? Everything in the sky moves in a particular cycle, like a big giant clock in the sky. Okay, so we see the sun, the moon, the planet, the stars, right? All taking particular cycles in an east to west direction over our head and resetting back into the same positions for all verifiable history. Okay, the Earth there's no evidence that the Earth is moving, and the celestials are taking a particular motion above our heads. Now, exactly what they are, what medium they're in, what size they are, what distance they are, etc., I don't think anyone can empirically validate that. So it's going to be speculation, and we kind of try to stay out of speculating about things, right? So I don't know, and I apologize. I don't have a counter explanation for every single claim that the globe side makes. I'll stick with what I can empirically validate, like the surface of water not having curvature.
So you're saying, since you can't reach it, you just don't know if it's denser than air or like lighter than air.
Well, I don't know anything about it, right? I don't know anything about what medium is it in, like what medium is up there. I'm not sure personally. I'm not sure how far away it is. I'm not sure what it's made of. Now, I'm not agreeing with this, but there were actually scientists in the 60s saying that the moon is made out of plasma. I'm not saying that I agree with that, but mainstream scientists were saying that back then. There's different interviews with them talking about that, saying how it's not possible for anyone to ever go and land on the moon because it's plasma. So I'm not sure. People can have different theories about it and different models, right? But what we need is empirical evidence to back up these speculations about the sky.
Alright, who's behind all of this? Like, who's the mastermind to make us all believe that it's rounded?
I have no idea who the mastermind is, right? But it was first proposed, right, by the ancient Greeks, and it was more conceptualized into existence rather than empirically measured or tested. If you look back in history, you need to learn about the way that they viewed the celestials, right? And the way that people observed the sky. And eventually they made a coordinate system out of the way that they viewed the sky, right? The celestial sphere. And they envisioned the heavens as, a big spherical system. Okay, where the stars were on the inside of this big giant dome-like sky, right? A way of conceptualizing the way that we view the sky. And later on, they inverted that, right? They said, as above, so below. So the Earth must also be like we see the sky, right? So they inverted that spherical celestial sphere model, right, that they envisioned the sky as a concept, right, and they turned that into a terrestrial sphere. Terrestrial meaning the Earth. Okay, and that's how the globe came to be. And it's a lot more technical than that, but I don't have time to go over all of the technical details at the moment because I'm just about to head off. But yeah, if you have any more questions.
I have a question. So, if the land is flat, how can we have so many different time zones when it is morning in America, why it is or night at any other place? it should be day every time for every country.
Well, if you, that's what I was talking about at the start, right? If you try to picture the flat Earth inside the globe model, where you've got a 93 million mile away sun that's really giant, yeah, that wouldn't work. It would always be daytime, right? But that's not what flat earthers are claiming, right? So if you were to speculate that the sun is much smaller, right, than the 93 million mile away globe Earth version of the sun, right? Okay, much smaller sun, much closer sun, taking a particular observational path, right, over the surface of the Earth, it would be lighting up different sections of the Earth at different times. Okay, taking a particular cycle, which would create day and night and seasons. So when you just say it's midday in Australia, right? The sun's going to be directly above you in the sky when you're standing in Australia. At the same time, it would be nighttime in Europe. Okay, and then the opposite. Okay, so 12 hours later, it's going to be the opposite of that. Okay, so it's midday in Europe. You're going to see the sun directly above you or close to, right? And you're going to have the opposite in Australia. It's going to be nighttime. So the sun is taking a particular cycle above the surface of the Earth, just like we see the sun move across the sky east to west. Okay, we see it rise and set within our field of view due to perspective, right? The way our eyes work. And it moves away. It moves away from you. And when it's moving away from you, it's taking its light with it. And it's the light from the sun is not able to push through the density of the atmosphere, right? Because a medium like the atmosphere or a medium like the ocean, right? It absorbs light. And then as the light moves away from the source, we also have the inverse square law of light. So the intensity of the light quickly diminishes as it moves away from the source. Okay, so it sort of gets eaten up by the air. Think about this: 200 meters deep into the ocean, it's pitch black. You can't see the sun. You can't see any light from the sun because the sunlight gets absorbed by the medium because water's quite dense. Okay? And the sun can't travel forever through the medium. Now, the air is also a different medium. It's just not as dense as the water. Okay, so it still happens. The same thing happens, but on a larger scale.
So what you're saying is the sun moves further away when it's night and comes closer when it's day. Is that right?
Yeah, the sun's moving over the surface of the Earth and lighting up different sections as it travels overhead.
I have a question, okay? Now, based on my observation and probably any other person listening to me, you can see the sun every day directly to your side or like in front of you, where in your the way you said it, you're only supposed to see it above you or like diagonally going further away, but still above you. But I can literally see it in front of me,
Yeah, so as things move away from you in the distance, they're going to appear to converge with the horizon due to the way perspective works, whether it be a cloud or a bird or a street light or a plane. Okay, as things move away from you, they're going to look like they go down, 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 and then eventually they're going to converge at the vanishing point, which is going to be at the horizon.
Oh, that has never been the case with clouds and airplanes.
Yeah, it absolutely is the case with clouds. I actually have a really good video to demonstrate that. Okay, so in the video that I'm gonna try to find it in a second.
Bro.
Okay, so we have a guy. Okay, listen, just for a second, just with the clouds. Okay, so we want to use the clouds as an example. Okay, so when you see clouds in the distance, they look like they're going down and converging with the horizon. That's just due to perspective, and I have a video that proves that. Okay, so in the video that I'm going to find, we have a pilot in a very small plane, and he's standing on the runway, and when he looks down the runway, we can see the clouds in the sky, and we can see the clouds, they look like they're going down and meeting at the horizon. Now, what you'll notice is that he keeps filming and he goes up into the sky with his plane. When he goes up into the sky, you'll see those same clouds that looked like they were going down completely flatten out into a completely flat deck of clouds. Because when he goes up to the height of those clouds, he doesn't have that perspective convergence issue anymore that makes the clouds look like they're going down. Similar to the way when we look down a hallway, it looks like the ceiling of the hallway is going down and the floor is going up, right? And then they meet at a vanishing point, which is a point of convergence. The same thing happens on a larger scale with the clouds. So I'll just try to find a video that shows that exact thing happening. Old Dude just posted a little diagram in the side chat just to give you an idea of what I'm talking about. So you'll see some lines. It's called perspective convergence. It's just the way our eyes work. I'll just try to find this video quickly. Right, so here's just an image, right, while I'm still looking for the video. So this is a hallway, okay, and it's overlaid over a picture of the ocean. Okay, so you can see that you can relate the way that perspective makes you see the hallway, and then apply that to the same way that you see the clouds and the water at the ocean. So yeah, there's a whole bunch of images that basically explain what I was saying in the side chat, right? I'm having trouble finding the video at the moment, but I'll find it shortly. Does that explanation make sense?
Yeah, kind of.
Yeah, you just got to learn about perspective. Like, look at this last image I posted. Okay, so this
sorry, if I compare.
You go ahead, man.
These two, if I compare the way I see the sun move, okay, and change perspective. If I compare that to the thing you're trying to explain, it's not the same, and I think that we can see the difference, and I think it's different. It's very different.
Well, it's actually not that different. If you just scroll up a little bit, scroll up to 57 minutes after the hour. Now, obviously, the sun is much, much further away. Okay, and you're seeing glare, and you're seeing you have a lot of atmosphere between you and the sun. Okay, so it's going to behave different than something that's very close to you. Okay, like looking down a hallway, right? You don't have much atmosphere between point A and point B, right? You don't have a light, right? You're not looking at a light like when you're looking at the sun. So yeah, it's not the same thing, but it's the same concept, right? Still perspective. Okay, have a look at this example. I'm just going to put an example in the side chat. Okay, so here's a straight line. Have a look at what I posted. Okay, so it's someone set up a string going horizontally across their kitchen top counter. Okay, and he's got the camera up at the height of the string. Okay, and you can see that the string is straight. Now what he does is he actually puts the camera down on the ground to represent how we would see something up in the sky based off perspective. And now have a look, right? That straight line that he was pushing that little light across to represent the sun, all of a sudden it looks like it's going downward. Okay, and it looks like that sun's going downward. But it's not. It's just perspective that's making it appear that way. There's a video that shows this entire demonstration with the sun and the countertop, but I'm sure you understand what I'm talking about.
Do you argue that How do you justify the seasons? The summer and winter.
The seasons, like, I was explaining before how everything in the sky moves in cycles. Okay, so the sun also moves in particular cycles. Okay, so the sun's going to be taking a particular cycle over different sections of the Earth during different times of the year. And that's what's going to be creating seasons, right? So if I'm in Australia and it's summertime, the sun's going to be taking a path where at midday, the sun is directly above my head at midday. But during winter, okay, at midday, the sun's going to be much lower in the sky because it's taking a path over a different section of the Earth relative to where I'm standing in Australia. So at midday in summer, directly above my head. At midday in winter, it's going to be much, much lower in the sky. Now, during winter in Australia, when I see the sun much lower in the sky, in the north, where, say, Europe is, okay, so someone standing in Germany, when it's midday for them, the sun's going to be almost directly above their head at midday. Right? So it's moving in a particular cycle, but when it's winter in Germany, right, they're not going to see that sun directly above their head at midday. It's going to be much lower in the sky because it's taking a slightly different circuit over the surface of the Earth, or a different path, a different apparent path. It might be hard to wrap your head around at first because I don't have a diagram really to show you. But I'll just put, it's like a kind of like a time-lapse photography of the analemma, which kind of explains what I was just talking about.
Then why don't the Antarctica ever get sunlight?
It does. So in the north, sometimes, we have the 24-hour sun in the north, and then sometimes we have the 24-hour sun in the south. But when we have the 24-hour sun in the south, it's 24 hours of darkness in the north, right? Because of the particular circuit, or not circuit's probably not the right word, the particular apparent path of the sun, right? It changes. So let's say we're in the north, right? In, say, Iceland. Okay, so when it's winter in Iceland, when it's summer in Iceland, the sun will be taking a particular path that's very close to the north. Okay, so you're going to be able to actually see the sun in the sky for 24 hours during the day. And then it would be at the same time in the south, it would be dark, right? In the far south, like in Antarctica, it's going to be dark 24 hours a day because the sun doesn't go close enough to that particular area for the light to reach it, right? To light it up. And now I'm just explaining what everyone observes. I don't know I'm not making a definitive claim about exactly how the entire system of the sky works, right? I'm just kind of explaining what everybody observes and giving you an idea of how it can work over the top of a flat plane. How do we know the plane is flat? Because we go out and we can consistently test the surface of the Earth for curvature, and we can't find any. Right? That's the basis of the argument, is if you have a globe, you have to have curvature. And when we go out and test for curvature, there's zero curvature.
Are you talking about the average, everyday, when you say go out and observe like any person, or like you're talking about scientists or people who do tests with equipment and stuff?
Yeah, people that go out and do tests with equipment. It can be anyone from a scientist to just a general person, right? It's not difficult. Okay, so you just need to find a large body of water. Okay, and if the Earth were a globe, you can calculate how much curvature there should be over that distance of water, and then you can test for it, right? Because if it's a globe, then let's just say we have a 10-mile body of water, a 10-mile lake, or a 10-mile section of the ocean. If the Earth's a globe, there has to be 66 foot of curvature over that 10 miles. Okay, so we can go to a 10-mile lake and try to find that curvature. 66 foot's quite a lot. That's 22 meters of curvature. Okay, so you shouldn't be able to set up a camera on one side of that lake and then zoom in and see the shoreline on the other side of the lake, right? Because it should be hidden behind the curvature of the Earth. But we can do that. Yeah, we can go consistently to this lake and we can zoom in and we can see things that we shouldn't be able to see.
Oh, sorry, you said 66 over how long?
Yeah, 66 feet over 10 miles. But it gets, yeah, you can look that up yourself. You can go on ChatGPT or anything like that. Look, this is what you would do. Go on Google and type in Earth curvature calculator, and there's a huge amount of Earth curvature calculators. So you can put in the height of the observer, put in the distance, and it will tell you how far away the horizon should be and how much should be hidden over that distance. So over 20 miles, right? It gets bigger as you go further. Okay, so 20 miles, say we have a 20-mile lake, there should be 266 feet of curvature over that distance. So if you're standing at a 20-mile lake on one side of the lake, okay, and the Titanic, right? You know the boat, the Titanic that sunk? Okay, just say the Titanic was docked on the other side of the lake, 20 miles away. You shouldn't be able to see it if the Earth were a globe, right? It would be hidden behind the curvature of the Earth because the Titanic was 175 feet tall. But over 20 miles, there's 266 foot of curvature. Okay, so if you're standing 6 foot tall, you just wouldn't be able to see the Titanic, right? It would be hidden behind the horizon, behind the curvature of the Earth. But when we go to a 20-mile lake, we can zoom in across the lake and we can't see any curvature. We can see flat water all the way across the lake.
Hey, what should I type on Google again?
Earth curvature calculator. I do have to go in a second. I'm sorry. Appreciate the conversation. Come back another time, or maybe I think someone else can pick up the conversation. So yeah, I appreciate chatting with you guys. I'm gonna head off.
All right.
Have a good evening or day wherever you are.
For me,
Appreciate it. Thank you.
You too.
Nice one, DJ. What's up, fellow flat earthers?
Hello. Yo, guys, he's a nice guy, okay? But please don't believe him, okay?
Don't believe him? Believe what?
Research.
What shouldn't we believe?
I said, I understand that he's a nice guy, and
Yeah, he's a nice guy.
I see honesty in him. He truly believes the Earth is flat. But
Well, he just said it measures
I
flat.
have to believe him.
But he said it measures flat, so if it measures flat, how could I not believe that it's flat?
Do your research.
Yeah, that's what I'm saying. He says it measures flat.
Okay.
So if it measures flat,
All right.
how could it not be flat?
If it measures flat, then it's flat.
Yeah.
But he says it measures flat.
Yeah, well, it does measure
Says
flat.
It's not facts. Doesn't have to be facts.
No, it's not just what he says, though. It's how the Earth is measured when anyone tries to measure it.
Okay, guys. Cyclone is also seems like a nice, honest guy, but guys, don't believe these flat earthers.
I agree. Don't believe me. Don't believe me. Believe the Earth. Go and check with the Earth.
Listen, if it's not meant to look like a rounded, sphere.
Oh, so you believe the government?
Like it.
You believe the government, right?
Not
That's who you're believing. You're believing NASA, but not nice old DJ there.
It's not only NASA, bro.
Yeah, it is NASA. They're the one telling you it's a globe. The U.S. military. So that's who you're believing. Not harmless old, polite, honest DJ. The U.S. military. Famous invaders of poor people. Blower-uppers of children. That's who you're believing. I bet DJ's never drone striked a child.
If they say the sky is blue, you're not gonna believe them, right?
Well, if I observe the sky to be blue, I don't have to believe it. I can just observe it, right? Does that make sense?
Yeah, makes sense.
But then if they tell you, actually, we're the US military and we're telling you, although it looks blue, the sky is actually green, you would believe that, right?
No.
Yes, you would, because they've told you the Earth looks flat, but it's actually a big ball, and you believe that.
No.
And you've never seen the Earth looking like a big ball. You've just seen it looking flat. But you believe them.
Okay, they probably sometime in their lifetime said that the sky is blue, and you still believe it.
No, it's not a question of belief. I just explained it to you. You observe it. But they've told you that what you observe isn't true, and that you should believe their story instead. And that's what you're doing. You're believing a story over your own God-given senses. Why are you doing that?
It just makes sense. It just makes
No, it doesn't make sense, because your senses don't detect it. It's nonsense. It doesn't. It's not sense.
It's logical, bro. It's just more logical.
It's not logical, though. It doesn't conform with even your base senses, so it can't be logical.
I bet flat earthers think it's flat because when something...
Because it's observed, measured... No, because it's observed and measured flat. Like, why would you believe you are 5'9" or whatever you are? Because you're measured to be so. That's it.
But the Earth is not measured flat.
Oh, okay. Is it not? What about a lake? What's a lake? Is that not flat?
It's supposed to be.
Okay, so the lake's flat.
It doesn't.
Yeah, so the water is flat. So the majority of the Earth is covered in water. So the majority of the Earth must be flat.
No, it doesn't have to.
Well, if the water's flat, it does.
Bro, do you comprehend how big the Earth is?
How big do you think it is?
I mean, it's big. It's big.
Well, I agree with that, but I mean that doesn't really mean anything. What does that mean? Earth is big, okay? Big and flat.
Oh.
You think saying it's big means it's a ball? Come on, dude.
Bro, you think if the floor in your house is flat, the Earth is flat?
No, I think if the floor in my house is flat, then the floor in my house is flat. Whereas I guess you think it could actually be curved, even though it just looks flat and measures flat and is used flat. It's actually curved. That's your logic. Come on, dude, because the U.S. military told you so.
Listen, the floor in my house looks flat. Sometimes.
Are you like under your bed sheets right now or something, dude? With a little flashlight.
Listen. When you take a closer look, sometimes you find curvatures. Even though
Nah, no one finds curvatures. The Earth has no curvature. That's why we're here.
As we're here.
Yeah, that's why we're here, because there's no curve. If the curve was here, we would not be here. But the curve is not here, so we are here. Understand?
Okay. What if there was curve and gravity?
Well, if we imagine the fairy tale globe story is true, then what? Then it's true. No. I mean, you can imagine the globe is true, but when you actually go out and measure it, you'll find it's not true. So you can keep believing it, but why would you?
Okay, that's the same thing with you. Like, why are we here? if the floor, like if the Earth is flat, like we could just fall sideways or like
What?
upwards.
Fall sideways from upwards. What does that even mean?
I said or upwards. Like
we could, if the ground that you're on is flat, you could fall sideways or upwards. Is that what you just said?
Yes.
That makes no sense at all, dude. So if you stand on a table that's flat, you could fall sideways or upwards because it's flat. Think about it. What are you talking about?
Bro.
You're just saying shit.
You can only fall down because the gravity is under you.
You don't have down on a ball. You don't believe in down. You believe in inwards and outwards.
No, it's the central point of the...
No, which way is down? Which way is down?
There is no down, yeah.
There you go. So why are you saying down if you don't believe in down? See how the globe fucks you up? You can't even say down anymore. You can't even operate in reality and say up and down. That's how messed up the globe is.
Common sense and not scientific.
Yeah, your common sense tells you that the Earth is flat and motionless. Have you never heard them say it's too big to see the curve? And you can't feel the Earth spinning or moving? So yeah, your senses tell you it's flat and motionless. Then the government tells you it's a big spinning ball.
So, when you're in a train, right?
Oh, here we go.
Miles per hour, and you have a glass of water. Why doesn't it just spill? Everyone goes.
Because it's in a container.
No, even if it's open.
How does that water stay in its container?
Because it's getting it. I don't know, but
because it's contained, isn't it? Water needs to be contained. The surface will be level.
Like,
yeah. Think about that in reality.
Why doesn't everyone just fall?
Why doesn't everyone just fall? What, just fall into the ground?
When not fall backwards. When the train is going forward, 100 miles per hour.
Because you're in a container. You're in a train. Try sitting on the roof of the train.
No, actually, that's the same thing.
No, it wouldn't be the same thing. This is why they don't let you sit on the roof of the train unless you're in India or something.
But what about, like, roofless cars?
Yeah, same thing. You're in a container. You're shielded from the outside air that you're traveling through. But on the globe, you're supposed to be not in a container, are you? You're on the outside of the object that's moving.
Okay, so you would have to see the container in order to know you're in a container. What if the container was built out of stuff that are not like seen, like not solid, like air or whatever it is? Like, I'm not too advanced with these stuff.
I don't know, dude. I think you're trying too hard for the globe. You should just be looking for some evidence for it. I mean, I get it. You believe in the globe, but it doesn't sound like you've actually got any evidence for it. And that's what you'd need. Because we're not just here to believe shit. We want some evidence.
So I have one last question before I go to bed.
A bedtime question? Okay.
Yeah, before I go to bed, I got one last question and I'll go out. So why does the sun set completely below the horizon instead of just getting smaller and fading away?
Well, it depends, because sometimes you can see the sun appearing to get smaller and fading away. It depends where you are and what the conditions are of the air that day. But yeah, you can observe the sun appearing to sink into the horizon. This is an optical effect. Things will decrease in apparent altitude as they get further away from you. Like, if you're on a long street and you see the street lights, over a distance, it'll look like the ones further away are lower down, closer to the ground. They're actually the same height, but because of the way your vision works and perspective works, everything moves towards the horizon, the vanishing line. And eventually, that light won't be able to reach you. The combination of your perspective and attenuation of light in air means that the light can't travel forever through the air. It eventually blocks it out. It's a combination of things which can result in what looks like the sun sinking down beneath the horizon. But that doesn't tell us the Earth's a ball.
Yeah,
So
no,
you are telling
I
me.
don't think he understood because.
So you are telling me.
Because Cyclone, you're
Hey, dude, raspy dude who's hiding under the bed covers. That guy was asking his question. Let him finish.
no, bro. You're explaining a different thing because he's saying.
No, dude, we're gonna let this guy. This guy needs to go to bed. He's very tired. Let him ask his question and go to bed. Then you can continue to whatever you're doing.
Yeah, go on
Thank
now.
you. Okay, so you're telling me that that I'm seeing an illusion, like it's an illusion that the sun.
Well, it's a function of perspective. Like when you see things in the distance getting smaller as they go away from you, you could call that an illusion because they're not really getting smaller, but you just know that's a function of perspective, right?
But the sun is like,
if you see a plane flying away from you,
it's like, yeah, but I can see it go down, right? So
yeah, because things over a distance appear to compress towards the vanishing line, which is the horizon.
Because so you believe there's a horizon, right? There's
I
a
don't.
point where
It's not a belief; it's a phenomena that's observed.
So okay, so if there's a horizon, and after that point, things start going down. So where?
No. The horizon isn't the curve of a ball where the ground is going down. It's an optical limit. It's the limit of your optic. It's not a. It's not a curve. It's not a curve of the ground.
I can still use optical instruments and still see the same thing, right? So
you can see the horizon, yeah. Because every optic has a limit.
Using my eye or using a telescope.
Yes. It's an optical phenomenon that's apparent through any optic, right? But it's not curvature. It's optical. You understand?
No, but why can we go in one direction and then end up in the same place?
Is this another guy now? Who's talking? You guys need to keep it straight. I need to know if I'm talking to one person or two or three.
It's found, but please, before we jump into the next subject, like change the question. Let me just repeat Mahon's question. Mahon, did you forget your question or what? You said that it sinks. It doesn't go away, like go far away, that it meets with the horizon. It actually sinks. You can see half of it. And then you see quarter, and then like it literally sinks. So based on our observation, there is some curvature around this.
So why are you saying the sun sets?
Why do you call that an illusion when you call like seeing the Earth as flat?
Well, what's your explanation? Why is the sun setting?
Because
the only explanation is because of a curved Earth.
What does that look like? So the sun is moving downwards. The sun is moving downwards beneath the curvature. Is that what you're saying?
Yeah.
So that's not what they're saying, though.
I mean, the Earth is spinning, so it's the same thing.
Oh, so when you're seeing the sun going down, what are you actually saying is happening?
So yeah, when I'm saying it seems like the Earth is the sun is going down, but it's actually the Earth spinning.
So you're spinning backwards, you think?
Exactly.
Okay. Do you have any evidence for that?
Hey, you don't have to be spinning backwards. Maybe the sun is just...
Oh, you do. For the sun to go down, you would need to be tilting backwards.
Like the sun just could be behind you or to your...
So have you got any evidence that you're actually spinning backwards?
I don't have an evidence, but
obviously.
I mean,
you can observe the sun.
Well, you can observe the sun appearing to move downwards, but now you're saying it's not the sun moving downwards; it's you spinning backwards.
No.
So have you got any evidence for that?
If you watch both sunset and sunrise and sunset, you can see that it's spinning.
You can see, no, you see the sun moving. You're saying you're spinning backwards. So, you got any evidence for that?
You can feel it, like when you can feel it moving
What do you
backwards.
feel? What do you feel?
Like I feel gravity pulling me back.
You feel gravity pulling you back. What does that feel like?
Okay,
I'm just
so
joking.
I feel the earth move under my feet.
Okay, so far you've got a claim that you're spinning backwards, but no evidence for it.
yeah, we have no evidence, but for flat Earth to be
Well, just dismiss that then.
correct, then the sun has to get smaller and smaller and fade away.
Well, arguably,
That's
we
not the
do have
case.
some videos. I'm sure
That's not
folk
the
can post them
case.
in the chat.
I've
That
always,
the sun does
I mean-
decrease in angular size.
I mean, I like seeing the sun fade. So I see it always like setting down and not fading away.
Yeah, but what if that's just because where you live, the conditions make that the case, but if you were somewhere else, you would see something different.
Like where? Something different where?
Like, in some places, depending on the atmo conditions, the air conditions, you can see the sun appearing to get smaller as it moves away.
So, I'm not aware of those instances.
Well, if you look in the side chat, I'm sure people can post some GIFs or videos for you. But needless to say, you're not seeing the sun going down because you're on a big spinning ball and you're falling backwards. That's not happening.
Right. Sorry. They have been. We have been. People have been posting stuff.
Yeah, so there you go. Look in the side chat. Just because you haven't seen something doesn't necessarily mean it never occurs.
Bro, I've been to like 3 countries.
I only
and I
believe what I
have never
see,
seen
so-
that phenomenon.
Yeah.
Yeah, so 3 out of what? How many countries? 200 countries? That's not very many, dude.
How many locations? Like I've been to Europe, Africa, and Asia.
Okay. So?
I'm in the equator, so.
Now listen, it's in the chat. Folk have posted it in the chat. Just go and have a look.
Hey, Demon, the lady in the back already told you to shut up and go to sleep, so why don't you do that?
I hit a nerve with flat earther or what?
You're about to get slapped by someone in the back, so we don't want that to happen to you. So just mute up, and go to sleep. Because
Actually, I
everybody's
think it was the other guy who was going to go to sleep.
I'm not sleepy though.
Okay, emotional kid.
It was the other guy who was going to go to sleep. The guy who's hiding under his bed covers. He's in for the long haul. He's got his flashlight.
There's no one fighting under my bed covers. What are you talking
No,
about?
not you, the other guy who's like, okay, I can't have people hear me, but I'm arguing with the flat earthers at night.
What's up? Bro, I got flat earthers mad, bro.
He's
You
getting
see?
flat.
What's up, twin?
He's gonna get flat smacked by
Wait a
the
minute.
lady.
I remember you from somewhere.
They're just going to hit him with a slipper.
With the
Yo.
flip flop.
Holy shit! Didn't you build that children's hospital all by your bare hands, dude? That was crazy.
Yeah, bro, that's me, bro. You remember me, bro?
Yeah. Oh my god, bro! Thank you. You're such a hero, bro. Thank you.
Yo, bro.
You saved my brother's
Me
sister's
just the
brother's
moment you say,
nephew,
bro.
bro.
Bro, you're so welcome, man. Like,
All
I do
right.
this, like,
Have a
you know, I
have
just
a
want to help
family
people,
reunion
so...
somewhere else, guys.
Yeah, go to
Sorry.
MVC, ladies.
No, thank you. Here with the flat earthers.
So these guys think they're spinning.
Yo, please.
These guys
please,
think
please,
when they
please,
see a
please.
sunset that they're spinning backwards at 1,000 miles an hour. Has anyone got any evidence for that?
Please, guys, man. Please, bro, have a conversation with a fan, yeah? You can't disturb us, you know? So please, for 1 moment.
Yeah, put yourself on mute, dude.
Do you want an autograph, man?
So have you guys given up on the globe already? Is that a concession? Sounds like it. What's the best globe proof? Let's hear it.
All right. I'm back, guys. You miss me.
All right. What's your best globe proof?
Huh?
What's your best globe proof?
Globe proof?
Mm-hmm.
I don't know.
Oh, so why'd you believe it?
So.
But you believe you live on a big spinning ball?
I mean, yeah, kinda.
Why, if you don't have any evidence?
Well, low-key, all the other planets are balls, so...
How'd you know that?
Because NASA said so.
Oh, so the U.S. government told you so, so it must be true. Because they don't lie, do they?
Well, I mean, I wouldn't know. I'm not from the U.S.
So you wouldn't know. So the U.S. government must be telling the truth because you don't know.
I don't know, probably.
Probably. That sounds like a smart way to base your entire worldview on.
I don't know, bro. I've never been to space.
Yeah, so why would you believe their fairy tale Hollywood stories about it?
Because, like, I don't know.
Because you're lazy.
Is NASA run by the government? I thought it was a private organization.
Yeah, come on, dude. It's the U.S. It's part of the U.S. military,
from the
basically.
US. What do you expect?
You don't have to be from the U.S. to understand that NASA is a government organization.
I'm not from the U.S.
But like, why would they lie to us about that?
Yeah, why would the government lie, guys? The government doesn't lie.
Why, like, all the governments say that.
Governments don't lie, do they, guys?
No, they don't lie. I don't think they lie, man.
Has been.
Yeah, governments can't lie.
All the way
I
since,
think
like,
he uses topic to lie.
ancient times, though. With, like,
Yeah, well, why would they want to? Well, yeah, why would the government want to control your entire worldview and belief system? Why would they want to do that? It doesn't make sense.
Why do you believe the Earth is flat?
It's not a belief. I experience it every day. Go outside.
No, man. But
I am
like,
outside.
Okay, you'll notice that the ground isn't spinning at 1,000 miles an hour then.
Yeah, no shit. We're spinning with it.
Oh, are we? So it is spinning at 1,000 miles an hour.
Yeah, that's low-key how physics work.
Okay, so how do you know you're spinning at 1,000 miles an hour?
I don't know. Science said so.
Science said so. Is science a person? Who's that? Mr. Science.
I don't know. Scientists.
You talking about Bill Nye?
You just saw a cartoon on TV and believed
Bill
it.
Nye said so. He's the GOAT. He knows everything.
I don't know is a good answer.
Yeah, Bill Nye also
I believe
thinks.
what Bill Nye says.
Well, Bill Nye also says that men can get pregnant. So.
No, he doesn't. No, I haven't watched Bill Nye, so I wouldn't know anything about that.
So it's fair to say that you've got no idea what the Earth is. You just believe it's a ball because you were told so.
I mean, yeah, I wouldn't know because I've never been to space, but like.
Well, maybe you should use your brain and think about it.
No,
But you
I'm
can
thinking
see
that
the
it's a ball.
curvature when you're on a plane, bro.
Yo,
Yeah. So now you've realized that you think it's a ball, maybe you should try and find some evidence for that.
I don't want to. Playing Battlefield is low-key fun.
Okay, put yourself on mute then.
No, thank you.
No,
Stay lazy brain.
Bro, Erson,
No, thank you. Playing Silent Hill F is better.
That's okay. Well, we can do it.
Research.
We can do it for you.
Imagine doing research in the Big 25.
So,
Yeah.
Boo.
See, you revel in your own ignorance. Of course, you're a globe believer. A perfect demonstration. Doesn't know anything about the globe. Just believes it. Doesn't even want to challenge it. Doesn't even want to investigate it.
Cyclone.
I don't know. They taught us that in school, but I don't remember it.
Yeah, you've forgotten all the fairy tales that you're supposed to believe, but you still believe them.
I mean, yeah, Bill Nye said so. It's like science.
Yeah, the government and TV said so.
You know,
so it must be true.
Like Jesse Pinkman said, you know, yeah, Mr. White, yes, science.
Yeah, you're watching too much TV. That's why you're lost in reality. Yeah, that's why you don't understand reality.
I watch it on my PC.
Because you're stuck on TV. Yeah, you're a TV watcher.
I don't watch TV.
Yeah, your head is a TV.
PC on Netflix.
Oh,
my
whoa,
PC is not
okay. Must
My
be
PC
very
is not a
different
TV,
then.
but it's okay.
That's a highly intellectual difference.
television program.
I'm low-key smarter than you anyway.
You're a TV guy.
That's true, man. That's true. He's smarter than you.
Yeah.
Yeah, because
me
he
ask you something
blindly
then.
believes
What's 2 plus
government
1?
cartoons
What's 2 plus
and
1?
fairy tales.
Nah,
That's so
man.
smart.
What's 2
It's
plus
so
1?
smart. Why would the
I have a
government lie?
fact.
That's so smart.
No, I have a fact, guys. Why the Earth is round, you know? So, if the Earth was flat, why is
No, you're wrong start. You're starting wrong.
No, man. Why
You're starting
is
wrong.
Bro, let him speak, bro.
one side of the Earth night and the other side day? You know what I mean? It doesn't make sense.
Okay, prepare yourself. Prepare yourself. This is radical. The sun moves. Whoa. You notice that?
I have a question for the cyclone. Can I ask my question?
Is it about why the sun moves?
No, it's something else.
Have you guys, let me ask first, have you guys noticed that the sun moves?
I got you. I mean, no, in my opinion, the Earth moves and the sun, it still moves.
But when you go
not
outside,
around the Earth.
you see the sun moving, right?
No, but
Well,
the Earth is moving. He's
that's just
right.
the Earth
is moving. Yeah, it's true. It's true.
No, you're only observing the sun moving, though.
Okay, so can I ask my question now?
Well, once we get to the bottom of this, because you guys are saying you see
really quickly.
the
I'll
Earth moving,
finish
but
your
you don't.
Everybody.
You don't see the. You don't. Hold on. You don't see the Earth moving. You just see the sun moving, right?
I mean, I'm not in space, so I don't know.
Yeah, so you just see the sun moving from your perspective.
I mean, I guess.
Okay, so is it possible that the sun is moving?
Yeah, for all I know, I've never been to space, so.
Well, there you go. That's what's happening. The sun's moving, the Earth isn't. Pretty simple.
Okay, that's cool. Can I ask my question now?
Sure.
What's 2 plus 1?
Wow, that's what you had to get out.
Yeah, please answer it.
Is this a deflection from you realizing that the sun's moving?
No, please answer it, like, actually.
Just put yourself on mute, dude. If you're this upset, you can't discuss it.
No,
just put yourself on mute.
Actually, please, just please answer it, and I'll put myself on mute after.
Nah, we'll put you on mute if you don't want to put yourself on mute.
Yeah, we'll just put you on mute. That's fine.
Bro,
That's a concession.
That's my question.
That's a nice concession.
Fuck.
Simple. So who was the other guy
Me.
that doesn't understand? Okay, so you see the sun moving, yeah?
Yeah, like I see this. Yeah, for me, it looks like the sun is moving, but
Okay, so why you don't believe it's the sun moving? Is that right?
yeah, it doesn't make sense.
So when you see the sun moving, that doesn't make sense.
Yeah, because like in every book, in every school, you learn that the Earth is moving around the sun.
But when you go outside, you only have evidence for the sun moving.
Yeah, but it's like it's because of how is it called? Like
the sun moving.
It looks like the sun is moving, but the Earth is moving.
You know better. You know better.
Yeah, perspective.
So how do you know better that it's actually you moving? How did you figure that out?
Wait again. How do I know that the Earth is moving?
Yeah, when you see the sun moving, you say, no, it's not the sun moving, it's me moving. What makes you think that?
Because I'm gay.
Okay, another concession. See how school has just brainwashed you and you have no idea why you believe what you think you believe? That's not something to be proud of.
Let me say something to their age level. Low key, you guys are sus. Don't know what it means.
6, 7.
6, 7.
Yeah, that's a tap. So we can move on. The sun moving always trips them up, isn't that funny? Just blatant reality makes them spiral. Any other globe believers confused about the sun moving?
Well, what about found? Or were you talking to found?
No, you weren't.
Okay. Okay, your time to shine.
I guess. I mean, when I'm in a plane, I can see the curvature. Like people say that the Earth looks flat in the horizon, but I can see the curvature.
You think you see the curvature from a plane?
Yes.
Well, then you're not arguing for the globe model then, because the globe model says it's too big to see it from a plane. So I don't know what globe you're believing in, dude. Some tiny Rick and Morty planet.
No, look. There are people in the chat who said the Earth is like a plate. I don't believe in that.
No one here is saying it's like a plate. We're saying that there's no curvature, so it can't be a ball. There's no curvature, so it can't be a ball. It measures flat.
What is it then? Is it like cube or like what?
Well, flat, I don't know. Flat isn't a shape. Flat's a description of the surface. What shape is a lake?
So you mean it's like maybe like a ball that's been squeezed?
No, it can't be a ball because balls by necessity have a curved
you didn't
surface.
understand me right. It's like you mean it's not totally flat, but it's like a flat object.
Well, the land, the hills and the valleys, they're not flat, but the water's all flat. Yeah.
Wait,
the water that all the land's sticking out of.
What kind of form is the Earth then?
It's a motionless topographical plane.
A what? Can you repeat?
Motionless. Yeah, not moving.
Yeah.
Topographical. Hills and valleys.
What does topographical mean?
Like hills and valleys. Elevation difference from sea level.
Okay.
Yeah. Motionless topographical plane. So the general nature of the surface is that there's no curvature to it.
Are you guys actually debating about if the Earth is flat or not?
No, not a debate.
We're just explaining to him what we're saying, which is that there's no curvature.
Sure of that?
Yeah, of course.
How come that you're so sure of that?
Because that's how it's observed, measured, and practically used in reality. The surface, flat, motionless. You can't get much more sure than that. It's like, how are you sure that you're 5'11"? Well, because you measure it. You know your height.
Mm-hmm.
You do the same with the Earth. You measure it.
Yeah, that's right.
Because a ball has to have a curving surface, remember?
So
and they never measured that.
Like the measurements of the Earth don't make sense. Like
no, they never.
No, they make sense. They make sense, but they just measure flat, no curve, no ball. No ball's ever been measured. There's never been any curve measured.
So all
they tell you how big it is.
And all the.
Yeah, at school they tell you how big it is, right? The size of it. You can even Google it right now. But they don't. They've never measured it to be that size. They're just giving some numbers there, and you guys are just saying like, "Oh, the Earth is this big," and just believing it.
Yeah, it's just a fantasy story.
They lie to us. Like every government on the Earth is lying to their people.
No, because most of those governments they just believe it too.
Round.
It's just a belief, dude. Everyone's believing the same thing.
Okay. So the people don't know. That's what you said.
Yeah, most people are just like you. They just like heard the story and believed it.
Yeah, but why? Like, where's the other part of these people? Like, some people must know, in your opinion. So why are they trying to hide it?
Maybe they want to control. Maybe they want to control your worldview and how you think and how you believe.
But
maybe
let me just say something very clear. They're not trying to hide it because it's nature outside. You can't hide nature. You can go see a flat level horizon any day. They're not hiding that. You just believe that flat level horizon is actually a globe somehow.
Yeah, but why are they saying then that it's like round?
Because they believe it, just like you. They're doing the same thing you are.
Okay.
Well, they in effect they create this source of truth, quote unquote, in an organization like NASA, and so hold on. Let me finish this thought. No, hold on. I'm going to finish this thought, dude.
Please let me.
No, dude, I'm going to finish this thought. I'm going to finish this thought, dude. Pop yourself on mute for a second,
like the only
or you'll be put on mute.
But
no, dude.
What's happening?
I'm about to explain an important part of this. Right, so
Yeah,
they've created an organization which is beyond reproach. They've created an organization in NASA which, if it comes out with any story, you're going to believe it. And you do so because they've told you that you can't experience reality, only we can. We have access to what the Earth actually is, you don't. So if they tell you Uranus is raining diamonds and farting out gas into space, you'll just believe it because you believe anything they say. So the government's managed to create a source of truth.
I just, like, I believe that you don't know anything, so you can't be 100% sure of anything. There's like an equal chance that it's not. I think.
Nah, that's no use. That's no use. You do know some things.
It's like so.
You're on Discord.
Solipsism is not a good worldview to hold, brother.
Wait,
you can't just say
one
that.
second. You think the Earth is not explored totally?
No, I told you the Earth's surface has no curvature and so cannot be a ball, like they've told you.
Okay.
Try not to take the solipsist.
If you want to think it, it's fine.
Yeah, sir. Try not to take the solipsist worldview where you can't know anything, because that's going to undermine anything you can know. So
it's not, and it's not just what I think. That's how the Earth is observed, measured, and practically used. Flat, not curved. So you saying, oh, well, you can think that. Okay, well, if you think otherwise, show us some evidence.
I trust the scientists and these people more than...
You don't know, you're not trusting anyone. There's no... if I asked you who you're trusting, you couldn't tell me a single person. You're not trusting a person, you're just believing an idea. What scientist do you trust?
You don't know, right?
Which scientist proved the globe?
But it's like general knowledge.
You told yourself that you're appealing to some scientific truth, but in reality, you couldn't even name a single scientist that you think's proven this. You don't know.
It's just the idea.
It is just the concept, the idea that you're appealing to. So I would suggest you go and do some research, and then come back and follow up on what I told you. The Earth's surface has no curvature.
Is it even does it matter if the Earth is...
Yes, reality and the nature of it matter. That's why human beings have spent their entire existence pondering the question. So yes, it matters.
I mean, okay.
Yeah, we make some solid points, man. Just for you to think, just like when you leave here, just think about what we're saying. You don't have to oh, the Earth is flat, tomorrow. Just think about what we're saying. Yeah, a lot of people just believe that the Earth is a globe based on an idea. That's it.
I mean, okay, it's it's a solid thing. You can think about it.
You don't. It's not only that you can think about it; you can go outside and experience it, because that's what we're talking about. We're talking about what is experienced in reality.
The curvature when I was on a plane. That's why.
No, you didn't see any curvature. If you saw curvature, it would be measurable. So who's measured it?
Yeah, that's true.
What kind of measurable? I see when it's round.
Okay, so you see it's round, so give us a measurement of this curvature that supposedly exists.
And somebody should be able to come back down to the ground and measure it if you saw it up in the air. Somebody can measure it on the ground.
You just say, I didn't see it, right?
No, dude, he's saying...
because
then you can come back down to the ground and measure it, if it's truly what you saw.
But it's like a common thing.
Let's say, I'm not saying you're lying, I'm saying you're mistaken, right? So the windows on a plane are curved anyway. So maybe you saw it at a particular angle where the window curved the horizon. That's possible.
You see the curvature also when people are skydiving?
You don't. Well, if they're filming through a camera that curves the image, then you might, if they're using a GoPro, you can see that curve. It's not curvature of the Earth.
On the ground.
Yeah, that's the problem.
There is no curvature.
You're just saying that people see it. Yeah, listen, dude. You're just saying that people see it from wherever you are, skydiving, from an airplane window, from a space shuttle. It doesn't matter where you said you see it from. If it's true, that's a globe, you can come back down to the ground and measure it. That should be something you can do if you saw it, right? Or no?
Yeah, they're not seeing it, dude. It's just a camera. It's a lens effect.
Yeah, but
you have to ask.
Earth, it's like
you have to ask yourself that.
Small in comparison to the Earth that it appears to be flat.
No, bro.
Dude.
Yeah, you can't do that. Like if somebody saw curvature and they didn't measure it, that's a problem. They should be able to if it is curvy. Yeah.
What you need to do is you need to understand the curvature claim, because at the moment you're just thinking of curvature. You're not actually thinking what the numbers are. So take a 10-mile stretch, for example. That's a simple one. How much curvature do you think exists, A to B, according to the globe concept?
Like a 10-mile stretch.
Over 10 miles. 10-mile stretch, how much curvature in feet? Like a drop from A to B.
Feet. Bro, I don't know about feet. That's not the measurement.
Okay, centimeters.
Centimeters?
Whatever.
That's like a little measurement. Wait, let me think.
10 miles. 1 centimeter, 10 centimeters. Have a guess.
Like the... Okay.
The drop. The surface is supposed to be dropping down and away from you in all directions because you're on a ball. So over 10 miles, how much has the surface dropped due to curvature?
I mean...
Just have a guess. I don't expect school has taught you.
I think you would say none, but I think...
No, I said according to the globe idea, right?
Okay.
Because they tell you what size this ball is, so they tell you how much curvature there's supposed to be.
Okay, I would say... Bro, that's like so hard to guess. Bro, I can't guess.
Just have a
Can you
guess.
tell me what they think?
I'll tell you after you guess.
Bro, I don't know. Like,
what is it? Half a centimeter, a centimeter, an inch, 10 centimeters, 20? Just ballpark it.
I would say like little, like really little.
Like a millimeter?
No, not this. Maybe a centimeter.
A centimeter. Right. Okay. Well, actually, they say it's about 66 feet.
What is that in meters?
What, 22 meters, something like that?
Okay. And how do you...
So that's a lot more than 1 centimeter, isn't it? Well,
how do you prove them wrong?
Well, because I ask, who's ever measured 22 meters of curvature over 10 miles? And do you know what they say?
Tell me.
Nobody.
No one has.
Wait, but so they just claim that, and it's like not true.
Yeah, nobody's ever checked, dude. Who's checked it? Nobody's
Exactly.
checked.
But it's also
There's
like
nobody
that's it.
The Earth isn't.
Hold on. Just let me.
Like that,
I'm just going to leave you with that. Now they claim it's like this basically perfect ball. That's what they're showing cartoons of.
It's
so
not
that
perfect.
is what they're saying.
It's like, you know, 1 second.
That's what they're saying. No, hold on. That is what they're saying. That is basically what they're saying.
Let me ask a reply on that.
Because I'm just a way to head off. I'm just saying good night. But I'll leave you with that. Yeah, and you need to focus on what I just left. No. What I said was,
you're not avoiding this.
No one's measured the 22 meters, right?
Take only a minute.
Hold on, no one's measured the 22 meters of drop over 10 miles. Do you understand that?
If you don't want to tell me that, I will leave. But if
well, I'm leaving. I'm gonna go on listen mode, dude. I'm just saying bye, but I'm saying this is what you need to focus on. No one's measured that 22 meters over 10 miles
because it doesn't make sense.
Yes, exactly. The globe does not make sense.
It makes no sense because the Earth's surface is like not a perfect ball.
Good chat.
Like
okay, good chat. You think it's like a lumpy potato, even though they're showing you pictures of a perfect ball in space. Cool story. Okay, anyway, have a good night, guys. Enjoy. Miggy or someone.
Yeah,
pick this up.
man.
Okay, bye. If you don't want to get
good chat. It was a good chat, bro.
Everybody has to leave sometime. Like, geez, you can't stay here forever.
I mean, I see. It's a good point of conversation to leave, I guess.
Well, I mean, obviously, but anyway, yeah, nobody's ever measured that, so
because
we can rest
sense. Because like, let me like say that it makes no sense because there are like the Earth's surface is not as round like as a perfect shaped ball.
How do you know that? How do you know that, bro?
Because I see it.
From where? Where do you see it like that?
I see it from my perspective. I can even see that.
Yeah,
like,
I know, but what?
There's like mountains and little like differences in the height of the ground.
Brother. From your perspective, where were you standing where you saw it like that? Like it's not a perfect sphere.
Like on the ground, on the ground, like on the street. I can even see it on the street. Like why would it make sense to measure a point where a hill could be or something like that?
No. Because you're saying that land topography, like a hill, is the curvature of the Earth. No. What we're talking about is...
I didn't say that.
All right, so what are you saying?
I'm saying...
What are you saying that you saw the Earth?
Probably measure it, but you would have to have a Earth ball that is perfectly shaped. Like
no, that's not the point. Bro, that's not the point. The point we're getting to is that nobody not even in like the school that they told you that somebody's actually measured the surface. Nobody's ever done that.
Matter. It won't be like it won't even make sense to measure it because of the shape. Like
what? Dude,
so
then why
you're
are they
making it
telling us
even more difficult for yourself?
Yeah, then why are they telling us that it's a certain? Jesus,
it makes no sense.
It's hard enough to measure bumpy Earth, and you're going to say they can measure curvature on top of bumpy Earth?
It has to be like it has to do something with perspective.
What? No, bro. Like you're not. Okay.
That's the problem.
Right, oh my god. Listen.
Yeah,
bro,
they hijacked perspective and called it curve.
But it's fine.
No, I mean obviously, if you think it's perspective,
like I don't think it's wrong to doubt things. It's
no,
not wrong.
But it's wrong for you to say things that are not correct too, right? You can't say that and then just think everybody. Yeah, but your belief is not. Listen, so I'll tell you like this: if your belief had any merit, then it would stand, right? But you can't even
if
say
I could talk to you in my first language, like you would talk to me in English, I would probably be better at explaining it. But it's my perspective, so.
I mean, you could say it's your perspective, but it's not. That doesn't measure the surface to have like the curvature that you think exists.
But you
on
can't do that either,
on a lumpy
right?
Earth. It's not. Don't say that I can't do it either. It's not my claim. I'm not saying the Earth's a giant ball, sir. You think that it is.
You're saying
not
the
me.
Earth is flat, right?
Yeah, and so you think that there's curvature, and I'm saying that cannot be measured because all you notice is the Earth
looking. You can't measure that, and that,
brother,
because it's flat.
Yeah. So there's no curvature measured except for you.
And that's because I.
Yeah, where do you, brother? Where do you see the lumpy Earth? Where do you see lumpy Earth at, bro? Like honestly, like you're not making any
assumptions, and we don't really know it for sure, right?
Yeah. Do you see a lumpy lake?
Yeah, hold on, dude. I'm not making an assumption. You are.
What else?
You're the one making the assumption. I'm not. There's no assumption here. Yeah, you're assuming that there's lumpy Earth, and you're seeing lumpy Earth. You're not seeing lumpy Earth, dude. If you see anything that's lumpy, that's probably a
what
hill.
What does lumpy mean?
That means that the Earth is not perfectly a sphere. It's got a regular, like a regular shape. Like a ball.
Okay.
Hold on. Sorry, I know I said I was going, but just very quickly, I would like to suggest that he's, I think, confusing just general land elevation, confusing this 22 meters drop.
No,
so
I'm not.
what we're saying is you could do this over a lake.
But it makes no sense to measure.
You can do this over a lake, right? Yeah. So you don't have to worry about the hills and the valleys. Do it over a lake. And that lake is supposed to be level with the earth, right? So it would be following the curve. Yeah? So that water is supposed to be dropping 22 meters. Where's that been measured? Show us a curvy lake. That's the position.
So, over water, yeah.
But the lakes all measure flat, so people are going out and looking for this 22 meters, but they're finding that it doesn't exist, and there you go, flat earthers, because there's no curve.
Let me, one second. I have to research something.
Someone show him some examples. Just show him some laser tests, explain it to him. He sounds like he could understand it.
Yeah.
And don't worry about the language. Your English is pretty decent. And if you don't understand something, just ask us to explain it or simplify the language. We're happy to do that. But anyway, have a good night, guys.
Let's see it, man. I want them to give the old college try, because it's always good for them to actually put their best efforts if they're thinking that they have an answer, because if we shut them down and just give them what flat Earth is, and they're going to be left with, I can prove it, but all this other stuff. So they got to do their best, or at least attempt to. Anyway, I mean, But currently, I think he's just going to go look for something. I'm going to actually be leaving here.
I'm just searching for because of my language,
It's like it's not a perfect sphere.
I mean, okay. It's hard to it's probably not measured when you see it on the river. You mean the river, right?
No, I mean any large body of water. There's no convexity over that large body. Yeah, any large body, sorry.
If you're on the ocean with a boat, and then there's another boat in front of you, but way farther. You can only see the upper part of the boat because of the curvature. Why is
That's
that?
incorrect. That's incorrect.
No, it's
your
not.
statement is, yeah, it is. Have you ever made this observation yourself?
Yes.
Okay, how many times have you made this observation?
I think 3 times, because I was on 3 times I was on a cruise, and I see that.
When you saw the ship disappear from the bottom up?
Yeah. No, I was looking with what is it called? These glasses, you know?
Okay. What distance away from you were to the ship?
A large distance.
How far away were you?
I
And
mean, how could I
mind you,
measure?
mind you,
No, I don't know.
mind you, it's important. Well, it's important because if you're seeing the ship move away from you and it's going a distance away, we're going to want to know what the distance is to that ship, because if it's farther than the predicted amount of Earth curvature,
many kilometers.
What? Many kilometers is not an actual numeric value, sir. And it's important. It's specifically important. Like I said,
American measurement or what?
No, just like a distance away. You could meters
I would say 50 kilometers or something or more.
50 kilometers?
Or even more. I think I don't have a good I can't guess I don't really know the distance from an ocean.
Well, the hard thing about what you're saying. Well, the hard thing that you're saying right now is that nobody can actually put to the test.
But one thing, why could I see the ship from?
Bro,
up,
you're not listening to me. You're jumping on what I'm saying. You're not listening. Just hear what I'm saying, okay?
Okay, I will.
The important thing about the distance is if you tell us that it's really close or far away, specifically what distance, then we can know if it's what you're saying could be validated, that you're saying, hey, I'm making a case for the Earth being a globe, so that the distance away is going to be this specific distance, and then the curvature should be appearing because I'm really far away. So that's the curve. So then we could talk about it. But if you don't give us any information, we don't know if you're a mile away. We couldn't tell. But if you're saying it's really far away and you don't give us a numeric value like distance, that makes it difficult for us.
Numerical value.
No, numerical, like numbers. You can't just say something like it's far away or it's close. That's not something specific. But if you say it's 10 meters away or it's 1,000 meters away, that's something specific. You're giving a number value to how far away it is.
Well, I think it's maybe even 20 kilometers or something.
Okay. Well, at least that's something to work with. I mean, it sounds like you really don't know, but then it's going to be difficult because if we're saying there's a specific amount of Earth curvature that should be present, and then we got to find out how high off the ground.
Isn't this a common thing? It doesn't does this not contradict your statement that the Earth on an ocean or in a river that you can see the curvature, when you see only the upper part of the ship?
No.
Why not?
Because it's an optical phenomenon that occurs that can cause that. And also, it could be the angle that...
What causes that?
Bro, you're not allowing me to finish, bro. You have to stop talking when I'm talking, brother.
Oh, you
have to at least let me...
make this further.
Dude, you go ahead. Finish what you're saying, because obviously I can't finish what I'm saying.
Okay, tell me now.
No, you finish what you... Because I don't want you to interrupt me. Go. Okay. Tell me what you're going to say.
Okay, then I will finish it. What does that cause besides the Earth curvature? You must know if you say it's not that.
What does that cause? What do you mean?
Yeah, what does
it's hard. Can anybody understand what he's trying to ask? What does that cause? What causes it? Is that what you're saying?
The optical illusion is caused by besides the Earth curvature, and you're saying it's not the Earth curvature.
Yeah, there's optical phenomena like mirages that occur over distance. So there's a lot of effects that occur, and including the distance you are from the ground. So what angle you're viewing?
Explain them.
Brother, I am in the middle of telling you. Why do you keep interrupting me? Stop doing that.
You paused.
I paused so that I can it's called taking a breath, bro. Can I do that?
Yeah, you can do that.
All
I
right.
just asked a quick question.
Oh my God! Just keep going, dude. Somebody else take it. I can't deal with this guy.
I tried.
You may never. Yeah, no, I tried.
I mean,
Hey,
it's fine.
buddy.
I don't
Buddy, you
blame
have
you
you
for.
have to control the diarrhea of the mouth, bro. You can't just be doing that to people. Come on.
Are you talking to me?
Yes, talking to you.
I
Because you know,
was.
there's other people
I
listening.
wasn't
There's
like
other
under.
people
Like I wasn't
listening. There's
even
other people.
interrupting him
There's
back.
other people listening, and you are interrupting other people. So that's not how communication works. You have to
Well, okay,
wait
I
for
will not
someone.
speak
No, you
for
have
the
to
next.
wait for someone to finish what they're saying. Then you reply. You don't do it in the middle of their sentences.
Fine.
That's how
Then you can
communication
speak
works.
now.
You know this, right?
Now you interrupted me.
The guy interrupting say he's being interrupted, huh?
It's fine. Like I don't
No, it's
take
not
that
fine.
bad. But he can speak now if he wants. I think
Nah,
he
he
heard
doesn't
my
want to
question.
talk to you. He doesn't want to talk to you because he knows now that he's gonna be interrupted.
He won't.
When someone is in the middle of their sentence, that's not a
I
cue for you
know
to
that.
start
I know
speaking.
that.
No, you don't know that.
Okay. Then well, you don't talk to me, right? That's
No,
fine.
no. If you just gonna behave like that, we don't want to talk to you. Whenever you learn and you know that you cannot be speaking in the middle of someone else's sentences, then we might be able to speak to you. But before that, once you learn that, then you
You
might
don't
be
need
able to have a
to tell me
conversation.
that. I already know that.
But he told you like 5 times and you still don't get it. I don't
But he
believe you
interrupted
get
me
it yet.
too.
I don't believe you get it. I don't believe it
Okay,
until
then.
you demonstrate it.
Okay. Okay. I mean, it's quiet now. You can talk if you want.
Okay, so you believe that's the only reason that a boat is going away from your view, it has to be because of the curvature of the earth. There's no other reason.
Can I talk now?
You just did. Can I
Okay.
talk now?
Wait, you are asking me a question, right? Shouldn't I answer?
I mean, if you want to, you don't have to.
Yeah. I mean, it seems to be the most reasonable solution.
How many of the other reasonable, less you said that's the most reasonable, what are the other ones that you discarded and checked out and said this one is not reasonable, this one is less reasonable, this one is less than the other one, and this one is the final lesser of all of them, and then you came to the most reasonable, the curvature? How many did you checked, how many variables did you check and discarded before coming to the conclusion that it has to be the curvature of the earth?
So, it's like it's reasonable because I can compare it to different scenarios. When I would be on a mountain,
How many variables did you check? Tell me the other variables.
Bro, you are like criticizing me.
The variables. Give me a list
I'm
of
not
how many
speaking
you
to
checked.
you interrupting me after you're like making a big thing out of this.
So are you gonna answer my question or no?
Nah, I'm not talking to you now.
Okay, so you're not gonna answer
I mean,
my question. All right.
if you would learn to not interrupt people, maybe then.
Are you gonna have a follow up? Are you gonna answer a question or no?
Yeah, it's like you guys are having two separate conversations. The audience is getting a little frustrated. Not your fault, Jamesy.
It might be a language barrier.
No, I don't even think so. Bro, okay. If you're on the mountain and you are on the peak of the mountain and you go down a little bit and the other person is going like down also a little bit, but on the other side, then you would only see the upper part of the person, right? And it's the same with the ocean. When you see the upper part of the ship, That's why I think that this is the solution. And I don't really compare much with it because it's a thing that makes sense.
Joder, you want to reply?
I mean, I'm not sure what you're getting at here. Are you saying that the two people walk away from each other and the mountain
the mountain stays where it is, and the people just see the mountain getting smaller relative to how far they are from the mountain. I'm really trying to struggle to figure out what you're saying.
No, I'm saying that there's two people on a peak of a mountain, and then they go in different directions and go down the mountain until they only see the upper part of the other person because of the curvature. And it's the same with the water when you see another ship in the distance.
Yeah, I've never seen that.
Okay, then you never be like on the ocean and see that.
No, I used to live in Hawaii across the street from the beach. We used to watch ships sail out of Pearl Harbor every day.
Okay, maybe you didn't see them like far enough. But
I mean, I saw them very far away.
Okay, then we have different experiences. It's fine.
Yeah, and I've never seen anybody show me ships going over the curvature of the Earth in any video or picture or anything otherwise.
Okay, then look it up, search it. You will find enough pictures of it.
I have, and I know what I'm seeing, and I know in all cases, it absolutely is not presenting me globe curvature.
Why not?
Well, first off, people don't present anything that seems to be causing globe curvature where the globe should be curving. What people do present are things like waves and shoaling and miraging effects of boats as they're getting squished and stretched in the distance. I've never seen globe curvature.
I feel like this is more a thing of you don't want to believe it.
No, I've been searching for globe curvature for about 5 years now. Can't find it.
So what did you find?
That nobody is able to demonstrate globe curvature. And
but I just did.
All evidence is on the contrary. Everything looks flat. It's crazy, but it's true.
Yeah, it's because of perspective.
Yeah, it's not curvature. There's perspective.
Yeah, it appears flat because it's like such a big thing.
So your evidence for the globe is how flat it looks?
Nah. My evidence of the globe is what I said earlier, that I can see the curvature if I'm high enough. And I can also see satellite pictures, which I believe are true. I mean, I don't blame you if you don't believe they are true. And I can see things from upper perspective when I'm in the ocean, like ships.
I've seen satellite images of a flat horizon. I've seen images from CloudSat. CloudSat is or was a constellation of weather satellites. They have sideways looking cameras, not looking straight down at Earth only, but also looking out the side at the horizon. And they show a flat horizon, 1,120 kilometers, flat Earth. It's beautiful.
But who
and it's in infrared.
Who published them? Like who?
Organization in the United States called NOAA, NOAA, the National Oceanographic
believe that the Earth
Aeronautic Administration.
Oh, they are government stuff.
Yeah, and it's a joint program between NASA and NOAA.
So they posted something where you see the Earth is flat.
Oh yeah, absolutely. I mean, that guy you were talking to earlier, his name's Jemsy. He's got a ton of information about this. It's really great.
Did he also bring you into this?
Into flat Earth? No.
But okay.
I found out it was flat myself.
I see.
Yeah, I mean, anytime you think you have evidence for a globe, it becomes obvious really quickly that it's not.
I mean, I wouldn't say that. I would say it's pretty obvious that it is. But
well, can you find a particular case?
We want to have different beliefs. It seems like
no. I mean, it's true.
What makes it true? Like, you don't even have a proof. I mean, I don't have much proof either, but I would say I have much better proof than you.
I don't think so. We got a server with terabytes of evidence.
Yeah, but we have like
Discord.gg/flat earth
evidence against it, probably.
Well, that's a funny thing. What you think is evidence against is actually evidence for. Most of our evidence for flat earth seems to come from official sources.
Okay. I think it's like it's a perspective thing, but it's fine. I'm just like, I will stay here and listen to you a little bit more.
Yeah, that's fine. I mean, we're not going anywhere. We're here 24/7.
Yeah,
we've
I believe
got
that.
people all over the world, and we've got the best laser tests on Earth.
Cool.
One of the best places to do a test for curvature is over water, over frozen water, or over a salt lake or a salt bed that has been recently rained upon, so it produces a mirror, a flush mirror image of the sky. Not once has curvature ever been measured over such things. We got flat earthers that take infrared cameras on airplanes and zoom in on the horizon. No globe there. What does the globe side present? Well, they present surveys of the Earth. They present surveys where they survey the Earth flat, and then they pick a globe model, and then they contort their flat Earth measurements to fit the model, and they call that a globe measurement. This happens all the time. There's a whole field dedicated to this called geodesy, Geodesy. Geodesy. It's when you measure Earth flat, and then you mangle your measurements with calculations on a fake globe model ball. It's the most insane thing. Not a single surveyor in this entire field of geodesy is able to measure the Earth directly as a sphere. They have to mathematically contort it to fit a globe model. And they've got hundreds and hundreds of different models of the globe. And they're not all the same, which means they aren't fully compatible with each other, which means nobody has a true map or a true concept of what the globe is or what it even ought to be. You know, within about a year or so of looking into this, I decided that I needed to look at what the surveyors are doing, the people who claim to actually measure the Earth for a living. And it was quite a frustrating endeavor. Nobody's actually measured curvature in accordance with the radius of the globe. They take models of the globe and they bend their measurements to it. It's almost like taking a texture map in a 3D program and wrapping it around a ball. And this is what they do over and over again, and everybody's fine with it. Everybody pretends that they're measuring the globe, and they're not. It's crazy. Like, what the hell is wrong with everybody? It's funny because they don't exactly tell it like that, but that's exactly what they do. It's the process they describe. They think that the globe model that they select in order to contort their measurements onto that globe model itself has arisen iteratively after many, many measurements over many years, this, that, and the other. It's just not true. Ultimately, their globe models come from measuring angles to stars in the sky at night. That's right. That's how they created the globe. If they could demonstrate that they were measuring the globe itself, then they wouldn't need what's called a reference ellipsoid to make it work. So this invites a lot of questions like, well, does that mean that they're purposefully mangling the true distances and even the orientation of things? The answer is yes. Yes, they are actually. I mean, does this mean that our flat Earth laser tests are debunking globe Earth distances between continents? Why, yes, absolutely. You see, when you use latitude and longitude on a globe, you're calculating distances on a map. You're not measuring distances when you look at two places. Like if you say New York is at this latitude and longitude, and Los Angeles is at that latitude and longitude, you can calculate the distance between the two, but that doesn't mean it lines up in reality that way. When they claim that there is a relationship where 1 degree of angular displacement of a star in the sky on a great circle route happens when you travel 69 miles or 60 nautical miles over the surface of the Earth, that has never been measured. That's a calculation. Sure, they can measure the angle. Fine, I'm not disputing that they can measure angles. But it's the angle distance relationship that has never been substantiated via measurement. Has anybody proven that? I've never seen anything but an extrapolation within an unspecified margin of error to substantiate the 69-to-1 rule. I've only seen extrapolations. I've seen people measure arc seconds or arc minutes of degree in the sky and then extrapolate that out to a full degree. But nope, never an actual measurement. So this means, I mean, does that relationship hold everywhere on the globe? And the answer is no. Like even with globe Earth geometry and mathematics and surveying, astrogeodetic surveying, the 69-to-1 rule is a rule of thumb. It doesn't even hold true in the globe paradigm everywhere consistently around the world. Why is that? Well, they've got a lumpy geoid. They pretend that Earth has this potato shape of a gravity field, and this screws up everybody's ability to get plumb measurements that are parallel to each other, or radial out from a common center, I should say. And this will have an effect on your distance calculations. That's one issue. You know, and they figure this out when they try to establish the 69-to-1 rule, and they go to look at a star to see where it should be, and it's not. They're like, oh crap, okay, it must be Earth's gravity field bending the starlight. That's what the geoid does. So they make all these ad hoc patch corrections here and there, salvage some kind of semblance of a working model. But yeah, I mean, I don't accept a 69-to-1 relationship at all. I mean, beyond just a map distance, calculated map distance. That's all that is. Measuring angles to stars is another challenge because within all the manuals, they tell you for practical purposes, you don't want to take angles above like 60 degrees of elevation. If you're looking straight overhead, you're going to have a problem. And you don't want to use the very narrow, low angles to the horizon due to what they claim is astronomical refraction or terrestrial refraction even. And so you got to use the meaty middle of your field of view, somewhere down below from directly overhead and somewhere above from directly in front of you. That's where the stars are that you want to take elevation angles to. But the assumption is that every star you're taking an elevation angle to has a GP that corresponds, and you can work that out with the geometry. And yeah, you probably can work it out geometrically, conceptually. But if you're not really taking 90-degree zenith angles to these stars because it's impractical for many reasons. And, what are the chances of you being directly underneath a star perfectly 90 degrees? And then for how long does that last? These things are always moving in the sky. I mean, is it possible that you could even claim that, or counterclaim that, that nobody's been able to establish a 90-degree zenith angle to any star at any time in human history? It's just assume that that's the case. Especially Polaris. I mean, has anybody stood underneath Polaris? I mean, what, from a dinghy in the Arctic waters? Yeah, good luck doing that. But, I mean, this is what our maps are all based off of, latitude and longitude. This is how the globe was constructed. Just got one belief after another and a lot of geometry and ad hoc explanations. Meanwhile, flat earthers take lasers out and infrared optics out, and we observe and measure Earth flat every time. Crazy world. Suppose that you thought you lived on a globe, right? Let's say you're looking northward. You see Polaris, right, in the Big Dipper, and that's beautiful right in front of you. Suppose, I don't know, then you're at a particular location, 45 degrees north latitude. All right, so you're looking directly north. You're at 45 degrees north latitude. So Polaris is assumed to be about, 45 degrees up in elevation in the sky. Let's say from there you look directly west. You turn 90 degrees west. And then you look straight up to get an elevation to a star. That star is in the south. I hate to tell you, Globers. Think you got this figured out? Yeah, it's pretty funny, I think, because you're facing 90 degrees west. But you got to remember, at 45 degrees north latitude, that's a circle. So really, when you go to look due west, that line of latitude is curving to the right off into the distance and bending down. So if you take an elevation while looking 90 degrees to the west, and you look 45 degrees north and grab a star there, that thing is way over the south somewhere. And it's also not going to be moving at 15 degrees per hour in your field of view. So how do you know where you are? How do you know that you're going to be following a great circle route, especially when all these stars are moving? How do you actually stay on your 45-degree north latitude and travel along that? How do you use stars to do that? Because that's not a great circle route. Does anybody really have an appreciation for how difficult this is?
So hang on. So 1 minute, right? My diagram is a diagram. That's not relevant when it's of observations. But now you're saying it's in the literature. Right? Have you ever watched a surveyor doing their work?
Dude, my friend, when he was 17-year-old and still in high school, surveyed.
Oh, goodness.
If you're putting them up on some fucking pedestal, good luck to you, because any freaking monkey can do that shit.
Was that the question I asked?
Yes, I have.
So you've seen what they do when they get over is it GOP or something, when they get over that marked position that's being put there, so they know exactly where the theodolite is being put.
You mean the control point?
Is that what it's called?
Geodetic control point?
Sure. Yep.
It's weird. You're in Australia. You guys use a completely different datum. In fact, one of the major guys that talks about deflection of the vertical and curvature of the plumb line is from Australia. His name is Featherstone. Publishes all the time.
Sure.
About this problem. It's called use and abuse of deflection of the vertical.
So
the reciprocal zenith angle thing is a deflection of the vertical created by a curved plumb, created by what you would call lumpy gravity.
Sorry, what?
So hold on a second. I'm going to post curved plumb lines in the chat. Oh, there it is. So this diagram is straight out of the geodetic surveying. This is deflection of the vertical. This dashed line is the plumb line, the direction of gravity. But the problem is you got this reference ellipsoid. It has to intersect the reference ellipsoid at 90 degrees or you're going to get distortions. So they have to curve the plumb line. So that means horizontal, right, is not parallel to the surface of the earth, and vertical, the direction of gravity, is not perpendicular to the surface of the earth in geodetic surveying. So things like reciprocal zenith angles don't mean anything, would only mean something if you had a 90 degrees from the surface of the earth, which geodetic surveying disavows.
I'll have to take your word for that. I don't know enough about surveying.
Yeah, well, okay. A lot of people don't. It's a complex issue. That's why it's a complex issue. It just is. Coordinates, maps, all that shit, they're complex issues.
Okay, so maps and stuff maybe not so complex. I'm just looking at that. That's really interesting stuff. I didn't know about this deflection of and the bent plumb line. Good information. I'll definitely go and have a look into that. I'm talking more about when somebody puts a theodolite up and they set it at exactly vertical, and in the distance they should be pointing at whatever like if their theodolite's at 5 foot, they should be looking at the distance 5 foot away. Yeah, in the distance. To say 5 miles away, should be 5 foot away, and it's not. There's drop, and the drop, it calculates exactly to the curvature of the Earth. They move their point to there.
That's not true.
It is completely true.
No, it's not true at all.
It is completely true.
Okay, then there would be no such thing as measurement error.
Oh, there's refraction. There's refraction, and
every measurement would freaking matching.
You can't be spot on with refraction, right? You can make an estimate of
refraction. Is it curve or refraction? Which one is it?
Well, there's both. Do they have to be exclusive? Can you only have one?
Well, first thing, I already demonstrated that the plumb. So the first thing you do when you get a theodolite is you level the instrument. But leveling it means getting the plumb right. You're getting the vertical. That vertical is not perpendicular to the surface of the Earth in the first instance.
How so? How is that not perpendicular?
Because there's lumpy gravity. They say that the gravity is lumpy.
Not to that extent where you're setting up where you've got a thing that's got that has two axes of level. And you make it level, like it's got a front and back level and a left and right level. You make them both level. It's perpendicular to the surface of the Earth.
Not according to geodetic surveying. They have something called the geoid. Have you heard of the geoid?
Yeah, I know that gravity isn't exactly perfect all over the planet, but do you really think that's enough to cause?
Yes.
It
is
8 inches per mile square every time.
Yeah,
It's just
nobody measures 8 inches per mile squared.
I know they don't. I was using a flat Earth term. 1 degree per.
Yeah, nobody measures that though.
1 degree per 69 miles, whatever you want to, however you want to see it. That's what we see all the time, repeatedly. Okay.
You're just saying that, dude.
No, it's not.
That's not true, even remotely. If that was true, trigonometric leapfrog surveying wouldn't work, but it does.
What wouldn't work?
It's called trigonometric heighting.
Yep.
Also known as leapfrog surveying.
Yep, I can gather what that is.
That wouldn't work at all.
Why wouldn't that work?
Because you're just sighting in at 6 feet and just leapfrogging over and over and over again. You couldn't maintain that line.
Couldn't maintain what line?
The 6 foot line above the surface of the Earth, because the surface of the Earth would be curving down.
Right, and are you claiming that they do go in a straight line? They don't.
Yeah. I'm not claiming it. I wish Apocryphon, I'd pull him up if he was here. He does this for a living.
Sure, I'd really like to see that data because somebody's confusing something somewhere.
Leapfrog surveying is well known. It's called trigonometric heighting. Okay. Look, the idea that things don't get compressed down because of the meteorological conditions is silly. Okay. They don't sight in exactly where you said they do. And even you said there's refraction. We know things get compressed in the distance visually. We know this because there's something called the flattening of the sun. Okay, the sun gets compressed at the horizon, right? Swishes. Why is that?
No, I've never seen.
Right. I actually took some video last week. I got a windmill, so the windmill is cut off where you can't even see the hub of the windmill. I took a photo or a video 40 minutes later, and I can see the windmill clear as day completely.
Right.
Yeah. The point is that if you saw it, you'd go, hey man, I can't see that windmill because it's behind the curve of the Earth. But if you would have looked 40 minutes later, suddenly the Earth would have uncurved.
We've been over these kinds of topics 100 times, so refraction has lifted it up.
Okay, why would you say refraction lifted it up?
Because that's how refraction works.
It is.
That's right.
And you know this how?
Through experimentation.
Okay. What experimentation?
Of demonstrating refraction in science class and seeing a bazillion videos of it.
Yeah, but that's not terrestrial refraction, okay? That's different. The air is a single medium, right? And the changes in the refractive index of air is in the 5th decimal place. So it isn't like air to glass or air to water. That's like 0.30. We're talking like 0.1 million, dude. When I say in the 5th decimal place, so refraction is caused by 2 refracting mediums, and they have a different refractive index, and then it gets displaced when it transitions from one to the other. And the ratio of the difference of the refractive index determines how much it gets displaced. In air, if you change the temperature like 1 degree, it'll be, let's say, 1.00000.27 versus 1.0000029. Okay, right. It's infinitesimal. It's an infinitesimal difference.
But it's not. Temperature affects the medium, but it's the medium that affects the refraction. So temperature isn't solely.
Yeah, I understand. Yeah, I understand. I understand. Okay, what you've heard and what you've been told. The fact is, there's no evidence for it, and in fact, all the empirical data taken to quantify this terrestrial refraction is against the claim that shit bends around the curve, that light bends around the curve and gets lifted up. You know, there actually is people that have tested this out there in the academia.
Right.
And I'll give you a specific one, right? So one, they did LiDAR measurements of a landslide done over a 24-hour period, and they measured the max deflection. They measured the deflection of the light as it arrived as an angle. So the highest deflections they measured during this 24-hour period was 0.0027 degrees. So at a 25 miles, that would be a displacement equal to 8 feet. You guys claim shit is lifted up miles and hundreds of feet.
Yeah.
Yeah, there's no basis for that. None.
There is plenty of basis for it. I mean, you've seen it yourself. What's that footage of that lake with the shore shifting up and down? That's way more than the percentage you just quoted. You guys,
hundreds of feet.
You guys show that because it's over a relatively short distance.
Are you talking about Skunk Bay? Is that one?
Yeah, that sounds familiar. That might be it.
Yeah, but that's obviously that's caused by turbulence. That's obviously very turbulent meteorological effects, and that's rare. That's obviously not observed all the time. And that's a different thing. Watching the horizon shift is different than picking up from behind something. It's a little bit different, right?
So yeah. So.
And have you ever considered that there's
what do you mean it's very turbulent?
Effects?
I'm watching a really plain lake. There isn't even white caps on the turbulence on the lake.
No, it's called there's something called turbulence, right? Like when you see like a hot road and the heat is making it shimmer, and that's turbulence. When you see a star twinkle, that's turbulence.
So I'm watching the shoreline lift up.
Scintillation, technically.
I'm watching the shoreline lift up. What would be the equivalent of 20 or 30 meters? This shoreline, it covers the entire peninsula at some points. So the refraction covers the entire peninsula at some points. Man, that's huge. That is massive refraction. Like, what is this? What is the distance?
It's the Skunk Bay.
It's huge. That is a massive amount of refraction over such a short distance. I googled Skunk Bay refraction.
Yeah. I got my own, dude. Hold on. Did you post it in there? Because I'm gonna post one.
Oh no,
I'm gonna post.
Sure.
I'll do it.
Cool.
I got it.
Cool.
I got it ready. There we answered the hell we're talking about. That is not moving 20 meters. That land isn't even 20, 60 feet tall. Across Skunk Bay. That land is like 30 feet tall, maybe. Maybe it moves 10 meters. I'll give you that. But that's nothing.
Over that distance. So what did you say was in the millionths of...
No, the difference in the refraction index of 1 degree temperature. This is probably a 20-degree temperature difference between the water's probably super cool and the air is probably very warm, or vice versa.
So, but it can happen.
Yeah, but you would see this moving up and down. This is obviously something's going on here. It's obvious.
Yeah, refraction's happening. That's what's going on.
You can see an inferior mirage. Right.
Whatever if you want to use names to try and obfuscate what's going on, that's fine. But
no, an inferior mirage is a double image, right? You can see an inferior mirage. I can clearly see it. It's not obfuscating. Okay? And there's other effects that we would see if terrestrial refraction was happening the way they said it is, especially for distances of hundreds of miles. So like Canigou, right? Some of the images of Canigou is 412 kilometers. Okay? It's a 10-hour drive. Right. Think about something that's 412 kilometers from you and seeing it through a camera. Okay? So over that long distance, there's other, if there was refraction lifting it up, you should see other things, namely something called chromatic aberration. That's how a rainbow, that's how a prism works, right? Separates the colors of light. You had a lot of refraction happen picking it up, especially that long ass optical path of 400 kilometers. You would see red on top and blue on the bottom. This does happen in astronomy, and you actually make correctors for this for your telescope called astronomical dispersion correctors. But we don't ever see this with land, ever. I mean, we just don't. And even in fact, there's one where the dude used an apochromatic telescope. And the apochromatic telescope, it's designed so that this dispersion where you see the color banding doesn't happen, and he doesn't see it at all. So if it would happen, it would have to happen in the environment. Someone could always say it happened at the telescope, but he used the apochromatic telescope and it still didn't happen. So
I just posted 3 images there.
Okay.
I don't know. I'm looking at the sort of the white, looks like a Lego block building in the middle of it. If that's a normal building, I mean, to me that looks like a several-story building. I don't know what's there in that town. So, and then the second picture, even more so. Yeah, they look like multi-story buildings. Me, I could be wrong, but to me they look like multi-story buildings. And then the last picture, they're all gone.
Do you think you're behind the horizon? They're just compressed.
Yeah, I know.
All that visual information is squished. Yeah, it's just squished.
It's refraction lifting up the ground.
Which part is refraction lifting up the ground? The horizon is behind this.
Yeah, so it's lifting up the ground in between it. It's lifting up like the ocean. That's what it looks like to me. I can see, I've noticed like, the mountains in the background don't seem to move very much at all. But it's not a very high observable either. So
well, all I see, from what I see, all I see is the image getting compressed and stretched like there's an inferior mirage in between here and there, in between the camera and there.
But it's not happening.
It's not unusual. Inferior mirages aren't unusual. They happen all the time. All you need is like a 10-degree temperature difference. But that's way different than lifting something up miles, especially if you're at elevated height, right? So the Canigou shots are from 9,000 feet. They're from the French Pyrenees to the French Alps, 9,000 feet to 13,000 feet.
And how big is the mountain that you're looking at? I don't know this photograph that you're talking about. We talk about peak.
Yeah, they're 13,000 feet. Yeah, they're 13,000 feet. So they're looking for the French Pyrenees, which is like on the Spanish border, across what's called the Gulf of Lyon, which is like where Marseille and all that shit is in France, to the French Alps, which are all the way on the other side.
You know, my question was, when you look at the photograph, how big does the mountain look? Can you just see a little bit of it?
Oh, they're tiny. They're far away, dude. They took one to like 400 fucking millimeter telescope, 800 millimeter telescope.
Right, so they're
far away.
Yeah, so you know they're on the ground, so to speak.
They're as far away as the ISS would be. Let's put it that way.
So is what you're seeing not passing through ground level refraction?
No, they're on top of a mountain.
Yeah, but you're
9,000 feet.
Yeah, let me see if I can find this picture so I can show you.
Oh, yeah. There's one of them. This next one, taken with an apochromatic telescope. Dead. Okay. Ain't that freaking bad? God damn it. Okay, they don't.
I cannot.
So, yeah, so the important thing to notice is that from this position, the horizon should be 127 miles from the camera. That is in the ocean.
Right. So which picture am I looking at, man? Oh, sorry. Okay, so this is
either one of them.
Is it? Rightio.
Yeah, two of them. Well, I mean, one is in the same area. It's from a different mountains called Peak. What the hell's the name?
Badekrenz.
Yeah.
I'm not really familiar with this photo, so I'm familiar with Peak Gaspard, though. Do you know that photograph?
One is Peak Finestral in the Pyrenees, which is, and the other one to Peak Gaspard, and the other one's Canigou to the other one. I don't know what the fuck the name of that is. So this is a mountain, the Peak Finestral is a mountain behind the Canigou Mountain. It's further away.
Right.
So I was able to get the weather conditions from when these pictures are possible. And it turns out that low humidity, high pressure, that's all it takes. So the humidity is down like 30%, and the pressure is super high. So you got a high pressure system and low humidity. So there's a bunch of these. There's some taken in infrared. So the point is that, like, the thing to remember, like I said, the horizon is supposed to end in the water. Like, there should be, like, a well-defined water horizon and, like, some mountains sticking up from behind it. You can obviously see lights all the way on the other side, on the shore, which should be under the horizon, because the shore is something like 140 miles away.
Sure. So I'll just put in the pill, something that I have looked into a lot, because I don't know the
Okay.
mountain.
I'll check it.
One.
Really, the first time you've seen that? It's pretty classic.
Yeah, no, I've heard him.
I'm surprised.
But I'm looking at the world record photograph, so I have heard Canigou. I've never.
Yeah, one of those is the world record photograph. Yeah. God damn, I gotta scroll down. I gotta sort this in better. You just posted something?
In the pill, yeah.
Okay. Oh, okay. All right.
So this would be my question to flat earthers. If we know the law of perspective, right? Double the distance, half the size.
Yeah.
So Peak Gaspard is 443 kilometers away.
You do realize there's mountains in the foreground, right? That are something like 100 miles closer.
Whatever. Peak Gaspard is, let's just call it 4,000 meters for the sake of the conversation. We know that's not spot on, but 443 kilometers away, 4,000 meters tall. Right? To the left is Grand Ferrand, right, which is 3,000 meters. Let's say it's 2,758, but let's just say 3,000. And it's 392 kilometers away. So it's only 51 kilometers closer, yet it's 3.5 times the size of Peak Gaspard.
And?
Well, that's not perspective. Double the distance, half the size. It would have to be 3.5 times further away to appear to be that size.
I want to take a look at this. Hold on. I'm going to show you something, but I just want to look at this. Is super fucking small. Well, you did hear me say that things get compressed with distance visually, right? Not only we know it, it's demonstrated by the flattening of the sun. And I can show you this specific place.
We're talking about
it happening.
We're talking about this.
I can show you it happening in this specific place.
What do you mean?
By comparing an infrared photograph with a visible light photograph, and one is compressed versus the other, taken 5 minutes apart.
Right, I don't see a point.
The point is that a naive saying, "Hey, perspective should do this." There's meteorological conditions. Perspective is just a rule of thumb.
Right, there's meteorological conditions, like refraction.
Yeah. Well, I mean, refraction's an oversimplification.
But
it's not just refraction.
So meteorological conditions can work in your favour, but no other at no other time. You're in your favour that contradicts what the rest of the science says.
No, because we can demonstrate our claims experimentally, whereas you can't demonstrate yours. That's the difference. You can't demonstrate something with experimentally of a curved surface being made to look flat, an object from behind a curved surface appearing in front of the horizon of that curved surface. For example, there's a video with a butane tank where they have a piece of clay, and they take the butane, and then the piece of clay lifts up, and you can see more of it. Can you get the edge of that butane tank to be behind it? To be behind the piece of clay?
No, I can't. I'm not picturing what you're saying.
Well, there's a butane. They take a big butane tank, right? And they take like a piece of clay that's red, blue, and yellow, like different colors.
Yep.
And you can only see the very top of it. It's behind the edge of the top of the butane tank.
Right.
The butane tank's on its side, right?
Yep.
So it's a nice straight line.
Yep.
Like a curved surface, right? Nice curved horizon. They spray butane, which is a high refractive index. It's like 0.4, and it's freezing cold. So it goes up so you can see the yellow and the green.
So it lifted. Right? So it lifted the clay up.
That's right.
Thanks.
But the edge of that, the horizon, never changed. Never changed. Right? So you have to be able to make the horizon go behind the clay.
What?
The edge of the tank has to be able to get refraction, has to make the edge of the tank go behind the clay.
No, that's not right.
Okay. So when we do an observation of oil rigs at 10 miles away when the horizon should be 1 mile away, right? And the horizon's beyond 10 miles and the oil rigs are in front of that horizon, how did the horizon get from in front to behind?
Because the refraction's happening at the oil rig and lifting the oil.
Okay, so
in your
oil rig,
they did the butane. They put the cold onto the butane tank. Is that correct?
They've used cold butane, yeah.
Yeah, so the refraction is happening at the tank.
Yeah, right on the surface of the tank.
Yeah, I'm not.
They spray it.
I'm not understanding.
Okay, it's a liquid butane. Yeah. They spray it on the surface of the tank. Because it's so cold, it evaporates. Okay? Butane has a refractive index of something like
I'm not understanding why you think this is a point for you.
Because you have to move the edge of that butane tank behind the clay. Just like you move behind the oil rig.
No, you don't have to move it behind. So if you lifted up the bottom of if you actually physically lifted the clay up so you could almost see the bottom of it, when they put the butane stuff, when they made the tank cold and the refraction happened, you would see the bottom of the clay.
Okay, that's cool, but the edge of that tank is still always in front of that clay. It's never behind it.
No, but if you had the bottom of the clay only just out of sight, when you made the refraction happen, you would see the bottom of the clay.
So
ipso facto, you would see the bottom of the rig.
So you're saying that you could, if you had a higher refractive index medium, like freaking super cold butane, let's say it's negative 200 degrees.
No, if you just position the clay differently, because what was it to scale with what the Black Swan photograph was? No, it wasn't. They've just put a bit of clay there, and they're showing you how it lifts up. The fact that you can't see
there's no scale at which anybody's demonstrated. My point is, there's no demonstration that this is even possible.
It's a moot point. The fact that you can't see the bottom of the clay is just where they positioned the clay in the first place.
Listen. The Black Swan and the oil rigs isn't about the oil rigs being blocked. It's about the horizon being in front or behind the oil rig. They're supposed to be in front, but it's behind. It moved 10 miles. You understand? The horizon, whether blocked or not,
I don't know if you're intentionally misunderstanding this.
And instead it seemed farther than 10.
I don't know if you're intentionally misunderstanding it or what, but...
The Black Swan, I helped create it.
Well done. Good for you. So if they place the clay, right, so they've placed the clay too far, so when they make the refraction happen, it's too low for you to see the bottom of the clay. Whereas in the Black Swan, it's only just below the surface, so when the refraction happens, you can see the bottom of the oil rigs.
Not talking about the bottom of the oil rigs. I'm talking about the horizon distance.
If you can see the bottom of the oil rigs, right, then the horizon isn't in between you. The horizon is past the oil rigs.
Okay, that's fine. Say the horizon would be right at the bottom of the oil rigs. It doesn't matter. It should be in front of the oil rigs, period.
But it's refraction happening, and your experiment
proved line where the sky appears to meet the Earth should be 1 mile away. It's 10 miles away.
And no
one's been able to demonstrate that you can do this in any experiment, that you can move the edge of that butane tank further away, or uncurl the butane tank, or move the fucking surface around. No one's ever demonstrated that that's even possible.
That's ridiculous. You're being silly there saying that, because that's not what it's about.
Okay, show me. I'm open.
You've lifted the clay up. It shows that
more than lifting up. That's only one part of it. You have to move the horizon too.
By lifting it up, you are moving the horizon. If you could see the bottom of I think what you're picturing is that the butane tank is the horizon always, and the butane tank would have to physically move behind the clay. Now, if you lifted up that clay so you could see the bottom of
visually,
right?
Move behind the clay. Visually move behind the clay.
If you lifted up the clay so you could see the bottom of it.
Yeah, don't make sense.
The horizon is back behind the clay now.
Is it? Well, in that video, the edge of that butane tank does not fucking move.
It doesn't need to.
Well, how would it get behind the clay if it doesn't move?
Oh my God. Is the clay sitting on the butane tank?
Yeah.
It's sitting on the butane tank.
Uh-huh.
And you can't see the bottom of it when they do it.
No.
So clearly not to scale with how far away Black Swan would be.
You're right.
On the planet.
You're right, it's not to scale.
So it's,
in fact,
your butane
it's
tank
non-physical.
What, about 60 centimeters in diameter, and they've placed the clay, at about, if you were looking at the canister, so you could see the round end of it, they've placed the clay where, at 10 o'clock? 11 o'clock?
Yeah.
Okay.
Yeah.
So they've placed it halfway around the planet. Not halfway, of course, but they've placed it thousands of miles away in equivalent to the Earth. That should be
great, and the freaking clay is also fucking 500 miles tall.
So if you're going to use a clock, you would be placing the the clay at 11:59 and 59 seconds.
Okay, so you do realize they're using butane, which has a refractive index of 1.4 or 1.34. Okay, it's something like 3 million times greater than the difference in air.
Yeah, the point I'm trying to make is to say that the butane tank as the horizon needs to physically move behind the clay is not correct. That's not what needs to happen to justify.
If you want to demonstrate, if you want to replicate what we see in nature, that's what needs to be demonstrated.
Then you would need to place the clay at the right spot.
Okay. Well, I mean, go for it.
Okay, cool. So
that's what I'm talking about.
So
we've demonstrated. We've demonstrated. Okay. Well, we've demonstrated all the things that Goldberg says is.
It, refuting it, is not wanting an answer.
No, it's not wanting an answer, because when you ask the question, you're loading the question, first of all, fallaciously. You're trying to basically form a narrative and manipulate the narrative towards it, instead of letting the person actually explain the perspective and information. And when they do, like, you immediately either mock the answer because you already know the answer, so you're setting up the terrain, asking a question so that they give an answer that you're going to mock, that you already know you're going to mock it, and that your intention is to mock the answer. That's not wanting the answer. That's just wanting to mock the person.
We're not mocking the answer. We're pointing out its flaw.
So, the Earth is flat, therefore the Earth is flat, is not assuming the consequent. But when we say that, well, if the Earth is a globe, therefore we should see this observation, and if the Earth is not a globe, therefore we shouldn't see this observation, and we should see this instead. We see this observation, therefore the Earth is a globe. Is not valid? Okay.
No, that's affirming the consequent would be akin to saying...
What?
If the Earth, akin to saying, if the Earth is a globe, we will observe X. We observe X, therefore the Earth is a globe.
That's false. That's not what we do. That is affirming the consequent. I agree completely. That would be affirming the consequent, because you don't have an inference rule. But if you say, if Earth is a globe, and then we will see this observation. But if Earth is not a globe, therefore we have the inference rule of if not a globe, then this observation, which would be exclusive to the previous observation, would also happen. And that's when
No, you'd have to say, no, you'd have to put it into modus
Yes, it's modus tollens, exactly. Modus tollens, that is exactly what I was doing. Modus tollens.
No, you don't start off with if Earth is not a... No, you don't start off with if Earth is not a globe. You start off with if the Earth is flat.
Oh, yeah.
We will observe X.
Okay,
we
if
don't
the Earth
observe
is flat,
X, therefore
we
the
will
Earth is
observe
not flat.
X. If the Earth is not flat, we will not observe X. If the Earth is a globe, we will observe Y. If the Earth is
incorrect,
not a globe,
bro.
we will not observe Y.
No. Listen to what I just said. Okay? Listen again, closely. If Earth is flat, we will observe X. We don't observe X, therefore the Earth is not flat.
That's affirming the consequent.
No, it's modus ponens, you idiot. Tollens. It's modus tollens.
So, if the Earth is not flat, we would have this observation. We have this observation, therefore the Earth is not flat. Same thing.
No, we don't have this observation, I said. Listen, open your freaking ears, bro.
Okay.
If P, then Q. Not Q, therefore not P.
Okay. So if the Earth is flat, we should have this observation. We do not have this observation, therefore the Earth is not flat.
That would be a modus tollens, yes.
Correct. And that is exactly what's being applied.
In which instance?
In the instance that we also use the if the Earth is a globe, because saying if the Earth is a globe is just as valid as saying if the Earth is flat. So if the Earth is a globe, then we would have this observation. We have this observation, so if the Earth were also flat, we would not.
No,
have
you don't
this
get to add
observation.
more into it, bro. No, you don't. You stop there and you go if. So we have this observation. Therefore, what? You don't get to turn it into it's not flat. You must go back to your previous premise.
Okay. The Earth,
therefore, the Earth is a globe.
If the Earth
That's
is not
exactly
a globe,
what's happening in astronomy and other fields.
Okay. If the Earth is not a globe, then we would not have these specific observations. We have these specific observations, therefore the Earth is a globe.
No, that's not how it works. My God.
That is how it works. That one's modus ponens.
You're butchering logic.
No, that one's modus ponens. If the Earth's not a globe, we would have these observations. We don't have these observations, therefore the Earth is a globe.
No, that's not. What is that called?
That's modus ponens.
What form of logic? No, it's not. My God.
Okay, so you're saying
If
that
P,
you're
if
saying
P, then Q,
if the Earth is
not
flat,
Q,
we would have these observations.
therefore not P.
We don't have these observations. The Earth is not flat. Is valid, but when
Modus
we do the same thing with the
ponens
globe, it's not valid, dude. Seriously.
No, you're not doing that.
Yes, we
You're
are.
butchering it.
We are doing
if
that.
P, modus ponens is this: if P, then Q. Not Q, therefore not P. You don't get to say if P, then Q. Not Q, therefore X.
Okay, and what happens if not P, then Q? Not Q, therefore P.
What?
If not P, then Q. It's not Q, therefore P.
So you're starting off with if not P.
Yeah, if not P.
Which is
then
the same
Q.
as saying if P as something else.
No, if not P or if P are two valid inferences. So, if not P,
Yeah, but
then
because
Q.
you're trying to say...
Not Q, therefore P is valid.
Yeah, so you're saying if not P, then what? Then not Q or Q?
If not P, then Q. Not Q, therefore P.
Oh my God, right. I just got if not P, then Q. No, if not P, then Q, is that right?
Yes, if not P, then Q.
And then what do we get? Do we get Q or do we get not Q?
Not Q. We get not Q, therefore P.
Not Q, therefore P. You said if not P.
Yeah. If not P, Q. Not Q, therefore P.
That's backwards.
That sounds like an all or nothing fallacy too. I mean, what's going on here? Stop it with the shit now, Stormbreaker or whatever the hell your name is.
You have the modus ponens and the modus tollens.
Wait a second.
No, get back to the topic of the room. This is insane. Look, you came in here, you made a bunch of claims. You couldn't back them up with evidence. We showed you an example, I assume, and we showed you a laser test over a lake or something. You couldn't refute it. All right, so that's where we're at. Now you just keep bringing up the stars, the sun, the moon, everything else but the Earth. Are you going to have? Do you have anything you can back up the claim you made that the Earth is round? By the way, that's not the default position. The default is we look out over ocean, it looks flat. We don't feel any movement, so it's not moving. So you're presenting something. You could have just have said like the Earth is a cube and then tried to prove that. I mean, do you have anything?
I mean, you said a key thing here. When you said it looks flat. Okay, I agree, it can look flat. But I mean, we've made observations of zooming in on a smaller ball, and it looks flat when zoomed in enough.
We
So
haven't
scaling.
zoomed in
Wait,
on
wait,
the
let me
ball.
finish.
Do you understand
So
why?
scaling matters.
Mathematically, do you understand math? Right?
Yes, scaling matters here. Let me finish.
No, I want to say this, and then you can finish. You have to be 10,000 miles away from your ball to see the full ball. Do you understand the math of that? ISS is...
Actually, you would have to be way further than that.
ISS is 250 miles up, and they show you your ball, right? We both agree that that's fisheye lens, correct? Because you can only see 3% from that height.
Yeah, it's still not high enough to see the whole thing.
Right, so we cannot see curve down here, therefore it's flat, right? We all observe it as flat.
Even because we're too small. We're literally too small.
Right, but we have a claim on the table. NASA says that the ball has a radius of 3,959 miles, correct?
Yeah. We've been through this. Wait.
Right.
We've been
So
through this
mathematically,
earlier.
we figure it out.
I know
right?
what you're saying. I know what you're saying. The 359 Malleus and the curvature drop. We've been through this earlier. Okay.
Yes, we don't have any measurements of curve. That's the problem.
Because of the scaling.
Yeah, well, we have
scaling is an issue for this too. Yes.
It can't be a ball.
No, that's wrong. That's wrong.
I mean, I can grant you it can be like maybe a disco ball with some flat surfaces here and there, but really, thousands of them? That's not even NASA's claim. They say it's a perfect ball.
No. NASA doesn't claim it's a perfect ball at all.
Oh, you've seen the pictures from NASA? They sure look like a perfect ball.
Well, it looks like a perfect ball. Doesn't make it a perfect ball.
There's a difference at the equator, according to them, for a couple of miles. But, you know, as you said, scale it out, and there's no difference.
Yeah, when we're talking about, let's say, a 6-mile oblation on 40,000 miles, I don't think your eye is going to see the difference.
I know, it's nothing, and you're not going to be able to...
It's like if I change your screen from 1080 pixels to 1079 pixels, you probably won't see a difference.
You're spacing away again. Listen, just think about this logically. If we shoot that laser over a lake, and it's 1 foot on beach A...
The laser bends.
1 foot over water on beach B, the 66 foot of curvature, no refraction can bend that much. Under any circumstance.
Again, that's a false claim. Also, the 66 foot is cumulative in linear. Let me finish. When we're applying curvature drop, this is what I was saying earlier. I knew you were saying this. I knew you were going for this argument, and I was trying to tell you that this argument was already pre-assessed. Literally.
I'm willing to look.
We've already went through this.
Your refraction. I'll grant you 20%.
It doesn't matter for the refraction here. Where you're getting your, I'm trying to explain to you where you're getting your maths wrong. It's not in the refraction. Your problem's not in the refraction. Your problem is that you're applying a linear cumulative curve drop to something that is non-cumulative and non-linear.
Look,
that's the problem here.
Why don't you do that?
Where it doesn't match up is that you're using this linearly and cumulatively, and then you see that it's not cumulative and linear and saying, therefore, it's wrong.
Yeah, you're in word salad.
But the fact is,
take your breath, okay?
The fact is, the whole thing is non-linear and
no, that's a valid form. That is a valid form.
If you apply that, the curvature drops is perfectly fine.
It is a valid form on a sphere because if you extend a straight line out, a tangent line out, from a single point on the surface of a sphere, right, and then draw a perpendicular line down from that original tangent plane, there will be a distance of that line where it meets the surface.
It will never be cumulative, so it won't be 67 feet.
It doesn't matter. It's still
yes, it matters. It absolutely matters.
Doesn't matter. No, it doesn't. No, it does not. It does not. No, because if you have a sphere of a particular size, its surface is going to have a curvature rate, and that will determine how far down from a tangent plane,
and
perpendicular to that tangent plane, that distance between the plane and the surface.
And that sphere will not have a
It's
cumulative
a valid
drop.
form of measurement, bro. It doesn't matter. I don't care about Euclidean versus spherical geometry.
That has a
It's a
cumulative
valid
drop in
measurement.
their curvature. I'm sorry.
It's a valid measurement. I don't care how accumulative or non-accumulative it is.
If you
There
don't
will
care,
still be
then why
a
are you trying
distance
to make the
between a
argument? You don't
tangent
understand what you're
plane
talking
and the
about, and you don't care about
surface.
the facts. You just said
There
you
will
don't
be
care.
a distance,
If you
bro.
don't
There will
care
still. It
about the
doesn't
factor
matter.
that proves you wrong, then
because
that's why
there
you're
was
gonna stay
because.
wrong.
Hey, fuck you, bro. You're gonna listen.
Telling you that you're wrong.
Because there will still be a distance between the tangent plane and the surface over distance. There will be a length.
La 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 la.
Alright, okay. So you're unmuted, you're going to play piano, alright.
What?
Go back on mute, bro. Unless somebody... You want to continue with him playing?
And he plays Twinkle Twinkle Little Star in the wrong key, and then he talks about the stars like he knows
I mean,
what
it's
they
kind
are.
of funny you guys will just
Anyway.
prove you wrong. I mean, yeah, you guys are ignorant as well.
I don't know. I think I've had enough of him. He doesn't understand logic. It's super weird to talk to a person like that.
Yeah, his whole F, if not P, therefore Q, doesn't take into account that Q could be the result of if not other things or if other things. Right, so to affirm that because you don't have Q, therefore P is completely invalid. Sorry, go on, Lucky. Lucky.
Yeah, I agree. Yeah, Lucky, you can go. Sorry, I have guests here. I better entertain them. Thanks for putting up with me for a little while there. I couldn't not speak up.
I mean, guys, Earth is of course round. I mean, what's the point of this VC?
Is it obviously round?
It is.
Okay, when you say round, you mean spherical, right? Like a ball.
A spear, yeah.
Okay, what makes it so obvious? When you go out into reality, what do you experience that makes it obvious?
I mean, if you take a lump of clay, put it into a glass of water, the gravity is gonna make sure that that lump of clay turns round. So basically, if gravity does exist, it means that the Earth is round, because it's the most efficient way for an object to be in presence of gravity.
Excuse me, you're going to have to show a demonstration.
And also, all the car tires are.
I'm sure. I'm sure if I put a lumpy piece of clay, misshaped, into a body of water, it's not going to just magically form into a sphere.
It's not magically forming into a sphere. It's going to be a couple of cars.
It doesn't turn into a sphere. That's the thing I'm saying. It won't turn into a sphere.
No, you can Google
show
it.
Us.
It does.
Show us. Show us.
You can Google it. I can't share my screen.
No. This is your claim. I'm not going to Google your claim. You're going to provide the evidence for this. Go ahead.
Let me just Google it and then spell out what Google says. Give me a minute. Mm-hmm. Mm-hmm. Basically, you form a sphere. 1 minute, just a sec. Yeah, basically, whatever experiment I suggested, this is the explanation for it. These experiments illustrate that even though the Earth is a very large sphere, our perspective on its surface is limited to relatively small areas over a short distance. The curvature is not noticeable and the ground appears flat, similar to the flat appearance of the small cut-out clay piece.
You're not telling me anything I haven't heard before, bro. Can you post the demonstration of placing a misshapen, an uneven piece of clay into a body of water and observing it turn into a sphere?
Fine, well, let me link a video if I can. 1 minute.
And after you post the observation of that happening, if there is such a thing, you're going to go ahead and show that gravity caused it through experiment. I mean, it's ridiculous. Like, hey guys, I stuck a cube of clay, right, in this jar of water, and I came back so many days later, and it was a sphere. That's ridiculous. Did he pop? No, he's still here, bro.
I'm not able to find the experiment, but nobody has done it, I guess.
Because it doesn't exist.
No, I mean,
there's no such thing.
It does exist. It's just that nobody has posted it on YouTube.
There's no such thing as somebody putting like a cube or a pyramid or some other asymmetrical form of clay into a body of water and then coming back later or sitting there and watching it slowly turn into a sphere. Doesn't happen.
No, actually, I mixed up the experiment a little bit. You're supposed to roll it into a circle, and then if you put it into water,
so you're starting off with a sphere.
Gravity.
So you're starting off with a sphere that you formed with your hands. Yeah, bro, that's not a good demonstration to support your claim about gravity forming things into spheres.
No, I linked another experiment.
I mean, you have so many things to prove that Earth is not flat. I mean, and I feel like this is a absolute. I mean, you have hydrostatic equilibrium, you have laboratory analogs, and you have astronomical observations. I don't know what you guys are tripping on. I mean, in conclusion, it is flat. I mean, the spherical shape of planet is a direct consequence of gravity acting uniformly in all directions. Like, it is confirmed by physics and observation. So you guys saying Earth is not flat is not going to change the reality. And I feel like this is a cult. I mean, you guys are just trying to like rage bait normal people into this. That's what I feel.
No, we're not trying to get anybody into anything. Okay, we're challenging the view that you just passed out for us, basically.
I mean, the view is already.
There is no scientific validation that objects are going to form into spheres naturally. Right,
then why don't
due to any sort of magical invisible force?
It isn't a belief-based observation, right? It's measurable. We can observe ships disappearing hull first over the horizon, satellite imagery.
Okay, at what distance? At what distance? If it's measurable, at what distance?
That's what happens. You're not letting me talk. You're not letting me.
Okay, so you said it's measurable. Okay, what's the numbers involved with a ship disappearing hull first?
That's what happened, and that's the only reason you muted this Storm guy, right? Because you were not.
You said it's measurable. Okay, stop talking meta. Stop talking about the person and the people, and address the claim you made. I'm addressing the claim you made. Right?
When I started talking,
we observed a ship disappearing hull first. Okay,
I was about to make multiple claims.
So I get you don't want to support your claims.
I mean,
you don't want to support your claims.
The fact that you can't accept reality is kind of.
Okay, you don't want to support your claims. We understand. Right, you've just got
but don't you
claims,
think it's a
nothing
little
to, no
cultish
evidence
to
to support
argue?
it.
You're saying that we should only argue in a certain manner, which
Right,
is very
are you gonna
cultish
talk
behavior.
about the people? Or are you gonna address the claims that are on the table?
Earth is flat and it's already proven, so
I
there's
agree. The
nothing
Earth is
to.
flat, and it's already proven.
The Earth
That's what you
is
just said.
round. I mean,
Freudian slip there.
no, not really. Just a mistake. But the Earth is round, though.
Okay, what validation do you have for that? Empirical.
You go on the top of the Himalayas, and then you see that the Earth is round, like it curves when you look at it from a distance.
We actually don't observe that. We've got footage from the top of Mount Everest where the horizon is not curving left to right.
It does curve left to right. What do you mean?
No, it doesn't.
Yeah, you have to go there and see it for yourself. The footage is not going to prove it.
No, bro. We've got observations from various heights, top of Mount Everest, and even higher in the air.
So you're saying that you have.
There's no visible left to right curvature.
You personally have gone to Mount
Your
Everest.
own side says that it wouldn't be observable at that height. You need to be much higher.
If you have to be much higher,
you would be seeing a tiny, less than a 0%.
Then why wouldn't you directly go to space? Right? Because that's the only
less
way
than
to
1%,
see if the Earth is round.
No, you don't need to. We already observe it.
No,
we already observe the
essentially
Earth.
what you want to do, right? Because if you're saying that physics is wrong, and if you're saying gravity is wrong, and if you're saying that majority of the scientists who have spent their lives in this are wrong, then you're essentially just saying
do you know why?
that nothing
do you know why we say that?
is going to convince you,
do you know
which
why
is a cultist belief, by the way.
Do you know
so
why we say that?
Right?
Hey, Rohan, shut up for a second and listen.
Do you know why we say they're wrong?
Why?
Yeah, go on.
I'm asking you a question. Are you aware of why we say those people are wrong?
Why?
So you don't know. You don't know why we say that they're wrong.
But you asked me. Do I know?
So you don't know why we say they're wrong. You stated we say they're wrong. Yeah, we do. Yeah, they're wrong. That's not a sphere. Do you know why we say it?
Because you want a sense of belonging. That's why.
No, incorrect.
And then flat Earth is. I think that's what it is.
No,
most cults work on that basis. Yeah.
Okay, bro. Do you want to hear why or not?
Yeah, sure. Go ahead.
All right. It's got nothing to do with wanting to belong to a group or a community. It's got to do with the claimed geometry that we were given about the Earth's surface. That it's a sphere with a specific radius value and that its surface has a particular curvature rate over distance. All right. And that there's reasons why all this other stuff that's not the surface is observed or occurs. Right? So there's a geometrical claim about the surface of the Earth, which when we go and test and look for, doesn't exist. The surface does not deviate from a straight line, does not deviate from a laser, for example. So that the deviation, if it was a sphere, over distance would increase, where there is an observable and measurable increase of distance between such thing as a laser and the surface of the Earth with increased distance. So we can shoot a laser over something like a 20-mile lake and see that it hits its target on the other side, where there should be a significant amount of curvature drop, where the laser would miss its target by hundreds of feet.
That none of that makes any sense.
Yeah, it doesn't if the Earth is a globe, does it? It doesn't make sense that a laser across a 20-mile body of water would hit its target. Doesn't make any sense if it was a globe.
No, see, the thing is, when you shoot a laser, it will bend. Like, it's impossible for it to not bend. What the hell?
Why would it bend?
Because the Earth is round.
So that's circular reasoning?
You're telling me when I go to the shops and purchase a laser that it naturally conforms to an 8-inch per mile squared curve? I thought lasers were
Well,
straight.
if you shoot it long enough.
So you're telling me lasers don't shoot straight beams of light, they shoot big curves of light?
If you shoot it on a long enough frame, it does curve.
Yeah, you're employing circular reasoning.
He's telling
Where
us
you've already
lasers
decided.
curve.
Yeah, because he's already decided the Earth is a ball, and that's why it would hit its target over a significant amount of distance across
That's
the
his
body
only
of water.
explanation. The laser must be curving. Yeah.
It must be, because Earth is a ball. It's circular reasoning. You just hand wave dismissing it. So you say it's got nothing to do with wanting to be part of a cult. It's got to do with observation, measurement, and practical use.
No, this is definitely.
In no point in your life are you ever going to be observing the Earth to be a globe and have curvature, or measuring it to be a globe and have curvature, or using it as if it's a globe and has curvature.
To measure if
Rohan, you're really rude. You're very rude, Rohan. You should listen more than you speak.
See, again, you're giving conditions once again.
Yeah. You have 2 ears and 1 mouth for a reason, so that you can listen twice as much as you speak.
Really? Who says that?
Everyone. Have you never heard of anybody's old wisdom? You never listen to your grandparents? You don't listen to your parents? Everyone says that.
I mean, how do I know my grandparents are real?
Holy shit,
Right?
you're a super
According
sophist,
to your
aren't
logic,
you?
I mean,
You're a sophist.
I mean,
You
if
are the
I-
proof.
You're
are the
basically
proof.
creating a straw man argument. You realize that, right? You're not actually accurately representing your opposition's argument. You're creating a straw man. This is fallacious.
But we can use his
Okay,
logic,
wait,
because
somebody wants to
we can
tell
use his line of
that,
logic, right?
Your
It's
math
analogous
only works
because
on an Earth
hey, Rohan,
3959 mile radius without an atmosphere. Since that Earth has
he's on
no
Yappuccino
atmosphere,
tonight, ain't he?
they will
He's
never
on that
match the
Yappuccino.
no atmosphere maths.
All right, so
Yeah,
can
this
you give
makes
us for an
sense.
example? Can you? Oh, what you were reading something from the side chat, or what were you reading?
Yeah, somebody wanted to tell you this. And yeah, this is true actually. I just Googled it as well. This is true. Whatever he said is true. I just Googled it.
Who said what? Are you talking about Lucky or
I'm talking about Perfect Storm.
Perfect Storm? Where did he say it? Read it out again.
He said that your math only works on Earth 3959 mile radius without an atmosphere. Since the Earth has no atmosphere, they will never match their raw no atmosphere maths.
All right, so give us the math with the atmosphere.
You want the math?
Yes, give us the correct math.
Okay, wait, let me just use AI for this 1 minute. I'm just gonna type it in.
Are you telling me that you're trying to defend a position that you have to research on the go?
Yeah, because I know what I'm saying.
How did you know what T-Dub said?
How were you so confident?
Hey, Rohan.
You know
how did you know what T-Dub said? Rohan, just hold up for a second.
Matter if I'm researching.
Rohan, hello.
Because you just.
How did you know, Rohan? How did you know that T-Dub was right or wrong if you have to research it?
The math is right there. Go do it yourself.
What math?
The math is there. Look, I just typed it in the side chat. Look.
Yes, but you had to research it. This is what's skipping your fragile little mind. How did you know, and how were you able to speak up about whether T-Dub was right or wrong? Why is the necessity to fucking talk through me right there?
That says a lot.
Rohan, shut up. Rohan, why did you have the necessity or capabilities of telling T-Dub he was right and or wrong without knowing anything about it in the first place? That's what I'd like to know. How did you know to tell him he was wrong before you researched it?
The math doesn't change though, right? Because the laser will bend because of the atmosphere. The mathematical
Excellent.
modules of Earth,
So,
shape,
Rohan,
and curvature.
Rohan, we don't live on a number 7. Rohan, I know you've probably got me turned down, and I hope you haven't for your sake. But show us the math of this laser bending, and if it's true, you'd be able to show us a video. Rohan, shut up! I haven't finished. Rohan, Rohan, hello, Earth the Numpty. If this is true, you would have to. Okay, we're going to have to help you out. Obviously, you've got some kind of microphone malfunction there. Rohan, I want you to go and scour the internet and bring forth video, photo evidence of a laser bending downwards in open air. Not in sugar water, not bending upwards, but bending downwards. Surely you'd have some kind of video or photographic evidence of a laser doing this, if it's such a common occurrence, and that's what's required to bend around Earth with a radius of 3959 miles. So go forth and have a look and see what you can find. Have fun. And Lucky, piss off. You're a clown.
Yeah, these guys are so low tier, low hanging fruit. It's not even worth speaking with them, to be honest.
This Rohan clown doesn't even want to listen. He just wants to have his little meltdown.
They hear only to respond and to react. They never listen.
Let me know when you want me to speak.
They won't care because they've already got in their head a straw man of you, and so they're going to keep attacking
see, you guys are giving me conditions. I'm going to give you guys conditions, right? I'll give
you a condition. Check this out. Silence.
Yeah, you have zero authority here. No power. Carry on.
Now, who's the one that's got the zigzaggy? I don't even know how to say that name. Maybe they've got a proper name, and I just profile. Let's have a look here. Perfect Storm. All right, perfect idiot. Incoherent question. The laser bends. Okay, then, if that's the case, you will be able to provide, instead of Rohan, video or photographic evidence of a laser bending downwards. It's so simple. Provide the evidence of a laser bending downwards, because that's what you're claiming. Lasers bend downwards to match the alleged curvature rate of the Earth. It's ever so simple. It's not an incoherent question. It's your claim. You're backing him. You're taking his side, so you now can carry the same burden. You claim that lasers follow the curvature rate of the Earth, so provide some kind of video or photographic evidence of such. Please, anyone. Hey, Shan, you got something to say, or are you just going to be a coward and sit in side chat? No, Rohan, you were not muted against anyone who argues over the truth. You were muted because you were talking over people and you didn't know when to shut up and listen. That's why you were muted for. And then you thought you could set the rules in someone else's house. It don't work like that, bro.
Funny stuff.
Okay, hold up. What have we got here? We never said downwards. You're the one adding that, and I explained downwards would be towards the centre of the Earth. With a laser, we're talking about a laser, Perfect Storm, a laser. You go outside, you set the laser up horizontal, and what you're claiming is the laser needs to follow the curvature of the Earth. So if the Earth, claimed, is bending downwards at a given rate, that means the laser would be following at the same rate. That's what you're claiming. So, the last time I checked, all the globers claimed it was bending downwards, so that means the laser has to bend downwards. So, go and show us the laser bending downwards. That is what you're required in order to prove you're ball-tard. What's this? I'm a cult follower. Ooh, I'm in a cult. Who's the leader? I didn't know. Shit. What's this? You're a cult follower. Like, notice how you place conditions to argue. You are trying to get sort of simple response that is in your favour. No, I'm getting you to provide evidence of your claim. You dumbasses claim that lasers bend. So which way do they bend? If I go and purchase a laser, does it bend upwards? Does it bend downwards? Does it bend to the left? Does it bend to the right? You know, so if these lasers are naturally bending, why do they use them on building sites as level lines, straight edges to mark where they're building? If they bent, they'd be friggin' useless. What's this? When I'm saying my evidence, you can't say I can't answer a certain way. Again, cult belief. I know this is the English channel, bro, but you're going to have to try harder than that. Yet again, young Storm Chaser. You have to prove that the laser is bending at the same rate as the claimed drop over distance. 8 inch approximately per mile square. You have to do that. Photo or video evidence.
Plus, we're not restricting you from being able to answer in any particular way. We allow you to answer in any particular way you like. We are then able to point out its invalidity or any flaws within the reasoning, the demonstration, lack of evidence, etc.
What's Rohan got? Ships disappearing whole first over the horizon. Is that the best you've got, kid? Oh.
Well, Lucky tried to present that as some kind of measurement, and when I pressed him on the measurements and the numbers involved, the math involved, and the instrumentation that would be involved in getting some data from an observation of such, he flipped out.
This season 1 crap. That's all it is, season 1 questions. These people don't understand what the Rayleigh criterion is, so they're not even qualified to receive the answer to their question.
I know what it is. That's a dude in our chat there. Look, Rayleigh criterion.
He could explain it. There you go, Ray. Tell them how it is. These idiots actually think that the Greeks believed that the Earth was round. They're claiming 2,000 years worth of history. And my only question, it's going to remain my only question, what is Atlas holding on his shoulders? I'll wait. Exactly, Flatloid. The celestial sphere. Not Earth. People assume that it's Earth because they've seen a sculpture, they've seen a picture, or watched a cartoon where they saw a giant man holding the Earth on his back. But according to Greek mythos, no, they never claimed that the Earth was a ball, and Atlas was holding the sky on his shoulders, not the Earth.
Which was a punishment from Zeus.
And then these people keep claiming cult, but they can't even define what the word cult means. Meanwhile, they never question the beliefs that they have about something they've never seen. They've never seen Earth as a sphere. They have a belief that they cannot prove. And meanwhile, they're going to keep projecting and claiming that we're the ones who are in a cult. That's hilarious. A cult has a very cultivated set of beliefs, very much under control. Who's the leader here? Who's the cult leader of Flat Earth? I'll wait.
Alrighty, so Perfect Storm has just sent me his claim of how the laser bends. I'm assuming the red one's the laser. I might be wrong. We'll find out in a minute. Anyways, I'll just post this up so everyone can see it.
Guys, I have a question. I have
your question. What is your question?
Why flat Earth?
Why flat Earth?
Yes.
Because measured flat. No curvature measured.
Yep. You observe it to be horizontal. It presents itself as such. So if somebody claims that there's curvature, well, the burden of proof is on the one making the claim, now isn't it?
But
since it measures flat, and there's no measurement for curvature either.
I know.
Optical phenomenon that you observe is not curvature, by the way. So ships disappearing or whatever, that can easily be explained with the oculus.
But the Earth is not flat. It's like a circle.
If you're talking about the circle of your vision, no. You have a limiting circle of your vision based off of where you are, where the observer is at a point, so they can see to the horizon and they can turn in that point in 360 degrees, and there's a limiting circle of their vision, but that does not make Earth a circle. Earth is not a circle just because your eyes show a circle.
Okay, give me real information about flat Earth.
Go outside, look at the horizon, and just keep going. It doesn't curve.
It's not real answer.
Well, like my bro just said, there's measurements as well. It measures flat. And you can go and measure it yourself. You don't have to wait for somebody else to do it.
You know why?
There's no wizard on the mountain.
You know why you don't feel...
Noctis, something for you to think about. Noctis, something for you to think about, mate. If you were out on the ocean on a raft, just you, your raft, and a bucket of food so you don't starve to death, and you look north, do you see the curvature?
No, I will tell you something 1 minute.
Do you see the curvature? You're on a raft in the middle of the ocean. Perfect calm day. The water is smooth like glass. You look north. Do you see the curvature? Yes or no?
No.
So, how are you claiming ships going over horizons and all these other weird things if with the perfect conditions you don't see the curvature?
No, before the Earth is very big. You don't feel it is like a circle.
Okay, very big. So you don't see ship go over curvature because very big.
No, because the humanity is not feeling that.
Okay, so not curvature, humidity.
No, not like this. You don't know about what I am talking about.
Well, you're not doing a very good at breaking it down, my friend. You say not curvature, humidity, and I question that.
No.
So not curvature, therefore must be humidity, is cause of things disappearing.
Because the Earth is very big. We don't feeling like a flat. We're feeling like a circle.
So you're telling
us
it's
very, very
too
big.
So yeah, right. So you're telling us it's too big to see the curvature, right? But it's not so big that you can't watch a ship go over it and go out of view because of the curvature. Is that right?
Maybe not so big now. That's the problem.
So, okay, so if it's too big to see the curvature, right? So when you view, like, let's say, a pond, right?
Yeah.
Water in a pond, The surface looks flat, doesn't it?
Okay.
The surface in a pond looks flat. Okay, why does it look flat if it's curving?
What about Antarctica?
I'm asking you why the surface of the water in a pond looks flat when it's supposed to be curved. Why is that? Why? Can you tell me why the surface of water in a pond looks flat?
Because we have a lot of things.
Because we have a lot of things?
Yes.
This might be an English barrier, language barrier, I think.
1 minute. I will tell you 1 minute.
I think maybe because of the short angle and of the gravity. It's like flat.
Gravity makes things flat. Okay. Wonder how many flat earthers are going to disagree with that. There you go, boys and girls. Gravity makes it flat.
No, not gravity, but the short angle. Yes.
Short angle. So if you compare the surface of the water in a pond with something horizontal, right? Will it be different or the same? Will it be parallel? Or will the surface of the pond deviate?
Based over the horizon.
I can answer it for you if you like. Right?
No, 1 minute.
Okay, all right.
Okay, what about Earth's shadow on the moon as always round?
All right, stepping away from that
Well, you have
line
to
of
prove that
questioning.
the Earth is a sphere first.
No, why we see not every day we see moon. Maybe every 1 week or 2 weeks. Why is happening that? Tell me.
The moon has nothing to do with the Earth. You have to prove the Earth is a sphere first.
No, because the Earth is not moving around the moon.
Correct. The Earth is not moving.
Why do you
you're
think
right.
you can't see the moon sometimes?
What?
Why do you think you can't see the moon sometimes?
Because we don't see the moon every day. Because
I agree.
Because no, I will tell you. Because the Earth is not flat; is around.
You have to connect the two. You have to give the reasoning behind that. You have to explain what it is about the Earth being round that makes you not be able to see the moon every day.
Okay. 1 minute. I will tell you. I have simple sentence proof. Ships disappear, fall first over the horizon, which only happens on a curved surface, not on flat Earth. Not
You
on
said
a flat
Earth too big. So if Earth too big looks flat, you're not seeing the curvature. You've already said that. So how can you now tell us ships disappear over the curvature that you can't see?
By the way, that is not true. Right? We can reproduce the apparent effect on flat surfaces, and your own side says that that effect is also. It's also your own side also says that that is physically possible, right? So that you can have the apparent effect of bottom-up obstruction of a boat, for example, when there's no physical geometric obstruction in the way, so nothing to get in the way of it, but it can look like that still. So that's just blatantly incorrect and false.
But I have a very important question about that. Why NASA tell the people is not flat?
NASA is an agency, right? So it's made up of many people. So in what way are they saying that? Do they verbally saying it, or are they showing pictures, or what? How are they saying it's not flat? Oh, he's gone? Okay. Never mind then. Anybody else here with any questions?
What was the storm railed for? Sorry?
Oh, have a crack if you like, Matrix. Have a crack.
Is it just going to have a meltdown, or...? So, I'll repost your picture up for you, Stormchild.
Have fun with that.
Yeah, it won't last long, doesn't sound like. Anyways, I'll repost its picture that it sent to me. Oh, I thought I unlocked it. I'll have another crack. There we go. Right. Perfect storm.
Oh, I'm unmuted. Okay.
Great.
Hello.
Yeah, welcome back.
My pleasure to be here.
You might want to chuck some headphones on, mate. Getting feedback.
Well, I mean, the settings for my musical streams is kind of constant. Let me try and see something here. Is this better at all?
Let's have a listen. No, I can still hear myself.
How about now?
Testing. Yep, you're good there. Awesome. That's a lot better. We're not getting that electrical sound now. It's good. Anyways, I reposted your little laser thing. At no stage was I claiming you said the laser was bending towards the centre of the Earth. What I said you required was photographic or video evidence of a laser comporting or complying to a 8-inch per mile approximate radius. So the question I've got for you: do lasers bend? You guys say yes. You guys say lasers bend. Okay, which way do lasers naturally bend? Up, down, left, or right? Or is this just a
lasers
random
don't
whichever way
just
you get
bend
out?
arbitrarily or decide on a direction. They bend depending on the medium they're going through, such as the atmosphere, air.
So you're claiming the atmosphere bends lasers downwards because that's what you require.
Not downwards. If it were bending it downwards, the laser would be hitting the ground.
You need the laser to bend downwards because allegedly the ground bends downwards.
Let's clarify a misconception here.
In order to curve.
No, there's no misconception. Listen carefully, nice and simple, one step at a time. Storm, just listen up. Your claim is drop over distance. That means the ground gets... Storm, I haven't finished. Storm, I haven't finished. That means that the ground is lowering down. Why is he talking? Yeah, no, how about you shut up for a second? We're going to do you a favour here. Drop over distance. That's what you guys claim exists. Also known as a boltard or a sphere or an oblate spheroid. There's a whole truckload of names that people give it. Now, if lasers are following the claimed Earth, that means they would naturally be bending downwards. You're claiming it's the atmosphere that causes this bend. Okay, let's run with that. So that means that every single time, every single temperature condition, distance, air pressure, all these other bullshit things just so magically happens that they did it at the perfect time for the laser to match the shape of the ground. Is that what you're claiming? Why is this thing not unmute when I wanted to? There we go.
No, none of those are my claims. You're making up claims and
Well, excellent. So, in that way then, you've got to get us photographic evidence or film evidence of a laser bending downwards in the open air.
Hey, what if I show a laser bending upwards over a flat surface for 19 miles?
I know which one you're going to show too. That looks spectacular, actually.
It doesn't bend downwards. It doesn't go parallel. It bends upwards. And you can see it.
You know, perhaps he's not claiming that because in reality, or on a sphere, I don't think that you can have a bend of light downwards. Downwards would be in relation to a horizontal. So he wouldn't be claiming that. That would be a flat Earth. So he would, I don't know what he's claiming. Maybe he could tell us.
Well, if I can speak uninterrupted, and maybe I can.
Yeah, go ahead.
You're wasting time.
Oh. Well, like I was trying to say, following the surface of a sphere is not going downwards.
Of course.
Yes, it is.
No, it's not.
How is it not going downwards?
Okay,
If you set it up horizontal...
Do you have a lighter or a pencil?
Why do I need a lighter or a pencil? We're talking about lasers,
just like that.
not
I
lighters
just
or
want
pencils.
you to do one physical experiment for me.
We're talking about lasers, not lighters or pencils. So if you're going to give us a comparative, use the same tools.
Storm, you don't think there's a down on a sphere, do you? There's no down on a
If
sphere.
you're not going to let me cook, you're not going to understand. So at least
Can you tell me if there is a down on a
lighter and whatever. I'm going to.
I'm sorry, friend. Can you just tell me if there is a down on a sphere? Because I kind of want to agree with you.
Okay, down on a sphere is towards the center of the sphere.
No, that's not down. That's in.
That's down.
No, down is in reference to a horizontal. In is towards the center of a sphere.
Down on a sphere is in reference to the center of the sphere. Yes.
There is no down on a sphere.
Down is towards the center.
You can't just make it up as you go along, friend.
No, you can look it up yourself. Down is towards the center of the sphere.
Well, then just go ahead and provide me with the citation.
So you want me to look it up for you? Really?
No, this is your claim. I want you to provide the evidence for your claim. That's your burden.
We're
So citation, please. Citation, please.
Okay, citation of the direction of down on a sphere. Sure. Let's see who's the citation. Okay. The direction of down on a sphere is typically defined as the direction that points toward the center of the Earth. This direction is relative and depends on the location of the observer.
Exactly.
For example,
Exactly.
from an
Relative.
outside view, the direction of down for people in Madrid, Spain, is the opposite of the direction of down for the people in Weber, New Zealand, as these places are located at antipodal points on Earth. This concept is further explained in the comic 2800 Down, which illustrates how the direction of down can be redefined by choosing a different point of reference, such as the center of a different planet.
Oh, so we're pre-assuming in this scenario that the Earth is a sphere. And then this only works on planets, which are stars, wandering stars as they're defined. So down, if you make the Earth a sphere, is towards the center. So the Earth would have to be a sphere. Do you have any Earth curve measurements to prove that the Earth is a sphere?
We've been through this 5 times.
No, and you never provided any Earth curve measurements. So,
yes,
I guess we're begging the question.
The Earth curvature measurements. We all.
Sorry, not discuss. I need you to provide them and how they were obtained.
Hell, and then we're all discussing these.
Sorry, once again, just needing the measurements and how they were obtained. We don't need to beg the question. We just need to establish that someone measured Earth curve, and then we can move forward. Then you can beg the question with down being towards the center of a presupposed spherical Earth, or in this case, an established spherical Earth by way of measurements.
Question was here, where is down? And I asked, and I said, was questioned, and on a sphere is towards the center of the sphere.
Right.
You're asking,
Right.
well, you.
Yeah, no, that's the assumption that the Earth is a sphere, but I want to see if you've measured the curvature. That way we don't beg the question in this one instance, right?
Can you be in good faith at all?
I am right now. We're talking about what you're talking about. So you got your citation. You got your citation. So now we need to make sure that the Earth is a sphere. So do we have any measurements of the Earth being curved, and how did they obtain those?
We're not talking about your semantics. We've been.
Well, yeah, we are talking about semantics because definitions of words and their meanings, that's important.
Yes, at first we were talking about these measurements and curvature measurements, which led us to an agreement on how to apply them, and then they
Nobody here agreed to apply anything. Yeah. No, we need the Earth curve measurements, man, and how they were obtained. That's the next step. This is not semantics. This is just me asking you to go ahead and provide evidence for the claim that you made. It's not that hard.
Again, with you as a person.
This guy is very biased.
Can I speak now? Can I speak?
He sounds like a
Actually, do you know who he sounds like? I'll tell you what he sounds like. I'm just going to put the red flag on because I don't like him much. He sounds like, now, if I was to pinpoint one particular person, he sounds like Professor Dave's writer. Have a listen to the way this clown speaks and go and watch a Professor Dave video. If I could nail one person as being the writer for Professor Dave, this guy's it.
I was thinking it was Donald C's brother, but I could be wrong.
He hasn't had a meltdown like Donnie, though. But
I don't know. Earlier, it was pretty animated. Anyways, maybe he's got them Earth curve measurements, or did he post them in side chat? Oh, no, I took that away from him. I can undo it, though. Or you can DM them to me.
he's been DMing me stupid stuff, so.
Mm-hmm. So, yeah, Earth curve measurements. Do you got those?
So, can I speak? Are you just going to cut me off as soon as I talk again?
Why are you crying? Just get the doggone Earth curve measurements, man.
Just ask.
You can answer the question.
Like,
you're stalling at this point.
No. Let me explain something here.
No, you don't have to explain anything. At the moment, you've been asked for video or photographic evidence of lasers curving downwards. And you've also been asked to provide measurements of Earth curvature. So I'm easy either way. Whatever you want to put out there, I'm good for.
If he's having trouble with measurements, I put a meme in the side chat to help explain.
That's not what I'm having trouble with. What I'm having trouble with is as soon as I talk, you mute me to say something over me. And
you don't really need to talk to provide the measurements.
Yeah, the question is simple. Do you have what's been requested of you or not?
No.
I just went to unmute him and someone muted him.
No.
No, you got to double tap him.
Yeah, it's doing that.
You would get an answer.
Oh, okay. All right. So, do you or don't you have what's been requested of you?
Like I was trying to say earlier.
We just want a yes or no at this point. Just a yes or no.
I don't care what you want.
Yes or no? Do you have them or not?
That's not how a conversation works.
It is going to go that way here right now. If you don't like it, bugger off.
Yeah, see, it's real simple. I mean, I figured you guys would be ready and like excited to present the Earth curve measurements, not stall and talk about the format and talk about being muted. I'm asking you to provide evidence for your claims, and you won't do it.
Because there's something to clarify that you're not letting me clarify, that should be clarified, that is important to clarify.
Let me have like 3 minutes with him.
You're asking me.
Let me have 3 minutes with him.
Oh, you won't let me clarify
Give me,
it. So of course I'll just
I'm going to play along with you, and I'm going to play along with you. You need to get you need to get to the point really quick. All right, you need to assume that I understand what outer space is. You need to assume that I understand what orbits are, and we need to get to the point really quick. So go ahead. I'm listening.
Okay, so earlier, not with you guys, not with you two, but with other people here, we were discussing this very thing, okay? And we settled on the radius, and we settled on the distance, and so on, and we did the calculations, and then there was pointing out
no measurements, just calculations.
Then they pointed out that yes, we see too far, whatever, the laser and so on. We point out that the laser bends because of the atmosphere. Then they're asking
so you ad hoc because you see too far.
Let me finish. I'm not done. Then they're asking me to prove that the laser bends and so on by showing a laser that bends downwards. Then they ask me to identify down on a sphere. So I tell them that down on a sphere is towards the center. They said no. So then they asked me a citation for that, and I proved that. Down
in order to prove that down towards the
that's it. So
in order to prove that down on the sphere,
it's not curving down. Now, as for curve measurements, we can be on these semantics all we want. It's going nowhere. It's been 5 times that we've explained the same semantics, and it goes nowhere. So we should move on to a better topic, such as what about ring laser gyroscopes, whose reading is constant and never zero?
What about it? So on gyroscopes, when I fly halfway around the world,
ring laser gyroscopes, big difference.
Okay, all right. So what about it? They have to be calibrated like every couple of hours, right?
A ring laser gyroscope is a closed loop where 2 laser beams are traveling in opposite directions.
Yeah, he didn't ask what it was. He asked, do they have to be calibrated?
If the platform rotates, one beam.
How do you calibrate it on a non-rotating surface so that way you know that it's rotating?
First of all,
you do understand that in order to detect rotation, you first have to calibrate it on a non-rotating surface, right?
No, he doesn't understand that.
What? If I wanted to measure rotation, I would first calibrate it against non-rotation, and then I would put it up against rotation.
But that is not how a ring laser gyroscope works. Okay, with a normal gyroscope, not a ring laser gyroscope. I was trying to explain to you what a ring laser.
I know how a ring laser gyroscope works.
I don't think you do, because you're asking me a question that's incoherent, because a ring laser gyroscope is not calibrated in Earth's rotation. It's not. You remove everything out,
calibrated on
and what
Earth,
remains is Earth's rotation.
Perfect Storm, shut up for a second. How do you calibrate something that is supposed to detect rotation on the alleged thing that is claimed to be rotating?
Shut up, you stupid retard! What are you?
Shut up, you fucking idiot! Right. Yeah, back to Perfect Storm. Now you've got a device. Hey, Perfect Storm. Shut up! Right.
Yeah.
The device, the ring laser gyroscope on Earth. Number one, Earth is claimed to be rotating at approximately 15 degrees per hour. Now, how do you calibrate something that is already moving on the thing that's moving? See, what you would have to do to calibrate the device to perfect zero is remove it from Earth. Calibrate it, then put it back on Earth and go, oh look, now we're picking up a specific degree of rotation. How are you calibrating the device without removing it off of the Earth?
Or a simpler method that can be used.
Listen, kid, you talk down to me again, I'm just going to fucking boot you. I don't put up with shit like that.
What's the simpler method?
You remove everything else, and what remains is Earth's rotation. And
what do you remove everything else? What do you mean? What do you remove? Hold on. What do you mean by remove everything else?
Instead of cutting me off to ask me what I'm about to explain, let me.
Okay, he's probably finished by now.
Man. He's just ad hocing further and further away, man.
Yep. How about we just nail this bastard now? You've got 2 minutes to provide either a laser bending down or Earth curve measurements, or we just leave you on red flag. I like that idea. Anyone else got any other suggestions?
Leave him on mute until he provides it. Meanwhile, he fought with you about down is towards the center of the Earth. Now, if you level a laser on a globe Earth, and you shoot a laser beam horizontally, and he said that it would go straight if unaffected by the atmosphere. So if it's curving in a manner which makes the off angle of the horizontal decrease towards the surface of the Earth, that would be going down in altitude. And since his only explanation for down is towards the center of the Earth, that means the laser would be curving down. So he fought you that the laser's not curving down, but then he proved in his own worldview the laser has to be curving down. So he thought he had a victory there, but he actually didn't. The only other way for him to think about it is to say that the laser isn't curving. You follow that? Because if the trajectory of the laser, if the trajectory of the laser is expected to be straight, but the trajectory is curving towards the Earth, then it's either going down from the horizontal frame of reference you established, or it's going down towards the center of the Earth because it's decreasing from its previous trajectory. So it's going down. In both views, it would be going down. So he's just simply wrong.
Well, my thing with these lasers, if this was such a common event, surely someone would have either photo or video evidence of these lasers just following the curvature of the Earth. It'd be an everyday occurrence.
Well, fair enough. But if he's saying that this is what down means, and this is what would be happening that you would call down, but it's not going down, then he must be asserting that it's going straight the entire time. So it's not curving, yet it's following a curve. That would make his position incoherent.
So he's just.
So in other words, he believes. Yeah, he believes curved lines are straight. That's basically what he believes.
So for the ring laser gyroscope, number one, what calibration actually means for a ring laser gyroscope? Calibration is not setting it to read 15 degrees per hour. That is not what we were claiming, my friend. Calibration means zeroing electronic offsets, measuring scale factor, hertz per rads per second, removing thermal drift, removing mirror imperfections and backscatter bias, None of these steps assume Earth rotates. Number 2, step by step. No hand waving. A, zero offset calibration. Put the gyro on vibration isolation. Rotate it slowly back and forth mechanically. Average the output. Any consistent bias cancels out. This removes electronics and cavity asymmetry. Earth rotation does not cancel because it is unidirectional. C, thermal calibration. Change temperature deliberately. Measure how output shifts. Compensate for it. Temperature effects vary. Earth's rotation does not vary with temperature. And that's what he sent me.
Well, if Earth's rotation doesn't vary with temperature, then how come the Russians did a test with a gyro in a supercooled chamber and they got a different rotation rate? How come when Scott Odell?
How are we doing today?
Hey, hello. Somebody's speaking. Wait your turn. Thanks. All right, go ahead.
Yeah, imagine walking into a room where somebody's talking about something important, and then you say, hey, I'm in the room now. It's such a rude thing to do, man.
No, this was a sign of being respectful and acknowledging the presence of everyone in the room.
Well, you don't do it when somebody's talking, right?
Here, let's stop talking about that. Listen, friend who thought it wasn't important to interject. Do you have a point to make, or did you just want to announce your presence? If you just wanted to announce your presence, go back on quiet. If you wanted to talk, I opened the floor to you. Go ahead and talk.
Sure, I would like to ask you, what's the proof for flat Earth if you guys want to talk about it?
Yeah, sure. That's a good question.
Thank you.
So the Earth is covered in water. Water is the gold standard throughout all of human antiquity, defining the term level. Okay? When you go and measure water, it measures to be flat and horizontal. All the surface points between two parallel planes. And since the height of everything is off of sea level, and it extends across 70% of the known territory of the Earth, that means the highest mountain, Everest, to the highest trench, the Marianas Trench of the ocean, right? They're all between two parallel planes, reference to the horizontal sea level. So the Earth is arranged horizontally, and the water is flat and extended horizontally on the surface. So the Earth is flat. There you go.
Thank you for your answer. That was an interesting perspective.
Right, and now notice how I said you measure it flat. One such method you could use is lasers. You could take a laser, that's what we were previously contending about before you joined, and you could measure a piece of water that would be sufficient to the task, get the laser, get the measurement, and discover that it's not a globe, that it actually is horizontal. And then you could extrapolate the physics of water across the known territory, which is 70% water, and therefore all the water is flat, because it's the oceans are a contiguous body of water. Yes, they have sea level rises and falls, sure, but they're all between two parallel horizontal planes with no curvature commensurate with the globe that the heliocentric model claims of a radius of 3959 in miles, or 40,000 40,000 circumference in kilometers, right? So the curve of the water doesn't match what they claimed. In fact, it matches nothing in between point A and point B, because the laser, when you shoot it across from one spot to another, it hits the target pretty much every time, which debunks the globe by 2 orders of magnitude. So in other words, the globe is expecting 300 feet differential, but we get within the 10-foot differential.
But my question to you would be then, if the Earth is flat, then why is it that people of certain countries experience night in their region, whereas people of other countries experience daytime?
Yeah, sure thing, no worries. So this question has an assumption in it that if the sun was above the Earth, it would light up the entire Earth simultaneously. Now, all I have to do is remove that assumption, and then the conclusion of why it would matter would be insignificant. So, for example, whenever you're in a big building, they have more than one light. We know everywhere we go that one light isn't sufficient to light up everything, unless it's bright enough, right? And unless it's bright enough, able to penetrate the ambient atmospheric conditions, and able to reach all points on the surface. Now, if the sun is simply not powerful enough to saturate the entire Earth simultaneously, then that would be why you see different amounts of daylight wherever you are, because the sun moves around. So the sun, we see it above us, and then it moves away from us. And it keeps moving away, and then it gets darker and darker and darker the more it moves away. So it's reasonable to assume that the sun moves around and it takes the light with it, or the light follows it. Either way, you end up with, you're standing on a flat horizontal surface, as proven by flat water, and the sun just moves around above our heads. There you go.
Oh, okay, you don't believe the sun is large enough or luminous enough to light up an entire region of Earth if the Earth was flat?
Oh, dude, listen, I live in a mountainous area, and the sun can pass from noon to midday, right? Or mid-afternoon, and I can't see the sun. So the sun should be seen by my eyes, but I'm looking through the air, and I can't see the circle of the sun because it's not bright enough to penetrate the ambient atmosphere. So even during the day, the sun can disappear. Now, is there still some light around? Sure. But the sun is still relatively above my area. But now when it goes over to the West Coast, further away, thousands upon thousands of miles away, versus hundreds upon hundreds, and now I can't see it anymore. Now, we know that the air is full of particulates, and it has scattering and diffusion and all these types of things. Like, for example, if you go down in the ocean, I think it's only 40 meters. I think if you go down 40 meters in the ocean, you can't see any light. Why? Because there's something in between you and the sunlight. And the same thing happens with the atmosphere. And again, you'd have to assume that the sun was powerful enough to light up the whole Earth anyway. So I don't have any reason to assume that the sun would do that. The only reason people do is because they're imagining the sun as this giant ball that's shedding light in all directions with the heliocentric model they've been taught. So in other words, they're confusing what they've been taught and told is true between what they actually experience.
I see. I think you have a point. If you have that kind of a model, but then my question to you, follow question will be regarding the star patterns which are differ. The southern hemisphere sees different stars than the north, like the Southern Cross, and it's impossible on a flat disk. How will you?
Oh, no, it's not.
How will you?
No, it's only impossible. It's only impossible if you make certain assumptions about the nature of the stars, which are carryover assumptions from the heliocentric paradigm you've been taught. So what you need to do is take the heliocentric paradigm you've been taught, put it on the side for a second, recognize that the Earth measures flat, therefore it is flat, and therefore you have to reinterpret everything in the sky based on the fact the Earth is flat first. You can't mix the two worldviews. You can't say, well, if the Earth was flat, then why isn't it a globe? Because I was taught it was a globe. Like that doesn't even make sense. You have to say, if the Earth was flat, why would the sky, which is not the Earth, which is not attached to the Earth in any way, and we can only see it, why would that change the physical form of the Earth? The answer is it wouldn't.
I see.
So for example, in my house, in the kitchen, there's like an island, right, where you can sit and eat food. And above that is a light fixture. And there's actually 4 bulbs in that light fixture. Now, if I go to Home Depot and I buy a 6-bulb fixture and I swap it out, did that change the shape of the island? No, the island is still flat. Nothing that I do to the lights above it are going to change the physical structure of the table underneath it.
I see. Very interesting. But I have a question then. From explanatory point of view, you're flattered with another kind of model compared to globe Earth. How much more explanatory power does your model have? Meaning, how
absolutely.
Phenomena can it explain compared to, let's say, a round Earth model or a globe Earth model?
Sure. So baked into that question is the assumption that more explanations for more phenomenon equals more veracity, but that's not true. The only thing that actually results in veracity is validated explanations, not just simply possessing explanations. So, for example, the globe has all these explanations about how the Earth fits into the cosmos, like you described with the stars. But that fitting in, that explanation requires the Earth to actually be a globe. But when you measure the surface, it measures to be flat. So their explanation is proven false. So the flat Earth doesn't rely on the stars. It doesn't rely on the cosmos. It just relies on the structure of the Earth. So the explanations about what the sky is doing are not contingently linked to the shape of the Earth.
But for a model to be a good model, it should be able to explain observable phenomena.
No. See, here's the problem, dude. Is the heliocentric model is not a model of the Earth. It's a model of the cosmos, which includes the Earth. The flat Earth model is a model of the Earth, which excludes the cosmos, because the Earth is an object, kind of like my house is my house and it's not your house. And whatever my house is doesn't make your house what it is. So the Earth is the Earth, the stars are the stars, the sun is the sun, the cosmos is the cosmos. Whatever the structure of the Earth is, has no bearing on what the cosmos is. Now let me submit this to you, my friend. No one in the history of mankind, except in religious texts and fantasy, has ever been to the stars. No one. NASA has never been to the star. The astronauts have never been to the star. People on the ISS have never been to a star. Katy Perry, though she is allegedly a music star, she went up real high, but she didn't go to the stars. No human has ever been to the stars to validate anything about the cosmos. Everything they think about it is a story. That is all it is.
I see. But not being able to or not going to the star, how does it have to do anything with the Earth being round or Earth being globe?
Exactly, my friend, exactly. How does the stars have anything to do with the physical shape of the Earth? Now you're starting to get it. They have nothing to do with the shape of the Earth. The Earth is what it is, regardless of what the stars are.
Uh-huh.
So, for example, the stars could be giant balls of fire. Sure. The stars could be an angel singing in a celestial liquid, of which their singing vibrates the liquid and then creates the sonoluminescent light that reaches us. The stars could be giant farts from Cthulhu, the spaghetti monster. It wouldn't change what the shape of the Earth is.
Would you say that our flat Earth model can can make some predictions, like a scientific
Absolutely. Yeah, absolutely. 100%. 100%. I'll give you one.
Can be tested and
Yep, sure. Yep.
Can you give me some?
Right. So the flat Earth model predicts that there's no demonstrable curvature of the Earth because it's flat. So when you go out and you measure the Earth, you find no demonstrable curvature, proving the flat Earth model correct. Now, once more time, friend, I just got to remind you, I told you that the flat Earth model is not a cosmological model. It's a model of the surface of the Earth. And any way that you can practically model flat is all points on the surface within two horizontal parallel planes. Okay? That is the demonstrable, physical, mechanical, attainable definition of a flat surface that's horizontal. That's the only way you can do it. Now, the globe Earth claims that the points on the surface of the Earth are curving in a big circle and coming back around on themselves, and not between two horizontal planes. But when you go out and measure it, that curvature that they claim isn't there. So the only flat Earth model that exists is the model of flat, which is the surface that we can measure.
I see.
Now, don't get me wrong, friend. Many flat earthers have ideas about how the cosmos and the stars and the celestials work relative to the surface. Sure, that's fine. The problem is, just like with the globe Earth paradigm, they cannot go to any of those objects to validate their claims about what they are, what they're doing, where they are, where they came from, or where they're going. So again, they're in the same camp that the heliocentrists are in, which is in fantasy speculation land.
Mm. Mhm. Regarding gravity, if Earth was flat, like you claim it to be, or other people claim it to be, gravity would pull towards a central point,
No, not
not pull
necessarily
down
the case.
everywhere.
Okay, this is again, you're mixing worldviews from the heliocentric view to the flat Earth view. So you're saying, well, if gravity exists, it must exist the way I've been told it exists. Well, if the Earth is flat, then the way you've been told it exists isn't necessary. So all you need for gravity to work is just to have a universal down. Now, if you insist that gravity must pull towards the center, that's fine too. All you need for a flat Earth with gravity pulling towards the center of mass is to have a distribution of mass which varies out the field lines so that they're essentially perpendicular at the surface. So all you need is a quote unquote surface of the Earth that is not super thin. It just has to be thick, deep, and have a mass distribution underneath it. So there's nothing wrong with the conception of gravity in the Earth being flat. In fact, my friend, if you go outside right now, or if you go down the street, or if you go to your friend's house, or if you come to my house, or you do it right now, just drop something, you're going to witness it go towards the Earth, down. Now, everyone experiences down. So I could just assume that whatever is making things go down is perpendicular to a horizontal plane, because I've already established the Earth as a horizontal plane of reference across its entire surface, which is covered in water, which is the definition of the level surface. So if gravity is anything, friend, it proves the Earth is flat. Because we all see things go down, no one ever sees, no one has ever witnessed, no one has ever experienced something going inwards to a giant ball. We only experience it falling down perpendicular to a horizontal plane of reference. That's all we ever experience. You, me, your mom, your dad, your grandfather, and your kids.
Interesting. Well, I think that kind of ends my questions. I think you have
Yeah, no worries,
answered.
brother.
Yeah, thank you so much.
Yeah, thanks for being respectful, and thanks for my team for not jumping in on any of those words, which might have taken us offline.
Yeah. Okay, thank you. Take care. Bye.
All right, so he'll be, I don't know if you left, brother, but if you didn't, if you have a question in the future, come back and ask us. Just come back with the same attitude you had there, inquiry. You don't come back saying, hey, I got you because I found this piece of evidence. I don't think you're that way. And hopefully no one will treat you that way when you come back. Cool. All right, next victim. I mean, next participant. So did our previous homeboy post what he was supposed to post yet?
Fail so far.
Nope, still waiting.
Oh, he did post while I was talking to our friend there that you have epistemology and ontology. And so you can determine what a star is through epistemology and ontology. Okay, so ontology is the nature of what something is and its existence. So how would you know that without being able to validate it? So he's saying he can get a long-range ontological sensor device, reach out and grab the star from its emissions towards us and be able to determine exactly what it is without ever going to the star to validate it, and then dogmatically say, now I have epistemology, which means knowledge. So I can make a claim about the ontology of the star based on something that I'm assuming from my local range, extrapolating it out via uniformitarianism to the distant range, and then make fundamental claims about things without ever having the burden of proof to validate my claims. Yeah. No thanks, brother. Sorry. Oh, by the way, brother, when they do that spectroscopy from the stars, right, and they do spectroscopy in a lab, and then they try to say this is what the star is made of because of the lines in the spectra. The problem is, friend, that the sample size in the lab is bigger than the accurate sample size of the star. So in a lab, in order to be accurate, they need a certain parts per million or whatever. Just for sake of argument, let's just say they need 50 parts per million. But when it comes to the cosmos, they're getting 3 parts per million. So they're claiming, let's see, well, 50 times 3, what's that? Like 25, 20 times? They're claiming 20 times greater accuracy of sensor ability to something that's light years away versus something that's in a lab. And you are eating it up ignorantly. Hey, you know what, friend? I'll tell you what, bro. In my truck, I carry a purple book, okay? And the book has a title on it, and the title is Spectroscopy. Now, I guarantee you, you don't carry a book around in your glove box that says Spectroscopy on it. So I'm clearly the expert. Now, you may ask, why in the heck would you just be randomly carrying a book called Spectroscopy? Well, I also have another book that's all about the human dimensions when you're building things. Like a man and a woman and the average heights and stuff, sitting in a chair, sitting at a desk. That's one of my reference books. I also have an electrical book. That's in case I need to do any electrical or, sizing. Ergonomics, that's what it's called, ergonomics. Sorry, I was going to say calisthenics, but that's exercise. So you may ask, well, why do you have a spectroscopy book in your car? Well, that's in case I ever get in an accident, you see. That way, when they ask me, what did you see? I can give them the spectral analysis of the other car. And I can say, yep, it was a Chevy, white, and here's the spectra. But do you know what? That wouldn't fly in court. Do you know why, my friend? Because the expert witness would say, was it done in a lab with certain tolerances? And I'd have to say no. And they'd say, well, then it's beyond the tolerance of the sensitivity of the machine. So how can you make a positive claim about what you saw? And I'll say, oh, well, if people can do it about the stars, which are trillions of miles away, then I could do it about whatever I want to. There's light bulbs that exist on the Earth, which have dual layers, and the thing inside it excites the layer on the outside of it. And then the spectra that's coming off is what's going on the outside layer, not the inside layer. So a spectrometer can't even tell what's on the inside of a light bulb on Earth, let alone something that's a light years upon light years away. I mean, get out of town with that nonsense. I gotta go on mute. I gotta get out of the cold weather. I'm about to freeze to death.
Right, so Stormchild, have you got proof of your laser bending out in the open air in a downwards direction in order for it to match the alleged curvature rate of the Earth? Or
can you give me the definition of the word
curve
proof, please?
measurements? I hadn't finished, but thank you for talking through me, Mr. I want to have a decent conversation, who was crying about someone else censoring him. So, have you got one of those two things?
Before you,
have you got one of the two things you were asked for half an hour ago?
So, can you get me the definition of
yes
the word
or no?
Can you get me the definition of the word proof?
Yes or no? I don't have to supply definitions. I'm asking you to supply something. That doesn't involve me looking up a dictionary.
Can clarify and understand exactly what we mean.
Clarify? What in your feeble little mind needs clarification?
The definition of the word proof.
The definition of the word proof. Well, I need the definition of the word definition, so clarify that first. See how retarded this gets?
I will.
Go away, little boy. Fair dinkum. I did read up earlier that he doesn't have hands. He's another one of those blitz-following clowns.
Hey, listen, anytime someone asks you for a definition, just cite Roofy. Definitions are meaningless.
Oh, shit. Oh. But where does it stop? We could just sit and define words all day and then lose the point of the whole conversation.
Yeah, bro. So he wrote to me, if you don't trust spectroscopy and claims about things light years away that can't possibly be validated in the first order, then you can't trust that you have hands. Like, good grief, dude. How are you so dumb that you don't realize that something that's local, tangible, accessible, experiential, like your hand, is so different than something that's light years away that you have a bunch of conjectures about? How do you not understand the difference between those two things?
No hands, something that's allegedly a long way away.
I know, dude. Like my hand is attached to my body physically and continuously. That means I can put my one hand on my arm, run it down my arm, and reach my hand. I can feel every single digit. Right now, my digits are cold because I'm out shoveling snow, and I took my gloves off, and my thumb is now cold. So this moron thinks you can't even know that you have a thumb that's feeling cold because you don't believe that a star is what I say it is, a trillion, billion, jillion miles away. I mean, get out of here, dude. Like, you're not even on the same level of intelligence here, dude. Using words like epistemology, trying to guise that you know what you're talking about, or even have a semblance of a point. How do you know you have hands? I don't know, dude. I think this room is too traumatic for you, and we're gonna have to do a Mercy Health wellness ban so that you can go and seek therapy. And ask your psychiatrist when you get there. I don't know if I have hands or not, and they'll be like, "What would ever make you think you don't have hands?" Well, someone said that they don't believe in what the stars are claimed to be according to alleged science, and so then I had to regress into I don't have hands, and now since that mind worm infected me, I'm starting to doubt whether I have hands or not. Can you help me, please? And so the guy comes over, takes his letter opener, comes over and pokes you in the hand with it, and you go, ow. And he goes, there, you have a hand. Now get out of my office. That'll be $700.
Cha-ching. I thought you were going to say something else. This is a left, whoosh, and this is a right. Whoosh. That'll be $650. Oh, no way.
Dude, this dude needs to go into AA program, 12-step program, Appendages Anonymous. Hey, so how they start the thing is, oh, welcome new people. This is a place for people who may or may not believe whether they possess appendages or not. So anyone who thinks they don't possess appendages, raise your right hand.
The 12th step is to do the hokey pokey.
Yeah, think about it. Yeah, bro, think about it. Like, forgive me if I doubt that people can get a definitive claim of what a star claimed to be light years away is, based on a tolerance of censorability that is much lower than what they can actually manufacture with a lab specimen. Forgive me if I don't believe you, but I believe I have hands. I mean, come on now. This is where you have to retreat to. If the Earth was flat, I don't have hands. There you go. That's his basic rebuttal.
Well, so our young friend was either showing us lasers bending in the open air in a downward fashion, or he was providing us with Earth curve measurements, and he's still yet to do so. But he's asked for quite a few other things. Definitions of the word proof. I don't know why that's required, but yeah. Had a little cry about being muted. We just want the measurements, mate. That pretty much sums it up, like, to be quite honest with you. If you dropped Earth curve measurements on us and went, ta-da, there it is, repeatable, verifiable, observable, go do it yourself, have a lovely day type measurements, then yeah, you'd probably take the yap out of quite a few people. But since you can't, we'll keep talking. So, and he's sent me a laser bending downwards in a tank of some kind of liquid. Okay, what part of the open air did you miss, my friend? I'm pretty sure I did say that, out in the open air. But I will post it up so everyone can see it, because I'm not horrible sometimes. Bending of light, laser science experiment, Taras Kull. Oh, it's a YouTube thing. Awesome. Copy. And paste. That is what he sent to me as proof of lasers bending downwards in the open air. Yeah, Morbicide, yeah, don't go there. Open air must mean we all live in sugar water or something now. I'm not sure. Maybe he's got it in his head that we're saying lasers don't bend. I never said that. I want him to provide us evidence of lasers bending downwards following the alleged curvature rate of the Earth. Because that's what we should be seeing if they're bending downwards. Maybe just to give you an idea, young Perfect Storm, of how much they're supposed to be bending, over about 10 miles, I think it's about 66 feet you should be looking for. That's about a 7-story building. 20 miles, it's about 270 feet. 30 miles, about 600 foot. 40 miles, over 1,000 feet. So that's how much these little lasers of yours that you're claiming naturally bend, that's what they should be bending to. And there's a bit of an issue when the boys and girls go out and do these laser tests. They're not following those kind of rates. Not even close to it. Oh, so your claim, here we go. To answer your question, since too afraid to unmute to hear it, no, it's not that we're too afraid to unmute you, it's just that we really don't want to. Bending in air occurs over longer distances, to which, unless you can have a camera clearly see a 20-mile laser, good luck. Okay, so that's your claim. So you're claiming none of this is possible to see. So therefore, if it's not possible to see, how are you going to validate or verify it in the first place? So well done. What was asked was a laser bending downwards. Yes, in the open air. So thank you for omitting very particular components of my sentence. To acclaim, mediums make lasers bend. Oh, so what you're doing here, this looks like you've looked up AI and you're very selective about what sentences you pick out. Air is a medium that is known to bend lasers through large-scale experiments that you're free to look up. Well, you could post any one of them if you wish. Your maths are wrong here. What maths? As you increase the miles, the curvature drop does not accumulate. Hold on a minute. The curvature rate does not accumulate over longer distances. So you're saying that every time, if I go 1 mile, it should be 1 foot. If I go 2 miles, it should be 2 foot. If I go 3 miles, it should be 3 foot. Where do you get these crazy assumptions from, boy? Where's my drop chart? Drop. Loading, loading, loading. I want that one. Come here. Oops. Back to the English hub. Come on, hard drive, spool up. That's the one, plain and truth. Thank you. So if I be clicking on that and make it bigger so I can read it. 1 mile. Where's 10? Get it to 10. 66 feet. 20. 266. 30. 600. 40. Over 1,000. Yeah, that's getting bigger. Maybe young Storm Child or Storm Chaser or whatever you want to call yourself today. Maybe you should type into AI and see what the alleged curvature rate is and how to calculate for it before you go telling someone they're wrong. How about you look up the information first and then have at least something to back up your shitty claims? Because seriously, that was weak. I think that's a lot of the problem with these younger kids. They all are using AI these days to do the thinking for them. Misinformation spreader. Yeah. It's only collecting information that was put into it. I was actually looking something up the other day about computer parts, and DeepSeek actually come out and said my database is only updated to, it was October the something. So, yeah. Oh, what's this kid posted to me now, which he couldn't post in main chat? Understand the difference between cumulative and non-cumulative. Also about AI, I'm not using AI, I'm using my brain. No, you're not using your brain. Because if you're using your brain, you wouldn't be in here complaining to us. So why do I need to understand the difference between cumulative and non-cumulative? And you can post it up in the main chat, not my DMs. So just delete, 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 DM. Just so you know, typing stuff into my DMs is not going to help your level increase on the main channel. which is what you need in order to post up links and things. So, what's this? Disagreeing with your position is not a lack of use of brain, moron. Well, yes, it is. Because all you're saying is, nah, I disagree. And then when you're asked for your evidence on why you disagree, you have a little meltdown and don't provide anything. So we are now at 12:17. It was approximately 11:40 when you were asked to provide your data, and you still have not. So we can only come to the conclusion that you don't have any. Okay, such as pointing out you're using cumulative drop rates on a sphere without a cumulative drop rate. Gotcha. Okay then, I've got no problem with you saying our calculations are wrong. How about you provide us with the correct calculations so we can calculate drop over distance? And if yours are more accurate, I am more than happy to switch over and use it. And I'll tell you something now, if you've got something that's more accurate than what we already use, according to the Baltardia model, then I'm pretty sure quite a few other people would be very appreciative of you providing something that's more accurate. Yeah, Trinity, I also find AI awesome for how-to things. Cooking, doing homebrew, that got like hands-on type stuff. It's pretty good for that. But when it comes to logic, nope. That's just a fail there. Oh, so what's his claim now? So when pressed for a better calculation or methodology of calculating, well, here's the thing. No matter where you'll be taking your measurement, you'll have the drop rate relative to where you are. And even at the extension of 100 miles, the drop rate at 100 miles is relative to the 99th mile. So that's why it's non-cumulative. And that's why a laser through the medium of air will bend along and follow, such as shown in the diagram showing what happens in non-cumulative drop. Okay, so basically you've said fuck all in a lot of words, kid. You're making excuses to why you can't provide, number one, photographic or video evidence of a laser bending downwards in the open air. So that was a fail. So we're just going to assume you're a numpty there, or you're just a liar. Either way, you're going to brand yourself, so that's cool. I'm good with that. Number two, you were offered to provide measured drop over distance, which you are yet to provide. So you're claiming you can go out to 100 miles because 99 miles is equivalent. Okay then, fuck it, 99 miles. We'll make it easier for you. If they're the same, one and the same, then provide. Stop filling my DMs up with shit. And I'll show you how I'm going to fix that. Scroll to the top, block. Now I don't have to put up with your shit. So you can post it in the general chat like you were told to. Yeah, I've noticed a bit of that, Trinity. It lies and then we'll say sorry and then lie again. Yeah, very common. And even twisting its arm hard enough the first time to get it to admit that it had lied, sometimes is a mission. What's he got here? Video or image of laser bending down in the open air. Yes, that is what's requested. The laser will follow the same curve drop. Well, that's a claim that you have to validate. So you're telling us lasers bend due to the atmosphere. I've got no problem with you making that claim, but if that's true, we should be able to film it or video it. Quite openly. It shouldn't be anything to hide. It's a very simple request. You seem to think I can say dumb shit and not have to back it up. That's what's going through your mind at the moment. I can make whatever claims I like and not have to back it up. You're claiming the Earth curves. You're claiming lasers magically follow the atmosphere, comporting to the exact same curvature rate. Okay then, now provide photo or video evidence of lasers doing such. Up to you. If this is a common occurrence and that's how lasers work, any second Muppet can walk out in the street with a camera. Oh, there's a laser. Clickety boom. Done. Here's me photo. There you go. Flat Earthers, have a nice day.
Assalamu alaikum, everyone.
How's it going, man?
Hey, bro.
Hey, bro. Yes, what's going on?
How are you?
I'm fantastic. And yourself?
Oh, I'm fine.
You're fine. That's a dangerous word. If you have a female that says fine, best of luck.
Fine. Yeah.
Oh man, gold. So what brings you in here today, my friend? Did he run away? T-Dub was here, I'd blame him. That's another claim there, young storm chaser. Have a listen to this shit. Your own observations with the laser going too far past the horizon and seeing the shoreline where we shouldn't directly proves that the laser is bending. How does that prove the laser is bending? All you're going to claim now is that's a matter of perspective. From my side of the fence, I'm going to say that proves that we live on flat ground because we can see the bloody shore. So what you have to do now is in the open air, validate, verify or prove that the light is bending. You have to do that. Not me. You. That's your claim now. So you're stuck with it. So you're claiming that, what's this? Seeing the shoreline where we shouldn't directly prove that laser is bending. As the maths state, this should block, but this doesn't block. And that's because it's spherical geometry. Well, I don't give a fuck if it's triangular fucking mathematics. Whatever type of mathematics you're using doesn't prove you're on a sphere. Using spherical geometry or spherical mathematics doesn't instantly validate you're on a sphere. You have to get out your ass, go outside and measure the bloomin' thing. That's how we know what we're on. That's why these guys say it's flat, because there's no measured curvature. You just don't want to accept that. You understand what we're saying, but it's just, nah, I don't like that. Oh, so at least he's admitted there's no direct imagery. Well, if there's no direct imagery of what you're claiming, how can you make the claim? Are you just assuming, taking wild guesses? If it'll make you feel better, there is one lot of video evidence that I have seen, and we've done a little bit of looking, of a laser bending upwards. We are yet to find one bending downwards. But in your mindset, what you're seeing is when a laser is flat and straight, to you, that means it's bending downwards. That's what that means to you. So if that's the case, what the hell did you show me that thing in the sugar tank for? What is it doing? If one that's flat and straight is down under your imaginary whatever you're doing. And then he tacks on the end of it because of distances. But we have the measurements. No, you don't. And I know this because you would have provided them by now. You have no measurements. Maths, well, without your measurements, your maths means sweet FA. Data, no, you don't because you would have provided it. Applications. What applications? Things being level, flat, horizontal, that you build upon, fly across, sail across, navigate across. Yeah, a lot of applications. Good on you. Data from multiple points. Well, you've yet to provide any data from any point. Light dynamics. Well, you were offered earlier to ask what the Rayleigh criterion is, and you chose just to completely sidestep that. So, yeah. All things can easily look up instead of begging me to flood you with 100 papers on how lights and lasers work. I didn't beg you to flood with anything. I asked you for singular, one photographic or video evidence of a laser bending downwards in the open air to validate your claim of lasers bending downwards in the open air. That's not hundreds of papers on lights and lasers. That's just one video, a YouTube video, anything. And you've provided nada. What's he got here? There's no direct imagery of my bones. What, so you've never had an x-ray before? Sounds like you need to get out a bit more, kid. I don't think this kid gets it. The problem with your question is, no, that wasn't a question. That was you validating your claim. Your claim of lasers following a curvature rate. If that is the case, that means lasers bend downwards. If that is true, then there would be photographic or video evidence of these lasers bending downwards. Well, now he's hitting us with a logic. Premise 1, lasers bend inside mediums. Premise 2, water is a medium. Yeah. So we're talking about lasers in the air. Don't know what the requirement of the water section was. Anyways, premise 3, air is a medium. 01, lasers observably and significantly bend in water. Lasers bend inside mediums is confirmed. We're talking about air. Air also being a medium means lasers bend in air. Oh, so you're asserting that because lasers bend significantly in water, therefore they do the same thing in air. So how are you going to validate this or verify these little logical crapstain you've got here, boy? So yeah, you've still got your own back to the I have to validate this or verify it or prove it. You just making open air claims means nothing to us without the data that you were whinging about earlier. You're just a keyboard cowboy. That's all we see here.
Bro, you want to know what's funny about that laser curving at the exact same rate that the Earth is curving?
What's that, man?
I was saying they're stuck in the same conundrum. They would have to measure a drop over distance in the laser.
I know that. You know that, but he doesn't.
So you can't measure the Earth curving.
So look, have a look at this. He's gone, nope, read it carefully. It's not saying it acts the same in air. I didn't say that. Start listening, boy. It states that lasers bend in mediums. And you're assuming air is a medium. So because lasers bend in a particular way in sugar water, therefore they must apply the same rules in open air. That's what you're asserting. Not me, you.
And don't forget when
you're the one.
Don't forget when they do.
Oh, sorry, AJ.
They also shine the laser from the outside of the tank where it first passes through glass. And
correct.
And then the water.
So air to glass, glass to water.
It's showing Snell's law of refraction perfectly. It's not occurring in the stratified atmosphere.
So his assertion is because lasers bend in mediums, he doesn't say why or how they bend in mediums. It's just a flat line assertion.
Hello,
and therefore air is a medium, so lasers bend. How's it going, man? Brento, how's it going? No, there he is. Hi.
Hello.
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 Welcome.
Welcome. Hello.
Okay, Stormchild. You're yet to provide us with photographic or video evidence of lasers bending downwards following the exact curvature rate claim of the Earth. You're also yet to provide us with measurements of drop over distance. So these two things would help validate your claims.
Yeah, you know what? Forget Earth curve measurements. I want to see 8-inch per mile squared drop of laser curve. That's what I want to see measured.
Oh, mate's Googling hard.
No, he's just one of these keyboard rats. That's all he is. And then he'll bitch about no one wanting to listen to him. And he doesn't realise he's been unmuted for the last couple of minutes.
Well, you could have told me that.
No, I'm not here to hold your hand. Sorry.